I just wanted to go over this project that we have for electrical, only for our electrical estimating class. We rarely, if at all, do any residential estimates. So I just wanted to make sure we at least did one because, a set of plans is a set of plans, but a lot of times in residential, they try to go on the cheap, and the plans aren't really very good when it comes to electrical because, as we know, that needs to be very detailed, and they don't make them detailed. Okay, so what they typically do on a residential set, they put everything together. Okay, so it's all thrown in there together, and you have to make sense out of everything. Okay, and so the lights are on the same plan as you can see with the power components, and so it's just a little messier. We don't talk about number 12 wire for the home runs. They use what's called Romolex. Let's see if we can. Oh, we don't have the cost book up. We'll do a separate cost book for that for the residential because really everything in residential is more. So you would charge more for the hourly rate. Your fixtures would cost more. Everything would be more. But the main thing about the set of plans is that, yeah, the power components and the lighting components all on the same set in most cases. And again, you just have to take your time and go through everything in detail. And in this case, you can just go room by room or just choose to do all the lights like you would if the set was separate. Just do all of the lights, count all of the lights, and what you know to be the lighting controls, and then try to make some sense of the wiring. Okay. Now, as you can see, just like in commercial with the lowercase letter, that means that these two lights are controlled together, and here's F here. So basically, dun dun here as far as your wire. Okay, and this one C D C E. So that kind of makes it easy. You know where your lights, which switch controls your lights, and so you can use that route, like all the O's. You can use that route. We got an O switch somewhere, three-way switch. So it's going to control three different things. Okay, so that's not too bad. So once we do the takeoff, once you see my takeoff, you'll see. So all lowercase letters all are all together. And in this case, you can, because it looks like here is one of the rooms where you can cut the lights on here or from this entrance. Okay, so that's how, or probably somewhere else too. So yeah, just all mixed together. And this is the only sheet we get, and that's the exterior elevations. Okay, that's what the house looks like. So at least that's the exterior fixtures. Okay, and two bad thing is no. Okay, where is the? Here's the panel, but they don't give you anything more specific than that. It's like, well, got to think about in a residence, how does the power come to the house? It's usually overhead, right? Comes through overhead and then down a pole or something. So yeah, we would have seeing all that. It's existing, so we probably don't even have to worry about it. How is that? Oh, it's not from the ground up. It's a renovation. Who knows? But it is a. We don't care. Oh yeah, it's existing, so that's good. We don't have to worry about that. That's a clue that you don't have to worry about that. All that's existing. All of this is existing. That's existing, and the main thing, the reason why you don't have to worry, is the meter is existing. So we're just doing probably just gutting it. It's probably been gutted, and or they just when they built the track homes, they just put the basic stuff in, and now you buy the house and you get it all put in or whatever. Who knows? customize it the way you want it. Maybe. I don't know. But yeah, so just know with residential, it's not all neat and there's not even a panel schedule. Okay, so with a lot of this, you'll have to guess in terms of, even if you had to think about breakers, well, you would just, uh, you'd have to go backwards, right? Because every outlet's duplex outlet is probably for a home is 15 amp breaker. The electrician will know, but typically for every outlet, you got a breaker. If it's a GFCI outlet, you have a GFCI breaker. If it's the mechanical equipment, you have a 2 pole, 3 pole, where all the other breakers are 1 pole, right? So you have to go backwards, but it's possible. But like I said, when we do this one together, you will see the takeoff. And I mean, in a way, it's easier, but then in a way, it's not. So just know you'll have to look at everything on one sheet. There won't be a lot of, there may be a lot of site work, may not be in this case. It is lots already existing. So if you have any questions, please email me at education@sfjohnsonconsulting.com. Otherwise, I will see you at the next class. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and this is a new one for our estimating class and for estimators, electrical estimators only. And we're going to be reviewing, this is just an introductory review to our Chase Bank that we're going to be preparing. It's a Chase Bank from the ground up. So not a very big bank. So we see the lighting plan, pretty straightforward, pretty clear, nice. Not a lot of keynotes. Well, on a lighting plan, we don't have very many. So we know that there is a panel called PP1, and that's where the home runs for the lighting plan are going to go. And if we're lucky, they'll show it on the lighting plan, but typically they don't show any of the panels on the lighting plan, even though it is for the lights. So, you'll be able to find it, or you may. Probably not, but it is on the power plan. Here's the site plan. This is kind of weird. Looks like they're going to have it go right over the building, because if it was underground, it would probably be a broken line. So that's kind of odd. Like this one is broken, right? Underground, oh, it's far away. It's quite some ways away from the bank. That's the underground, the secondary. Okay. So we'll have to look at the single line diagram to give us what that is. And then the power plan, roof plan, all the disconnects. Got to make sure we know, again, as always, the wire configuration for the mechanical. We have a switch that can turn on a motor. So we got to make sure we have all the right ones for that. I don't know. It may come with the equipment, so that's something we need to check and find out. We won't have to look at the specifications with this one. I didn't include it, but on the ones coming up, I will give you we have a hotel coming up, and you'll have all the specifications. You got to read through those. Okay, and so here we have a drive-through with some, I'm sure, and we know that it is the break off, right? So it's underground. That's also going to be underground, but they don't show it as being underground. The home run for see what. This has a lot of keynotes, 4, 5, and 6, and a lot of just stuff. Okay, so yeah, 1 and 1 inch PVC underground routed to panel PP1. So always make sure you have for the transition from underground to above ground. And here are the panels. Panel PP1. And then that's the drive-through. So yeah, we're going to go underground, and then at some point, because this is from the ground up, you may stay all underground and stub up, or I'm not sure. So that's something that we'd have to look in more detail. Most likely, maybe because they show us this, that this stubs up into the building where this remains underground because of the. So that's a lot to look into because you want to make sure you are close to using the right conduit. Because if this has to be underground at some portion, I mean, it's going to be because of the distance from the building. So I'll just assume that this all is going to be PVC conduit until it gets to the building. Then we'll bring it up into do over there. All right. And then a lot of details. See where our single line. I might have. Okay, so they have it like this one line instead of, they have it vertically instead of horizontal. It's okay. Same thing. Utility transformer outside the building, right? So we just have to find the distances in real time, pretty much in real life from the power plant and include all of that. So that's weird that they have the single line vertical instead of horizontal, which we're normally used to seeing. Okay, so this is just a little Chase Bank from the ground up. Of course, we have all the details, so we have to make sure we know, and this will help you with your. We're using 1/2 inch conduit for this, so that's gonna make a big difference. So we normally use 3/4 inch, right? So when we see these keyed on the probably the power plan, we have to make sure we are using the right conduit when we see those marks on the plan. Okay, where the that's good. I rarely see it like this. Where the of course the power is 3/4 inch and the data phone TV 2 inch. That's good. Duplex 2 3/4 inch. Whatever this is. Oh, data phone. Then the floor box. Oh, that's good. 1 2 inch, 1 1 inch, and then a 2 inch. What we got? Okay. Yeah, coming out. Nice. All right. So we can't get confused on the. So what I'm saying is, right, when you on the power plant and you see those things, you see, well, here, now we're going to need a 2 inch conduit to the ceiling for the data phone and the whatever HB was on those details. Let's find it. Was it on this one? HB. Of course, I can't find it again. Let's see. Let's go back. Where was it? Yeah, here we go. HB. And sometimes it's not perfect, but should be an HB somewhere. There was one on the plan. Maybe it's just HB. Let's see. I don't see a HB. It's always a mistake. Let's see if we see one here. HB, HB, HB. Oh, look. HBH. No. HB. Oh, we're getting close. HB. Nope. Yeah, it's a mistake. We'll find it. We'll assume it's 1 inch. Because it sure said, oh, let's see what 15 is. See the stupid stuff you got to do? But you have to do it. Hold up button. Oh, I like banks. Because you find out where all the hold up buttons are, which is good if you're estimator, but you're not supposed to, share the secrets. You know what I mean? And so, yeah, we'll find the conduit, floor boxes for the desk, different stuff. So, yeah, they keep us safe when we go to the bank. All right. So, if any questions on this one, let me know. This one won't be shared in the public because it is a bank. It's just for my students. And If you have any questions, email me at education@sfjohnsonconsulting.com. And to make sure you have at least 2 days a week, okay? Private sessions to go over this stuff, all right? All right. Let me know if you have any questions, and I'll see you next time. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and I am here to talk to you about the project for this week. This would actually be project number 4 for our electrical estimating class, and this is a dentist's office. This is Conroy Family Dentistry, and we're going to do something a little different on this project where you'll have an additional piece of work to do, where I've also included the specifications in with your documentation, and I need you to review the specifications and tell me what the electrician needs to, what does it tell the electrician to do in detail. Give me detail in an email. What do the specifications state that the electrician needs to do? You know, when we do review a set of construction documents, I kind of been letting you off easy by not reviewing the specifications, but we know in real life we have to do that. And so I will have you, in addition to when your takeoff is due, also give me the additional information that is required from the specifications. And so photometric plan shows you how the light is, parking lot lighting is supposed to hit the full parking lot area. That's, of course, nothing we need. And here is our electrical lighting plan. Pretty simple. Bunch of 2x4s, a bunch of dome lights. It looks like, okay, the typical emergency. Okay, so pretty simple. Probably a lot of different, names. And what I want you to do, that this is like you could say, instead of counting individually, three-way switch, you could say that it is a duplex switch, right? It's a duplex two gang switch. You can do it that way if you find that there are a lot like that. That's fine. You can do it that way if you find there are a lot like that. Or you can just do them individually. Either way will work. Okay. That's the lighting plan and the power plan. Okay, so dental offices, we're going to have some underground, some floor boxes, right? And that's a quad floor box. And, of course, dotted lines underground power, and this indicates it comes up, right, up to from the nearest wall into the nearest power, right? So both of these are individual, because you see that they go to individual positions on the panel, right? So it's basically telling you that that's the home run, right? That this one's going to, but it's going underground, coming up individually, right? Because we can run more than one circuit in a piece of conduit, but we're just going to do one for one. And if we see here in the rooms, right, both of these are going to position 16. So what we need to do is do that MC cable trick that they're not showing us here. So you can do it in the most efficient way, right? They're all going to, so it's not showing you MC cable, right? But we know that in our minds, if these are going to the same circuit, it's not like a home run, that we can MC cable them here and here and wherever, right? Because they are going to the same circuit, as opposed to the floor boxes that we see that they're each going to a different home run, a different single position. Okay, so you want to look through all of your rooms now, because we may have multiple rooms, right, that have, because you can have up to six, usually I've seen up to 6 duplex outlets, daisy chain pretty much together, and then home run to this position. So you need to be aware of that. Okay. So when we do the takeoff, we want to see that 59, 59, 59. Well, zit, right? 72, 72 all together. So that's why sometimes you got to go in there and look and like it's like 66 and 68, 64. See, it gets a little crazy. But the whole point, right? Going to the same circuit. So you got to keep your eyes open for that. Okay. So that's the power. You know, the power is always more difficult. And then we've had our mezzanine, and then our roof, right? So we've got our disconnects. We got to make sure we count those. And we know because it's telling us to go into 3 different positions in this panel, likelihood it's not all number 12s, right? So we got to make sure we know where that is. We got to look at the panel. There should be some schedule somewhere telling us the rooftop unit or the mechanical plan power. Okay, so make sure we do that. All the disconnects, all the home runs. This is all on the roof, right? So we have to, in our mind, make sure we give everything an additional 10 feet to go down, right? Lighting and power. And then the single line diagram, pretty big, right? We go from outside. Okay, we got everything in black, unless noted, is something we have to account for. So we see we have the conduit going down underground, then coming back up, right? And then staying up. And then the mezzanine part. So make sure you give an additional, to go up to the mezzanine for the power feeder. And remember, single line diagram, it doesn't tell us anything about distance. It's not to scale, right? NTS. So we have to go on our power plan, find out where all the panels are in position to what we see on wherever, right? And do the measurements. Okay, so this one was the first page. This is our HA panel. All of our breakers, so we know, okay, so here we go. So now we see from the panel our rooftop, our mechanical equipment wire. Some are number 12s, they're number 8, 3/4 inch. Mm-hmm. Okay. And then the next page is all the other panels. Then the lighting control panel, got a whole cabinet for that. Okay, so we have to look in detail to see what we have there and account for it in the material. And we see all number 12, a lot of number 12. So we're going to note, we're going to go back on our power plan and find the X-ray home run and make sure we break that out. X-ray, look, X-ray home run. Okay, and all of the signage, number 10, corridor lights. Got to pull all of that out when we talk about the home runs. Because remember, what we're talking about here is the home run wire. Whatever's home run, right? If we're talking about the wire at the panel, we're really talking about the home run. So we got to make sure that if something says other than 12, washer, dryer, okay, we got to make sure we account for those, and it's not number 12. And look on every panel, copy machine, compressor, vacuum, condensing unit, server room. Okay. So you got to go to the power plan, find where those are, and do the physical measurement from that home run to panel LB or wherever it's going. Details, all of our lighting, so we can see what it is. Sometimes you have to look at the lighting. Uh-oh, nobody's home. Sometimes you have to look at the lighting schedule to sometimes, because you'll think it's an individual light and it's a string light, right? It's a string light. So You got to measure a length. I don't know if that's the case in this one because, I do these and I forget about them because there's so many to do. But you have to look because it'll tell you. Okay, so you have to say recess surface, and it'll say, well, what string or something. And you'll know, oh, okay, I need to measure where I see that, or it'll be noted like something like that on the plan. Okay, also site lighting. Make sure you look at the details of your site lighting. And I got to go back and put a video on that. I don't know, the other one we did, because chances are you're going to need a 3/4 inch ground wire, ground, a grounding rod for each of the light fixtures. So make sure you, where is our site plan? It didn't really give us, those are, okay. So they didn't give us much of a site plan. Did they give the wire? I'm gonna have to look. Maybe we're missing something. Yeah, because that's the plumbing plan. They didn't give us a detailed site plan. That might mean they're already there, but it's on the lighting schedule. So, but this is from the ground up, so they're not already there. So I would have to call the GC. Hey, you want me to just guess? Maybe yeah, that's a light on. Yeah, we're missing a site lighting, so I would have to get that. But we're going to work with what we got. And we'll show you when we do the takeoff how we work with what we got, because we don't have time to call these people and they should have everything we need. All right. So that's that. That's the lighting plan. A lot of lights, lots of lights. Make sure you designate between the regular and the emergency, as it does make a difference. Let's see. Power's a lot of stuff. Underground. Okay, account for two powers coming up from the ground at each one of these dots, right? Because each one of these is a home run, basically. And it shows you whatever 2 is. Lots and lots of notes. Okay. See, underground, you have not only the power, but you also have 2 sets of conduit. So make sure you read that 1/4 inch for the communication conduit. That's under there too. So 1 and 1. That's where we're all, wherever we have that 2, we have communication and power. That's very, very important. Okay, so if you have any questions, email me at education@sfjohnsonconsulting.com. But this is the one we're going to begin this week. And please subscribe and like and all that good stuff. And every month we have now drawings for $100 Starbucks gift certificate, $1,000 estimating credit for any company that listens, and free OSHA 10 and OSHA 30 certification every month. All that is each month. And you get the certification. Although now OSHA, you can have access to all of our study material for free. But when it comes to the live presentations, you need that to actually be certified, right? So you have to sign up and pay for that. But all the educational stuff, all the videos, all that stuff is free. So make sure you join, tell your friends, and I will see you later. Hey guys, thanks for joining me. This is Stacy with SF Johnson Consulting and Construction Services, and we are going to go over the full review of the OT Tennis Academy for our electricians only. And so what we're looking at here is the site plan. Pretty simple. And this is a series of tennis courts, right? So what we're going to have are a bunch of like parking lot light poles, and here they are. We just have to count them, right? And then, of course, all of the conduit is going to be underground, right? And it's going to be PVC. And so just make sure we follow the notes. And in some cases, it's going to give you, right, it's going to tell you the home run. It's not number 12s. Okay, typically when it's that distance, and for our lighting, it's going to be number 10. Okay, and so keep that in mind. So what you have to do is make sure you know where the uh, the panel is, where the main distribution panel is, with reference to the court. So it will be somewhere. You're going to have to look at the building, right? Look in the building. Oh, it's right here. I didn't want to tell you, but I just told you. Okay. So here, this is where it's at. And, this is pretty simple. So this is the site plan. Everything is pretty well outlined. Make sure you follow all of the keynotes. Okay. And allow for transition from PVC to either rigid or EMT, depending on where it's coming in at. Okay. And the power plan and lighting plan all on for the building, all on one thing. It's a nice, neat little plan, right? It's really simple. You can't really mess up, right? Just do your counts correctly. If you have a good counting tool, you're not going to mess it up. And two, make sure you distinguish between the emergency fixtures and the ones that are not. Okay, because they cost a different price, they're different, everything's different about them. Okay, so make sure you do that. And pretty simple for our power and communication. Your junction boxes where they're needed. Make sure you do all your home runs. And you know that unless it tells us something different, it's all going to be number 12s. Follow all the keynotes. Okay, and last but not least is our all of our panels. Okay, and so just make sure you get all of your breakers correct, and make sure you know how many positions in the panel, because the labors, depending on the number of positions in the panel, pretty simple. And then your single line. And what I normally do, right, when I'm doing my conduit, look at your keynotes. It's going to tell you the assembly for all of the wire. Okay, and so I normally just start here, and all of this stuff is really going to be on our what? On our Excel spreadsheet for all the switch gear, right? And I usually do this the very last thing. And see, this right here shows me that this is underground and it comes up, but it shows me this too seems to be underground and it comes up. So make sure you account for this portion of your conduit to be PVC, because it's going underground and it's coming back up. Okay. And so that's it. If you have any questions, email me at education@sfjohnsonconsulting.com. I will have my take up off. I won't have my stuff put up there until all of your work is due. And so if you have any questions, email me, and make sure to make your at least two times a week your appointment to work directly one-on-one with me. But thanks a lot, and I will talk to you guys next time. Hey guys, happy Monday. And this is Stacy with SF Johnson Consulting and Construction Services. And I just wanted to show you very quickly how to get into the OSHA site for the training information. And so you would go to, and everyone that's taken the class has to complete this. You get access to all the study material, and all the links will be active. But in order to get your certification, you have to attend the live classes, and which means you would have had to pay for that, which means you would have separate access when we do have the live, separate access to those classes. So if you have already purchased the class as a company or as an individual, then you know who you are. But everyone else, anybody else, gets access to all of the study material. And this is how you do it. So you go to our homepage, which is www.sfjohnsonconsulting.com, and go to the OSHA Live. It says free. And so to sign up, you're going to click that. And hopefully I haven't already used every one of my emails. So my name is Stacy, and my last name is Johnson, and we're going to use a different one here, because I think I already got one on that one. And let's see, let's do takeoffs. That's one of our emails. Okay, and so I'm going to create a password. type my password. Okay, and that should be it. That's all you have to do. That way, we'll be sent a notification that you have signed up. And now, if you are the primary person for the business, this is what you have to do. You have to go down here because there are certain requirements for OSHA 10 and OSHA 30, which you have no choice. You don't pick those. But and OSHA 10, I do everything. So there's really nothing to choose in addition to in OSHA 10. And so, but OSHA 30, you do have to choose additional classes, which are down here. Okay. And so you pick the ones up to six, I do believe. Yeah. Six of the topics and or more, pick as many as you want. Well, we have to cover those as well. So again, if you're taking OSHA 30, you need to pick six of the additional elective topics and then give us all your information. So either way, we'll be ready. And every class is Tuesday through Saturday, 7 a.m. to 9 a.m. and then 1 p.m. to 3 p.m. On those days. So if you have any questions, email me at info@sfjohnsonconsulting.com. And again, just go to the free tab, fill in everything. We'll get a notification, and then we'll know you've been added to the class. We'll contact you with the actual login information for the live class, and we'll go from there. Okay? Any questions? Let me know. Thank you, and have a wonderful week. Hey friends, this is Stacy with SF Johnson Consulting and Construction Services, here to introduce a new segment of our educational program we call For Fill in the Blank Only. And this is for roofing and roofers only. And so what that is a program where we cover basics, estimating, and then safety related to that trade. And so we always start with the estimating or takeoff portion to introduce the trade. And what we have here is a small roof for a Scooter's Coffee. And this is the scope of work. So the keynotes on the roof, basically it is a TPO roof, 60 mil, over a half-inch DINS deck over poly insulation. Okay. And so what we need to do, we need to determine how many square feet of the TPO. We need to check to make sure if we have parapet walls, which we do. What is how many square feet of that do we have? Because chances are we're going to have the roof finish go over the parapet wall, right? And then we have some parapet caps, so we need to be able to, and this is typical for every roof, so it's not really anything, the square footage of the finished material, the cricket sizes, possibly, um, how many linear feet of flashing for a particular purpose. Anywhere where there's wall and roof meet is usually a place to put the flashing. So I always give the how many basically the perimeter of the roof, and then any of the cricket lengths, right? And what's a cricket? It's just additional framing we place over the main framing to give it a slope so the water doesn't gather here, right? So and the arrows indicate the direction the water's going to flow, right? So we want the water to typically flow uh, in this direction towards the valley, right? Kind of early, kind of early. All right. So we want the water to flow towards the valley, and it's usually some roof drains or gutters, downspouts, and I'm sure number 3, that's what that is. Let's see. Yep. A roof sculptor. So what do we have to do? How many square feet in total? We have to measure how many linear feet the perimeter, because chances are the parapet wall is the length of the parapet wall goes the perimeter of the building. We're going to look at the section views. That's a building section view, so we can see the thickness of the insulation and all the other details, right? Because from the plan view, we can only determine how many square feet of the finish, plus we can determine how many linear feet. And so for the roofer, square feet of the finish, always determine how many square feet of opening we have. And this is an opening for a rooftop unit or condensing unit or something like that. Then we want to know uh, how many square feet. And then, it's a circle, so we just square it out because we do want to be able to give to the roofer how many square feet of opening because they're going to deduct that if they want to. I don't know. It's just waste, right? Deduct that from the total area of the roof. So, area of the roof, perimeter of the roof, because we're going to have to look at a section view to determine the parapet height. So, let's go here. So, we have 4 different building section views. So what this is now this building section view is good for a bunch of people. It's such a small building. So it's good for the framer if we need to know the full height of those, God, I can't even think, the full height of the shear wall. Shear wall height usually goes the full height of the building. So now I know that the shear walls are going to be this height. So I can use this for that, I can use it for the thickness of the insulation. I can use it for finished carpentry. This looks like 2 top plates and another, and it's most probably at the perimeter of the building. And so for my roofer, tells me my roof finish, right? And I can look and see that this is the board insulation as opposed to the bat insulation. And if I'm the insulation professional, I can use this too to determine the height of my insulation. A lot of good things from this view. But because we are the roofer, we have to make sure we go to the next view. Why? Because this is a call out, right? A detailed call out, meaning it's telling us it's going to call out just this portion of the building. And because we're the roofer and our roof is showing right here, so we know that our parapet wall, it looks like it's a different height, right? Based on the side of the building. So we have to go back to the roof plan and the 1 over 3.1 would be the height for these walls because that section view goes through both walls. So that indicates that both of these walls are based on that height. Now, once we get here, it's going to change. We're going to look at 4 over 3.1. So if that parapet wall happens to be a different height, it's going to be at this point forward. We're going to calculate the different height. But for this whole section, till we get here, it's going to be whatever height is shown. And then these also have a different. Then we'll look at 2 over a 3.1 for the height of these parapet walls. Because again, we can see that the parapet walls are a different height. Okay, so that's how we get that. So we go to, because I want to go to more of the detail view. So I'm going to go to 4 over a 3.3. 4. It still gives me another detail call out. So I got to follow every one of them because I'm the roofer and I have to make sure I followed every detail call out until there's no more. So I still know a lot about this. I know that my finish is going to go up the parapet wall. I know I have a 22 gauge metal parapet cap that is this width, and I still got to go to 7 over 3.4. 7. So you got to have patience. And because you don't want construction defects, right? You're going to make sure you go to every view that you're sent to. And so we see here that there are no more views, no more call outs, no more anything. So this is the final of the views, the final of the detail views. And so as the roofer now, I know that I need to do all of this for my parapet cap. And I know that even the rough carpenter is going to come to this view too, or have it, yeah, because they need to do all of this. And then, if you're doing the siding, then yeah, you're going to come here too. It's going to lead you here too. So all of the views are based on whatever you do. If I'm the flooring professional, right, I'm not looking at these views because it's not my scope of work. But if I'm the rough carpenter, the siding professional, the roofer, all of these, it's my scope of work. Okay, so I have to go to every view. And so now I know that in terms of, because I'm looking at the plan, right, for my takeoff. And so I know that even for the rough carpenter, I know I have two of these top plates. So 2 times the perimeter of the roof, if I'm doing my takeoff for that, I know I have is a sealant, continuous caulking. So I know how many linear feet of caulk I have. So I know from the container how many linear feet of caulking, 8 ounce, 16 ounce, 32, whatever, a bucket, whatever. So that way I can do a proper takeoff to do a proper material determination, material cost determination, right? Rain screen, high performance weather barrier. You don't want to miss out on any of that because if you do, chances are it's going to leak and you're going to have a construction defect. And if whatever trade was your trade, you'll be responsible for all the other trades that got damaged because you failed to do your portion. That's what I did for a living, construction defect litigation adjuster. That's why you get that insurance. So just in case you don't show them, you don't know how to read a set of plans, you don't get to the detail call out number 6 or whatever, and you forget to put something in your construction and you blow it and it leaks and somebody gets sued because now the whole building is leaking, right? Yes. No. So you want to make sure you know how to read your plans. Okay? Come to the construction queen. I think this is the only time I ever referred. It's like, what were you thinking when you came up with that name? Oh, probably a shot of tequila. See, I'm perfect for this job. Anyway, roof plan. Okay, so here are our wall curb attachments. So whatever this is, you got to make sure you account for it. It shows you how they want it up the wall, right? Because, well, what's the purpose of the roofer? To make sure no moisture gets in the building. Okay, so that's why we have the TPO roof on the roof and over the parapet, and it with a parapet cap with the caulking, so water doesn't intrude into the building. Okay, and so what do we do as the roofer? Square feet of the flat roof. Now we know we have to break up the section view, right? Because at some points this parapet wall is 3 feet, some points it's 5 feet. So we have to do 5 feet times however many linear feet. So we're accurately determining the additional TPO for the parapet wall, right? And now we have to measure how many linear feet for the parapet cap and whatever else goes with our scope of work. And we have to make sure we're doing whatever this tells us for the openings, whatever this tells us, number 8, whatever this tells us, number 5, 6. Vent, that's easy. So we got a flash and it's going to show us at 5A. Let's go to 5 over A 3.6. 5 over A 3.6. 5. I never pan in the first time right. Okay, so here's the vent pipe. Right, because what's the point? We don't want moisture coming into the building. So we have the vent pipe, that's the plumber. And now we have to do all of this. We're the roofer. Okay. And so you need to know how to do it and how to account for it. And so it's a vent pipe, so it's a circle. You could treat it like a square. That's fine. When you're doing actual takeoff numbers for, okay, how many linear feet of TPO to what point, and it tells you, I think, stainless steel clamping ring, sealant. See what's the point? So no water gets down in there. So you have to be able to follow every section view, detail view. So you're doing the right thing. Okay, roof deck, rigid insulation. And if this is to scale, which it is, then you can just measure what's the thickness of the insulation. That's the whole point of having something to scale. If you don't know, it's like, oh, 4 feet, 4 inches, 6 inches, whatever. What is this? This is different from that. So you got to make sure what that is. Okay, so it's fun. It's a lot of fun. All right, so roofer, you are going to make sure you know how many square feet flat, how many additional square feet for your parapet wall, parapet cap, all the goodies that go with that, and know the heights. That's why they give you the section views, because the section view marker is if what? This is, we cut down in two, and now we're opening up and we're standing in here and we're looking at the interior construction so you can have a better view. And then that view will take you to a detail view most likely. Okay, and take you to all of these other places so you'll know how the vent pipes come and are flashed, and how let's see what 7 is. We didn't look at 7. Air condenser, see mechanical drawings. Okay. All right. So if you have any questions on anything that we presented, please email me at education@sfjohnsonconsulting.com. So in addition to this, we'll have stuff like safety for the roofer, what the project manager needs to know from a roofer, from that kind of perspective. So join us every day. We have something good for you. And if you like the video, please let me know. And again, email me at education@sfjohnsonconsulting.com. And I will see you next time. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, here to talk about number 8 on OSHA's top 10 cited violations, which would be a failure to have and be able to prove fall protection training. As we know, falls are one of the leading cause of death and injury on the construction site. And so in every case, I'm almost certain you need to have a fall protection program and proof of such at your job, and proof that everyone there is getting the training. So it's the OSHA standard 29 CFR 1926.503. Subpart M, safety and health regulations for construction, says this standard underlines the requirement for the employer to provide a training program for employees that may be exposed to falls. Training must be performed by a competent person, qualified in the nature of hazards and details of fall protection systems. The employer must have a written certification of training on file. So that's the important part, because if it didn't write it down, it didn't happen. And so here's the actual standard from OSHA. Must have the training program for employees who might be exposed to fall hazards. You got to have the program. It's really just that simple. So I'm going to show you our page that we teach from OSHA's fall protection training. Just a small little video to get us started. OSHA makes the world go round. All right. So, How can you protect yourself from fall hazards? Well, first of all, the use of fall protection equipment. We're not going to go through everything, but this is kind of the beginning of what we teach. Basically, the safe use of ladders, and of course, you got to have your training. But the most important is the fall protection equipment. You know that the employer is totally responsible for providing that on the job site, and so the one they prefer, if you need any at all. See, the goal is to never even need fall protection, but if you do, then there are three that are recommended. Guardrails, of course. Those are a passive system where if they're there, you won't fall. Okay, where also safety net systems is if you fall, something's there for you. You get in the net, and they'll take you out of the net. And then the personal fall arrest system. It's an active system. You have to wear it. It has to work right. It has to employ correctly in order to save your life. So you really want to not have the need for one, but if you do, guardrails are the safest. And of course, if you're up higher than 6 feet, you're going to need some kind of system to safely get you to the ground. We go over scaffold work. If you need the personal fall arrest system if you're higher than 10 feet. And then we go over safe ladder use and then all of the training. Okay, fall protection guidelines. We go over all of that. Understand the company's written fall protection plan. So there's the there's the violation right there, right? Let's get a little something to drink here at the office studio. Yeah, that's the problem right there. Written fall protection plan. So, if you have people working for you, you want to keep them safe, right? You have to plan. You have to actually do the training. You have to use the equipment. The employer has to provide it, has to replace it. But if there is evidence that the employee damaged it on purpose, then the employee has to replace it. Okay, so that is what number 8, the violation. You got to make sure you do what's right. Okay, so what are my employer's requirements? Of course, to provide the fall protection, to ensure if you're going to use scaffolds, there's a system, there's a requirement in OSHA how to do it safely. Yes, we need to train you on the use of ladders, even though it seems very simple. And yes, we must conduct work site maintenance. These are all things that will assist you in staying safe from falls. And then, of course, to provide the training. Okay, so it's a lot of a lot of stuff that appears to be repeated, but these are the actual standards that go with proper scaffold construction, the standard on the scaffold. And we went over a lot of these on the previous because, yeah, these are things that everything related to falls, pretty much the fall protection, the use of ladders, the scaffold, pretty much OSHA's most cited violations. And so maybe that's why falls are the leading cause of injury, right? And death. So fall protection training, all of that stuff is very important. So if you think you are in need of it, or if you are in need of it, make sure you contact us. We set up individual fall protection training for the individual and for the manager, so they'll know what to teach. So if you have any questions about this or anything that we have presented previously, please make sure to send us a email at education@sfjohnsonconsulting.com. Otherwise, I'll see you at the next class. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services. And in this video, we are going to go over some structural framing for our class and our special segment on our website for framers only. This is the structural set. And in the structural set, this is the cover sheet. You know, the structural set talks about all of the concrete framing components, posts, anchors, uh, concrete masonry, everything related to the structural set. And so in this set, we're going to talk about the structural framing. And what is structural framing? It's the shear walls, it's the posts and columns and headers and beams and how they are connected and supported. And so this is a small coffee shop. And the first sheet that it gives us is a configuration of the uh, shear wall. So it's the shear wall plan. So it gives us the shear wall schedule. And what is the shear wall? It's additional framing that you put over the structural framing to give the walls more resistance to shears. To in this case, is showing drift for snow or for wind shears or earthquakes in California. And so you give the walls some additional structural um, components to make them stronger, basically. And so, what is a shear wall? It's basically just plywood uh, on the exterior portion. Well, because it's right, it's at the for the rough framing. We're not talking about drywall. We're not talking about framing that's on the architectural set, right? So it's just the so we have the rough framing, and so we're going to connect the shear walls at the frame of the structural walls, and it's nothing but plywood, okay, half-inch plywood, and it tells you how to place it basically between the posts, right? And how to nail it. Okay, so what is this? 10D at 6 inch off center. So shear wall one, the hold downs are these. It looks like all the hold downs, no, they're not the same. Hold downs are as listed. Then the anchor bolts are as listed. Okay, so 10D is the size of nail. 6 inch OC is so we're putting a 10D nail every 6 inches on center. And the hold downs are as such. So we're going to have to look at, if we really want to get a good look at this, we have to look at the structural um, sections, right, in order to see exactly how everything is placed. And so the anchor bolts, this is the size. And for shear wall one, they're placed every 2 feet, and we work our way down to every 32 inches. So basically, it shows us here. So wall B, and now we have uh, this. These are wall B, and so now this is just the shear wall, and we have to go to the other page in order to find out, well, what is B? What's the configuration of B? What are we talking about when we are talking about B and A? And that's on the other sheet. Okay, so this basically just shows us the shear wall configuration, and we have to use this in conjunction with this. And so, what's A, what's B, what's one, what's two? Here's the actual roof framing plan, and then the foundation plan, which in the foundation plan, they also kind of mix up your, they put everything that's for your framing here. So, it's kind of like, for my liking, I don't want the king studs on the foundation plan, right? Because the foundation plan is concrete, right? For me, it's a one. See, we have a single story building, right? So it's kind of like, okay, do I put it here? Do I put it there? But because it is framing, we should put it on the roof plan. But Every architect is going to do something different. So, what is my job? Let's go back to what my job is. As the framer, structural framer, I have to be able to do the takeoff for this thing. That's really what so I have to do the takeoff for the shear walls, and I have to do the takeoff for all of the king studs. How many? What's the height? I have to do the takeoff for the headers. What's the how many linear feet of each type of header? What is B? So that's why we have to use this sheet in conjunction with the sheet that we already saw. What is B? Well, B is the header. And what's a header? Header is, let's go back. When we put see, that's why I don't like it. It has the header here and the header here. But no, it doesn't have the header here because it doesn't mark it. It only has the king studs here, but the header's over here. Okay, so what's a header? That's header B. Anytime we put a hole in a structural wall, and a hole is a door or window, you have to give the strength back to the hole so we can place the roof joists and they can be secure. So we put headers in doors and windows. So it's a combination of 3 or 4 2x4s, 2x8s, 2x6 with the plywood to fit the gap. So let's go back to see let's go forward to see what header B is. See, I kind of don't like when you got to go back and forth. Everything that you need on one set should be on the set. There's no reason why they couldn't repeat this on the sheet that we actually need it on. So it's like, oh, if you're new to this, I'm like, okay, well, what is this? And yeah, when I was new to this, it drive you crazy. It's like, well, wait, where's A, B? Oh, it's on a different sheet. It's always, it should always be on the same sheet that it's referenced. But in this case, it's not. So we have to keep going back and forth. And so what I would probably do is just print this out. So when I go to the next one, I'm like, okay, what's header B? Okay, I already know because I printed this out. Okay, this is a pain, but it is what it is. You know what I mean? You work with what you got. All right. So what's header A? It's 3 2x10s. We know the by is wood, right? X wood with 2 half-inch plywood spacers to fill the gap, basically. B is 3 2x8s with 2 half-inch plywood spacers, and header C is 3 2x6s with 2 half-inch plywood spacers. So when you're doing the takeoff, you're basically saying 2x10 times 3. So if I measure 25 feet, I'm really going to say 75 feet of a 2x10. That's how we do that. And half-inch plywood spacer, half-inch thick by, no, half-inch by the width by 2. Half by, because you need a height for it to be very technical on your takeoff, right? You need a height and a width for that plywood spacer. So you just got to sit there and, do the math. It's easy. Okay, so some stuff is over here now. What's B? Shear wall schedule. See, but this B is nowhere on this, right? Because this B, well, where's 1 and 2? See, 1 and 2 is nowhere on here, so I hate this set of plans. So what we're going to do is we have to measure 1 and 2. That's here. That's all of our 1. Because your shear wall isn't continuous. It's only where it's noted. Okay, so that's confusing too. That's why I decided to get a very confusing set of plans. Okay, because here's the shear wall, here's the symbol. So when we see octagon 1, 2, 3, 4, we need to look for octagon 1, 2, 3, 4. Okay, so that's here. octagon 3, and it is only where you see these symbols. So it's not everywhere. Okay. So that's a pain. So we'll do those measurements. Okay, and remember this is for framing only. So what do we need to measure? The length of the shear walls, how many linear feet. Then we're going to go to the section views. And see, these section views don't help because they don't go all the way to, they don't tell you the height. Okay, it shows you, see, it breaks it off right here because this is the header. Man, this sucks because your shear wall is going to go the full length of the wall. So this right here is the header. Where's the header? Header's at the top of the window or the door. And so you have to figure out what's the top of the window, and it tells you right here. Reference the architectural set. So you see how difficult it can be to navigate when you have a crappy set of plans. And what's our job for framers only? Measure how many linear feet a shear wall, and you got to figure out what the height is because you need square feet for shear wall. You got to determine how many linear feet of the header. See, this is the one with the 3 or 2 or whatever plywood header, and then it tells us to reference the plan. So this is from section view 2 on there. Okay. And so, yeah, it could be a little difficult. But this is just the basic overview of the plans, right? We got to get a basic overview. We're the framer. Basic overview is kind of crappy because framer, we need our rough framing. 3 king studs and 1 jack stud at rough opening typical. So whatever I see here, so that's why they don't have to mark this one, because they've already marked it here. They gave me the details. Typical means that this picture right here, whatever I see that represents this picture right here, which is like what, this one, that one, that one, that one. Oh, see, no. Okay. So corners, typical. So the corners, we know we have 5 at the corners because it told us. Typical is the key. And then at the openings, we have this configuration, typical. And this is an opening. And I just have to know it's an opening because I should know it's an opening. This represents an opening. Okay, so a little confusing, but not really. So again, what am I doing? Measuring how many linear feet of shear wall. This represents the shear wall, octagon 1. It's only this many linear feet. But at the corners, I have this configuration and that. So I have to measure what? 5, 10 king studs times 15, 20, 12. I don't know how many linear feet because it's going to go from the foundation, right, to the roof joist. So I have to get on another set of plans if this section view doesn't show me, which it doesn't. Okay. It only shows me from the header all the way up. Now, it's very confusing because I have the shear walls. Let's go back to the shear walls. Well, we know that the wall is, let's go back to the floor plan, right? Floor section view. Here we go. Okay, so now we're in the architectural set. It's not telling us anything about these, right? That's our header that we're looking at on our structural set. It's not giving us info about that. But see, we have to go here to determine the shear wall height. because there's nothing that tells me, and shear walls are usually that's the whole point, to attach it to the foundation, to the roof joist, and then above. And so that's the only detail. And I would just, when you do the estimate, you just got to be very detailed on how many linear feet, how many square feet of shear wall are you allowing for the plan. You got to be very detailed, especially when the plans aren't detailed. You got to write out a lot of stuff because you want whoever's reviewing your estimate to know that you've done the best based on these plans that you're given, right? To get the correct numbers. And so over time, we'll have the takeoff completed, the visual completed so you can see it. And you'll also have the pricing from a cost book. And then with the cost book, we'll be able to tell how long something takes. That's the beauty of this whole thing because you want to be able to price it correctly. If you know how long it takes, you'll be able to price it correctly. You'll be able to know how long each job you do is going to take. And so you'll be able to schedule work for the whole year, right? If you have 5 jobs and you know exactly how long they're going to take, you know if you need more work for the year. You can't just work, oh, I think this is going to take 2 or 3 weeks. No, there is a way to determine once you have your full takeoff completed, how long this job is going to take to do every portion of the scope of work. So let's go back because this is for the framer. Okay, so the framer, what I'm going to do is shear walls. I got to measure how many linear feet of the king studs, right, from foundation to roof joist. I have to determine how many linear feet of uh, the headers over here. How many linear feet of header I have. And now, how do they represent the roof joists? Structural framing and always represent it with the arrows, the sweeping arrows. So I know the full roof joist configuration. And if it was if it's something different than 2x12s, it would have another sweeping arrow and give me whatever that is. And so the full roof joist, structural roof framing and structural framing. We know that it's all 2x4 at the 16th on center. And then we have to look at, because we have a hole in the roof, right, to hold the condensing unit and the air handling unit and whatever unit. So these structural roof joists have to have their own additional structure to keep the air handling unit from falling through the roof, right? Okay, and so for the structural framing, there's a few totals that we'll come up with. All of the headers, all of the shear wall totals, all of the roof joists. Now you can do the roof joist because you actually buy roof joists based on not square feet, but how individually, right? In all of these individually, and it appears that the majority of them is are 17 feet 11 inches. So that's good for this one because if the building was built another way, then we'd have to tailor our roof joists to fit that length, right? Because these are made specifically for the building. Okay, so again, for framing only, what do we have to do? The structural framing, not architectural plan framing. Structural framing, architectural plan framing, two different things. So this is S plan as in Stacy. So what do we look for again? Shear walls and posts and columns. Basically, these are acting as uh, posts. Pretty much, these are acting as posts because it's single story. You don't need anything to other than that, but that's a lot. These are uh, posts or columns, whatever you want to call it. Call it either one. They have the same purpose. So Again, I repeat myself. Structural framing, what are we measuring? Shear walls, and that's all is represented by this configuration. And on the other sheet, it told us what octagon one, two, three, four, plus the anchor bolts. So really, we can determine first if we know how many linear feet, and it should tell us more about the nails. It's like, okay, 10D nails at the 6 inch. Is that at the framing? See, we got to look more in detail on the nailing because it's just, yeah, every 6 inches, but at the corners on in each direction. So that's something else you got to look for. Okay. And you can figure out how many anchor bolts you need. If you know how many linear feet, you're placing them every 2 feet. So you figure out how many anchor bolts you need, the hold downs. You can really determine how many nails you needed if you wanted to. Okay, so shear walls. And then we say, well, how many linear feet of shear wall, octagon, one, two, three, figure that out. Then all of the corner king studs, figure that out. All of the headers, how many linear feet of whatever configuration it says it is. So, right, no, headers. So remember, it's not just one stretch of 2x10. If I have 100 feet, now I've got to get 300 feet each cut that size, right? Because within each opening, I have to put 3 plus 2 1 inch half plywood spacers. So that's what the structural framer does. Got to figure out all those totals. We'll have all of that done shortly in a video reviewing all of that. And then we'll have video 2, which is the pricing. And then video 3, which is formatting an Excel spreadsheet so it can look nice and pretty. And so if you have any questions related to any of this, please email me at education@sfjohnsonconsulting.com. Tell me what you think about this. It's very crazy, right? This is not a very easy one. Structural framing, like electrical, a lot of little details. If the plans aren't really good, you got to go back and forth and back and forth. And you can't make mistakes as an estimator. You got to make sure everything is right. So you have to take your time. So you'll see once we work through this little by little. And again, any questions, please email us, or otherwise, I will see you at the next class. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, going over OSHA's 10 most cited violations, number 7, which is powered industrial trucks, or more likely the improper use of the powered industrial trucks. And that is OSHA standard 29 CFR 1910.178. 1910 subpart N as in Nancy, material handling and storage. And this standard contains the safety requirements relating to fire protection, design, maintenance, and the use of powered industrial trucks. And so basically, fancy term for forklifts, tractors, platform lifts. It could be any specialized industrial truck powered by electric motor or internal combustion engine. And there are, 11 different designations. Okay, so it just basically goes over the standard of each, what's required in the training, and we're going to get that up here. So we have this in a little video. We want to drive the forklifts around like they're sports cars. So basically, if you are using one, you have to be properly trained. It has to be noted that you've been trained, and you have to be trained every 3 years. And the only additional training would be required if you were found to be using the forklift improperly, then yes, you would have to be required to be retested, recertified, and all that good stuff. So uh, that's what would happen in that case. So, really simple. This section contains safety requirements related to the protection, design, maintenance, and use of fork trucks, tractors, platform lifts, da 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 da. All new powered industrial trucks acquired and used by an employer shall meet the design and construction requirements. And then it just states that there are 11 different types. And then there is more information on where and when you can use each type. And so we have a little video here to go over the most important things when it comes to that is just you don't modify it other than you don't do anything to it other than the manufacturer's recommendations. For instance, even if it is 110 degrees, you can't put an umbrella, stick an umbrella on the top, right? Because that's not according to manufacturer specifications. I know it makes a lot of sense, but you'll get a violation because of that. Okay. So let's show this little video. And it is very outdated just to show you how long we've been trying to keep you guys safe. Here we go. I'm gonna cut the mic off, and hopefully this time again, I'll remember to cut it back on. We'll be right back. Isn't that awesome? It's awesome music.
Powered industrial trucks are rugged tools used to push, pull, carry, lift, and stack materials. These machines include the tractors that pull luggage carts at airports, the all-terrain reach trucks operated on construction sites, and, of course, forklifts. All of these vehicles save us time, money, and effort. But if they are not used correctly or maintained properly, they can be dangerous. OSHA's Powered Industrial Truck Standard covers how to work safely with these machines. One of the most significant parts of the regulation deals with training. Before you can use any type of powered industrial truck, OSHA requires that you be fully trained, evaluated, and certified by a competent instructor. Your certification process includes instruction on safety procedures and training on how to operate the industrial trucks that you will be using. You will also have supervised driving practice. Your knowledge and ability will be re-evaluated at least once every 3 years. If necessary, you will undergo retraining at this time. OSHA also requires training anytime you are observed being unsafe, have a close call, or are involved in an accident. In addition, retraining is required whenever there is a change in your workplace that may affect your ability to operate a powered industrial truck safely. Hello and
All right. So that very last one where bro comes out swinging his arm. No, no. That's the one is what we get the most violations, right? Doing donuts in the thing. Even in a lift, I've seen it. So, what more can you say about power industrial vehicles? Pretty much forklifts, what we use every day on the job. Just be safe. And if you have any questions or concerns, hey, let us know what you think about the video. And I think we got 2 or 3 more left. What's next? Oh, fall protection. Training, okay? So we have fall protection. That was number 1. But fall protection number 1 was the use of it, right? Nobody was wearing it, okay? So it obviously makes sense that we have number 8, no program, no proof of training program. So that's next. That's number 8. That's number 8 of OSHA's most cited violations. You know, OSHA's been around since the 70s, but that's how they make money, because people don't pay attention and they don't follow rules. So if you have any questions, make sure you send me an email at education@sfjohnsonconsulting.com, and I will see you guys next time. And ladies, adios. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services. Just wanted to go over our violation number 6, the control of hazardous energy, also known as lockout tagout. So that is OSHA Standard 29 CFR 1910.147, part of the General Environmental Controls. The standard covers the servicing and maintenance of machines and equipment. And it really goes over the standards and rules and procedures that should be set when there is an unexpected release of energy from a piece of equipment. So pulleys, that kind of thing, anything with an internal pretty much capacitor, they hold energy. They store the energy that they are, that's given, or that's input from the energy source, can be stored in certain parts of the equipment. And so when the equipment has to be serviced, we have to make sure that the equipment, that stored energy, has been released in one way or another. And so in a lot of ways, it just takes a period of time to do that. So time, we have to allow for the piece of equipment, unplug it, release it from its original power source, and then or turn it off. If there's a direct connect to the power source, we turn it off, and then we do what's called as lockout tagout, where we physically lock it. Someone's in charge of that. There's a what do they call that? I got to think about it a minute. There's a order for which, we know who's to check it, how often it is to be checked. There's only one person in charge of the key to the lock, and the whole purpose of that is to give the equipment enough time to naturally release the energy. So when it is, when we want to go in there and repair whatever it is, the employee who puts his hand in there, right, is safe from it being injured, or her being injured. And so what I want to do right now is kind of give an introductory video on the concept of stored energy and the release of energy. And then we'll go over a few of just the outline of the standard created by OSHA, and then a small video on the procedure for lockout tagout. So let's first things first. Yeah, let's see, where are we? I think we're here. And this is, what is potential energy and what are the hazards? From our friends at WorkSafe. All right. And I'm going to turn off my mic. And this time I'm going to turn it back on, because I recorded this already, but I didn't turn back on the mic. So this is the second time, but I promise, I'm going to promise myself to turn the mic back on. Here we go.
What is potential energy? Potential energy is energy that is stored in an object, based on the position or the state of the object. For example, a massive object raised very high, such as a wrecking ball, has a lot of potential energy because of its mass and height. Elastic materials, such as springs and rubber bands, contain potential energy when they are compressed or stretched. When that potential energy is released, the rubber band or spring can move very fast. Because potential energy is stored in objects that are not in motion, it can be hard to tell if the equipment has potential energy. and may be dangerous when released unexpectedly. Sources of potential energy must be controlled by restraining, blocking, or lowering elevated parts of the equipment. Some sources of potential energy may be hidden from view inside machinery, becoming dangerous if not identified and controlled. All sources of potential energy must be identified when performing risk assessments. Once equipment has been de-energized and stored potential energy has been controlled or released, it is considered to be in a zero-energy state. Always ensure all sources of potential energy are identified, controlled, blocked, or released, and verified to be in a zero-energy state before working on or around the equipment. Employers are responsible for identifying potential energy hazards in the workplace and implementing controls that prevent workers from contacting the equipment while energized. For more information, go to WorksafeBC.com.
Almost forgot again. All right. So now we'll go to some of the standards. But yeah, potential energy, very dangerous if we're talking about machinery and you putting your hand in there and it's a bad situation and you lose some fingers and you now can no longer hold 2 beers. You can only hold 1. We don't want that to happen. All right. So the OSHA standard is 1910.147. Talks about the scope, application, and the purpose. But we know all of this, and when you take your class with me and we're going to have a good time, we'll talk about in detail the scope. And we know the whole purpose is to, if you are using machinery that has the potential or has the possibility, we don't want to use the definition in the explanation. No, we don't want to use the word in the definition. If you are using a piece of equipment that has the possibility of a release of energy, we want to go through the standard, or we want to make sure we understand everything to the application, why we do it, what do we do, what applies to what pieces of equipment, and what the purpose is. And the purpose for every OSHA standard, of course, is to always keep you safe. Okay, and so that is the standard. Like I said, when we go over it in detail, we go over everything in detail. The lockout tagout is basically, it is what it says. We lock it and we tag it. Chain of command. That's the term I was looking for earlier, that there is a chain of command, which means there are people in charge. We know who had it, who locked it, who's checking it, who unlocked it, because if there's a possibility that you go and everybody has keys to it, right? And you go unlock it and it wasn't ready and the energy hasn't dissipated, you go in there, you try to work on it, you lose all your fingers. You know what I mean? And so there is a chain of command, there are procedures, and OSHA has set those for you to keep you safe. And now we're going to look at our, what is lockout, tagout, and some of the actual procedures, and we'll take it home from there.
Ever heard of hazardous energy? Imagine something like this, or maybe something more like that. Not quite. Hazardous energy is any form of energy found around the workplace that poses a potential hazard. It comes in many forms. Electricity is a common one, but hydraulic pressure, radiation, and even gravity can sometimes be considered hazardous energy. Modern machinery can utilize many types of energy, but when the machines are shut down for maintenance, that energy may not just go away. Workers can be injured when energy is released unexpectedly. So to keep them safe, extra precaution must be taken when working with this equipment. That precaution is called lockout tagout. There are many variations on LOTO processes and programs, depending on the type of hazardous energy present. But they all share 4 basic ideas that are addressed before work begins. 1. Identify potentially hazardous sources of energy. 2. Disconnect those energy sources from the equipment. 3. Apply lockout or tagout devices to temporarily prevent reconnection. 4. Confirm that the system is safe. Lockout-tagout systems must adhere to OSHA's lockout-tagout rules as described in 29 CFR section 1910.147. As important as they may seem, lockout-tagout plans get overlooked far too often, as lockout-tagout is commonly found in OSHA's annual Top 10 list. In 2015, it was number 5. For more information about LOTO programs and the equipment used, visit
More information, ask Stacy. Yay. All right. So, yeah, that's our number 6 hazard. You know what I mean? And so we want to try to avoid that at all costs. Lockout, tag out, OSHA's 1910.147. Make sure you're not messing with equipment, even at home, right? Even at home. It applies at home. Make sure you're not, messing with equipment that has the potential to blow you up, shock you, set you on fire. Okay, so any questions about anything that we have presented? It is our hope to get these last few out within the next few hours. And so any questions, please let us know. Any comments, please let us know. And sign up, subscribe every month. We're going to put everybody's info in, and we give away some Starbucks or some other thing, $100 a month for our loyal subscribers and listeners. Thank you very much. And please email me any questions you have to education@sfjohnsonconsulting.com. And we will see you next time. Peace. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services. Just wanted to go over OSHA's top 10 cited violations, number 5. And that would be ladders and the improper use of ladders. And if you're improperly using the ladder, you probably have a lack of training. How easy can a ladder be? Well, we use ladders so much we think they are easy to use, but they are the 5th leading cause of injury on the job site. And so we just want to go over a few things with respect to ladders and safety. That's the OSHA standard 29 CFR 1926.1053. And that's a general requirement construction standard. And the standard sets the rules for the condition of the ladders, the use of ladders, self-supporting, portable ladders, fixed ladders. Talks about the conditions of the rungs, how far spaced they should be, free of oils, that kind of thing. And then the ladder support. So we'll look at just a quick, because ladders, why we get violations on ladders is really is silly. It's mainly because of the support that we use or don't use for the ladder. And so just go over a couple of little things on the ladder safety here. And should be really easy. I just have a few things because again, really with the ladders, you just need to make sure they're not in an unstable position when you set them. There must be 3 points of contact when you're climbing a ladder. The height of the ladder should be at least 3 feet above the surface or the landing, right, that you're going to be approaching or that you're trying to get to. So the ladder has to be 3 feet longer than the landing. And it has to have a slope of 1/4 of for the slope. So let's just read over a few things. Falls from portable ladders, step ladders are one of the leading causes of occupational fatalities. First of all, you have to make sure, just like with scaffolds, that the ladder is rated to hold the amount of weight, including the worker, and all the material that they're going to be taking up the ladder. So first things first, you want to make sure that you're at least 10 feet away from any overhead power lines, and or that they're de-energized, which is a whole problem in itself. Okay, so you want to avoid the metal ladders in the power lines. You always want to inspect the ladder before using it and make sure it's clean. You can't slip off of it, that kind of thing. And then always maintain a 3 point of contact. So 2 hands and a foot, or 2 feet and a hand. So 3 points of contact. Okay, so you always make sure that if it is up against the building, it has to be properly attached to the building. Both of the rails have to be properly attached to the building. Okay. And again, you never use the top step or the top rung of the ladder. Those are the never steppers, right? The top and the rung, the last rung and the very top, you never use. So you can imagine, anybody from OSHA going by and they see a couple of things. They usually see a ladder positioned against a building that is not stable at the bottom. So it's sitting in some moist soil and it can sink. That's one thing. 2, there's no support at the top of the ladder. And 3, the ladder is usually not long enough for the landing. And so really, if you take point and do that and make sure your slope is correct. And here's a perfect perfect picture. Make sure you have a 1/4 slope, 3 feet above the landing. The stable in a stable soil, or you have to make it stable in some way. The slope's correct, 3 feet above. That's pretty much it. I mean, ladder safety is probably the easiest thing you can avoid getting a citation for, right? Make sure it's fitted for the job. Make sure it's the right height. Make sure it's secured at the top. Make sure it is in a stable soil, dirt, concrete, something at the bottom. And then make sure you are always, you always have 3 points of contact when you're climbing the ladder. So, why we get violations for ladders is just being careless and being stupid, basically. There's nothing else I can say about that. So this is number 5, OSHA's most cited violations: improper use of the ladder. And just keep in mind, 3 feet above the landing thing gets everybody every time. Always gets them every time. So if you happen to be on the job site and your ladder is not long enough, you got to go back and you got to get the right ladder. Because again, if you're outside a building on a ladder, you're very extremely visible. And there's somebody like me walking around saying, hey, you either don't have on a hard hat, you're up higher than 6 feet, you don't have the ladder attached to the building, the slope is off, it's in the dirt, something. 3 people on the ladder at one time. Oh, I saw a bro today just hanging off the side of a building. No guardrails on the top of the building. He's just hanging off the side. So I was going to make a U-turn and take a picture, put it up here just for you, but I decided I wouldn't. Guys don't like that. Anyway, ladder safety. Keep it in mind if you have any questions or concerns regarding this video. Please email me at education@sfjohnsonconsulting.com. But I'll see you for the next thing that nobody should be getting hurt for or violated or a citation for, but they will. And I don't have my list with me now because I thought ladders, let me spend about 5 minutes on ladders because it's just being stupid. Okay, basically. So people say don't say stupid, but when you're grown and you do something like that, it's just stupid. All right, so I'll see you next time. Email if you have any questions and look for the next class, guys. Have a good one. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and just wanted to encourage you to sign up for our OSHA 10 or 30 class before the end of the year. It's $800 for the full company, no matter the size. And for OSHA 10, just want to show quickly what we'll go over. It's basically 6 hours of mandatory, 2 hours of electives, and then another 2 hours of optional. And then with OSHA 30, it's 14 hours of mandatory, 12 hours of elective, and then 6 hours of 4 hours of optional. And you see here that you can choose from a wide variety of classes for the optional and the elective. So please sign up at our website, sfjohnsonconsulting.com, and hope to see you soon. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and just wanted to bring you number 4 of the top 10 cited violations by OSHA. And today we're going to talk about scaffolding. And today is September the 20th, and we have some OSHA classes starting next week. So I want to make sure we get all the rest of these out today. So you'll probably see our YouTube page blow up today, which is a good thing. So number 4, scaffolds. Okay, so that is the standard for construction, 29 CFR 1926 451, general requirement, and it is a construction standard. This standard sets the rules for the construction and use of scaffolds on the construction site. It mentions loads held by the scaffold, which basically means its capacity, 4 times the weight plus, and that includes the people and the equipment that they're going to have on there, things of that nature. And the scaffold shall be designed by a qualified person. That is a definition used in the OSHA standard, meaning they know how the scaffolds should be constructed. They review, they help in the construction. They are on site while they're being put together and taken down. They look over them every day, and they can note any problems that they see in the construction, and they have the authority to make the changes. Okay, so that's the qualified person when it comes to scaffolding. And the standard also details how the scaffold should be constructed. Okay, so how it should be put together. So you can imagine it just take about 2 seconds when you look at how a scaffold is supposed to be properly put together, how you're supposed to properly be on it, get off of it, the ladder safety, all that kind of thing. You can probably imagine there are a lot of violations out there when it comes to scaffolds because they're easy to see, right? And easy to see that you are not using them properly. And the standard not only covers the ones that are built from the ground, right? There are scaffolds that are suspended, right? So it also covers the standard for that. But in this presentation, we won't be, because I do want to show a small video, which is always good, because if you do this every day and your supervisor isn't giving you the regular training, come watch what we have and hopefully sign up for one of our continuous education kind of things, because I'm pretty old, but not, and education never ends. Okay, you should never think that you're finished learning anything. You're only finished learning when they put you in the grave. Okay, people. So continue to learn so you can continue to grow and to be good at what you do. It doesn't matter. You can learn anything at any age. No one's ever too old to learn anything, and especially when it comes to you being safe. You're definitely not too old. So let's look at some details. Let's see what we got here. Come on, Grandma. Let's see which one. Here we go. There we go. So here's the OSHA site. Remember, it's OSHA.gov, right? Because it is a government agency developed in the 70s by the Department of Labor. All right. So safety and health regulations for construction. It's 1926 subpart L. Scaffolds 1926.451 general requirements. Okay, so capacity. except as provided. This section shall be capable of supporting without failure, right, without falling down, its own weight and at least 4 times the maximum intended load applied or transmitted to it. So, so it has to hold its own weight, of course, plus 4 times the amount of weight you're going to have on it. So that includes the individuals, the individuals, the people, how heavy are they, right? You can't have heavy hitter, bunch of heavy hitters on the top row of your scaffold. It's got to fall. Or if you do, it's got to be able to hold 4 times, not only the people, okay, but the equipment and everything you're going to be raising up and down on the scaffold, okay? Oh, it's Tuesday, and they use the pollution things without proper stuff on their faces too, every Tuesday, and blow around a bunch of dust and never pick it up. They just blow it around. All right, here we go. We're going to keep it moving. Suspension ropes, it mentions that, and those are for, if you're bringing something up, right, you're going to pulley it up on a pulley system, that kind of thing. It says that the suspension rope, including connecting hardware used on adjustable suspension scaffold, shall be capable of supporting without failure at least 6 times the maximum intended load. Okay, so how do we figure 4 times, 6 times? Just do the math and go up. If your bros are $250 each, right? Okay, well that's $500 just for the people. If it's only 2. Is the bags they carrying another 15 pounds? Okay, well, that's another 30 pounds. And now, what are they going to carry up? Some paint? Add the weight. And just go over. Do 5 times. That way you've got it covered. All right. So, let's see. The stall load of any scaffold hoist shall not exceed 3 times its rated load. Stall load, meaning when it's not doing anything, okay, it shall not exceed 3 times the rated load. All right, scaffold platform construction, okay, very detailed. So we're going to show a video. Well, first we're going to show a nice little hazard situation here. So here we go. And I like these people over here. Safety, these safety notes and safetyvideos.com. It's always good. All the safety videos you could ever use. And hopefully you can hear me through the noisy landscaping equipment. I need to go take a picture because they're violating their own OSHA standards. They do every week. All right, so what we need to look at are the scaffolding components. That's what we will look at, just so you'll know the nomenclature or the names of everything and what's where and all of that. And then it mentions the good hazards, and maybe the landscapers dudes will be finished by the time we finish. General safety precautions for scaffolding, general safety precautions for ladders, but we'll do that later, okay? And so here are some of the terminology for our scaffold. The sole plate, the base plate, standards, ledgers, bracing, decking, guardrails, handrails and mid rails, height 1 meter, we'll see 42 inches and somewhere in between that. Toe board, minimum 6 inches in height, or has to be above whatever material you're going to load. So if the material you're going to load onto the scaffold in height is more than 6 inches, then you need a toe board that's more than 6 inches. Clamps, the standard, gives you some standard numbers, clamps you use. And the decking should be scaffold rated decking. There is a difference. All right, secure ladders should be secured at 3 locations. So can't you imagine all the violations that people are getting? Because, they'll secure it at the top or something, or maybe just at the top and at the bottom, but we need 3 locations. And then we talk about tags. Green or red tag shall be reviewed after 1 week. Okay, so the tags may be reviewed after 1 week, but you look at the scaffold on a daily basis. More in the standards tell you more about not using the scaffold when it's, thunderstorms, lightning, that kind of thing. Okay, so here we go. Base plate and sole plate. Okay. Scaffold tag. Yeah, it should see green means it's good to go. Red, don't get on it. Yellow, what's up? Still don't get on it. Don't get on it. Then really, you're only going to get on it if you have the green tag. And then here's the decking. Okay, this is a nice scaffold. This uses metal decking. Okay. And then securing the ladders at secure locations. And here's a broad view of that, right? The main scaffold body. And then, you're going to secure the ladder on a secure portion, right? And then the toe boards. And the toe board height really depends on the height. If your material is above here, right, you need a bigger toe board or you need less material. You choose. Okay, so that's nice. This is a nice I like these pictures. That's why I want to show these. And look at that. Isn't that pretty? The nicest one I saw was the Matterhorn in Disneyland in Southern California. You talking about nice scaffolding. I'll find that and put it on this video once we upload it. I'll find it. You're talking about some nice scaffolding. All right, handrails, mid rails. Okay. And it's all for your safety. It's a larger. And we don't climb on the crossbars. Kids. Okay, it may be fun, but it gets your boss an OSHA violation. Okay, we act like grown-ups. It's not monkey bars. Okay, so here we go. We have some nice little video here. Oh, are you kidding me? All right, so I think I'm going to play the video and mute the microphone. Here we go. Let's make it a little bigger. Oh, no, wrong one, Grandma. X that out. We don't want to put that on our TV. Here we go. And I'm going to say bye-bye while we play this. And I may stop it to make comments, but please, it's nice. It's about 5 minutes. Let's go.
Scaffolds or temporary work platforms can provide a safe and more efficient way to work in construction. But the use of scaffolds is also one of the leading causes of injuries on construction sites. Unsafe scaffolding causes an estimated 3,000 injuries and 79 work-related deaths a year. And workers being exposed to hazards on scaffolds is one of the most common OSHA violations. It's important to recognize scaffolding hazards and make sure every scaffold is set up and used properly. Although there are many different types of scaffolding, there are several common hazards associated with all types of scaffolds. Number 1, falls due to lack of fall protection. 2, unsafe access due to ladders, stairs, and ramps. 3, injuries from falling tools, work materials, or debris. 4.
Okay. I just wanted to pause it real quick. The bro with the foot pedal. I'm not sure if those were Nikes or Adidas because they sure didn't look like work boots. Just saying.
4, electrocution due to the proximity to overhead power lines. And 5, collapse caused by instability or overloading. There are requirements specific to scaffold erectors and to scaffold users. Erectors have to use a combination of fall protection methods, which include body harness, lanyards, and vertical and horizontal lifelines. Users must be protected against falls by guardrails, full decks, and safe access, and knowing when they would need other forms of fall protection. Any scaffold 10 feet high or higher and more than 14 inches away from a building must have a complete guardrail system with toe boards covering all exposed sides and ends. The top rail must be 42 inches high, the mid-rail 21 inches high, and the toe board must be at least 3.5 inches high, or as high as the material on the scaffold, to prevent objects from falling off. If guardrails can't be used, workers must use a personal fall arrest system when the scaffold height is over 10 feet. Falls from scaffolds generally occur when personnel are climbing or descending the scaffold. In many cases, injuries occur when climbing the braces or scaffold frame that was not designed to climb. Safe access to the scaffold work area is required when the elevation change is more than 2 feet. Equipment that can be used for safe access could include secured ladders, clamp-on ladders, and built-in ladders. You can directly access scaffolding from another scaffold or structure, provided it is not more than 14 inches horizontally and 24 inches vertically from the other surface. Cross braces cannot be used to climb on or off the scaffold. Being struck by falling objects is a common occurrence that can be reduced or eliminated by using toe boards, netting, or by barricading the area. It's important to note that hard hats must be worn at all times when working on and near scaffolding. Overhead power lines can be extremely dangerous, even deadly. Scaffolding should be built at least 10 feet away from an exposed power source, unless it has been insulated or de-energized. All electrical tools and power cords must be in good condition and protected by a ground fault circuit interrupter device, or GFCI. Do not work on scaffolds during electrical storms or high winds. Scaffolding collapse can be caused by several factors, including poor foundation or footing, improper construction, overloading, and being struck by machinery. Always know the foundation the scaffold will be built on. Never build scaffolding on stacked bricks, block, or other unstable objects. All scaffolds require steel base plates, adjustable bases, or casters. Mud sills can be used under the base plate to spread the load when scaffolds are built on soil or asphalt. If using mud sills, ensure the base plate is nailed to the mud sill to prevent displacement. It's important to know what the load capacity is of the scaffold to avoid collapse. A scaffold must be able to support its own weight and at least 4 times the intended load, which includes workers, tools, equipment, and materials. Bracing is extremely important. Scaffolds should never be used unless all required bracing and securement is in place. Scaffold platforms must be fully decked and at least 18 inches wide. Only scaffold-grade planks should be used. Planking can be wood, metal, or a combination, and must be secured to prevent movement. Workers who are involved in using, erecting, or disassembling scaffolds must be provided training by a competent trainer who can identify scaffold hazards and has the authority to correct or eliminate them. This person should also be responsible for overseeing the setup, dismantling, or any modification of any scaffold, and is required to inspect scaffolds and scaffold components for visible defects before each work shift. By following these safety guidelines, scaffolds can provide you with an efficient work site while maintaining the well-being and protection of you and your crew.
All right, so that is our little presentation on scaffolds, right? Falls are, the largest, most violated, a lack of fall protection. So on a scaffold, if you're up higher than 10 feet, right, you require the guardrails. And if you don't have the guardrails, you got to have some kind of personal fall protection gear. Don't forget the proper shoes and the proper hat. So thank you for joining me. Look for the remainder of this stuff today. And it's something that we enjoy doing. We hope you enjoy it. Please comment and like if you do so. And we'll see you next time. Any questions, please send it to education@sfjohnsonconsulting.com. Thanks a lot. See you next time. Hey guys, thanks for joining me. This is Stacy with SF Johnson Consulting and Construction Services, and this is part of our new series we call whatever the trade is only. And in this video, we're going to be reviewing concrete. So this is part of our concrete only, and we're going to be reviewing a set of construction documents from the ground up. And as the contractor that's handling all of the concrete, where do we look? What do we have to review? And that becomes a little, if you're new at it, then, enjoy the convo I'm about to give you. And if you have any questions on anything that I have presented, please email me at education@sfjohnsonconsulting.com. And so the contractor that installs concrete, there's pretty much a three-way point process that we need to review if we want to look at everything in detail. When it comes to concrete, I mean, we can just do everything based on an assembly price, right? Which assembly price is just going to combine the price for the formwork, the rebar, the reinforcement, and then to pour the concrete and to finish it. But we want to be able to break down a set of construction documents and all of those items individually. So the first thing we have to figure out is which of the sheets are we going to look at to do the takeoff. And so we're going to, over this week, we're going to review, do a full takeoff of the structural set, because the structural set's going to give us all of our foundation concrete. And what we're looking at right here is a copy of the paving plan, because the civil set, which is in the civil set, the C plans, and the C plans are going to show us where all of our driveway, parking lot, curbs and gutters, all of that concrete is located. And really our first step is to do the takeoff, which means to look at the plans and calculate all of the measurements. And, if you do this for a living and you just have to hurry up and get an estimate done, that's not wise. And there's 10,000 tricks of the trade if you have to do that. But as professional estimators, we always take our time, get the measurements, get a reliable cost book, because I can't emphasize enough that if you are going to perform competitive bidding, especially when you're talking about $100,000, $200,000, $1 million projects, you really want to give the best detail as possible. You really want to know how many man hours it's going to take. You really want to have your details squared away. You really want to know how many man hours is it going to take to lay the foundation, as opposed to the driveways, as opposed to the curbs and gutters, because you, as a professional contractor, even as a general contractor, it's really important to keep on schedule, to keep on time, and to, if you're on schedule, you're going to be on budget. And if you're not, then you're not. And so it's important to, as a professional estimator or professional contractor, it's important to get a good estimator, or to get a good combination of a takeoff software and a material cost software and a good formatting procedure, which really, if you have one nicely formatted Excel spreadsheet, you can use that over and over and over again, just edit it. And that's what kind of we recommend. We have specialized Excel spreadsheets for every trade, because we know what should go on in every trade. If it's a HVAC system, well, yeah, we have to include the cost to balance the system. If it's a plumbing system, we have to include the cost for the rough ends, if it's from the ground up, that kind of stuff. So it's important to be able to have a professional format, and Excel, of course, has been used forever. So, and Microsoft has professional contracting spreadsheets, and all of this new stuff that they've created over the last 10 or 15 years to help you create very detailed formatted estimates. And really, sometimes the general contractor will give you the format they want you to use, because they may break down, they want the cost for the curbs as opposed to the driveways, as opposed to the foundation, or they may want the rebar cost, right? Separate from the concrete cost. They want the concrete totals in cubic yards, right? So you got to be able to do all of that. So what are we looking at? This is a coffee shop. So we have a very small plan, easy to review, very small plans, but this is our site plan. And so, yeah, we know that our driveways, right, and our walkways and all of that, and our curbs, and we have to measure, make sure you measure, because the cost is going to vary if it's a straight curve as opposed to the curved curve. Okay, and so we're going to review this, and I'm going to come back with the full takeoff for everything based on this, right? The keynotes. And so you endowed concrete curb. What's the dowd? We got to look at the detail, right? So we have to look at all the details related to, and the civil set's going to give us everything, right? Painting the concrete, the symbols, but we're for concrete only. So we are only looking for everything related to our concrete scope of work. 5-inch light duty concrete pavement, 6-inch heavy duty, medium duty, light duty, sidewalk. Okay, so what we're going to do for our purpose is just get a square foot total for everything and a linear total for all of the curved curves and straight. And then we're going to come back and see what the takeoff looks like, right? So all concrete, and we can start here. I'm just going to start. And of course, you got to start by knowing what your scale is. And on a civil set, the scale's always somewhere special. Here we go. So for every inch, right, it's 20. 1 equals 20. I agree. And then now I can use this. No, I don't want to use the segment tool. Let me cancel that. Let's use our ruler. Okay, so between 1 and 10, this should tell me it's 10 if the plans are to scale. Now that's close enough, right? All right, so, yeah, so I'm just going to look at my keynotes, start with what's easier, and then I'll just call it curb 1A, curb 1B. And then later I'll look at what the construction of it is. And then we've got the 19. You got to make sure you know what that is. Let's see what that is. Okay, 2-foot V-notch curb. We'll just note that. Okay, and so let's see. We go from a 1A to a 1B. And so I'm going to say curb 1A. And I won't make this boring for you, because I'm going to do it all. Boom, boom. And so everywhere where it's straight, I'm going to do all my straighties. And I think maybe at this point here, it starts to curve out. This is a 1A. Do it to here. This one. Because our formwork is going to have to curve. And that's an extra cost for all of that and the labor involved, right? Okay, so we won't make this boring. We'll leave it to there for all the straights. And 1B will be the same way. Now, we need cubic yards of concrete. So what we do is we measure how many square feet and times it by the thickness. That gives us cubic feet. Divide by 27 gives us cubic yards. And so, or did I say divide? It's pretty much division. When you multiply by 6 inches, you're dividing in half. Same thing, right? And so we do what our square feet, let's just say let's just do this right here. And we'll say, which one is that one? Medium duty concrete. So we got an area tool on that one. MED duty, CON. We don't have time to type a lot. We got a lot to do, right? So that's all of this. And so we're going to go back and do our curved curves, but then we're going to just do something like that. Make it all nice, and see, that's our curve, so we're not going to include our curve. You want to do something like that? We just try to stay, and I can make it more curvy. You just got to pan in to get on the curve. Okay, so let me pan out a little bit. Okay, so I'll leave it at that. Let's get a little bit more over here like that. And then we're going to go like that. You know, construction. It's fun, right? It's like coloring. It's like we're coloring. It's fun. When you have good tools. We'll go a little over. Okay, so we got the little apron, right? So if we had to do, and then a good cost book is gonna, you have a different cost for the driveway apron. That's what that is, right? So how many square feet is that? Oh, 554. And so times 6 inches, right? So we would basically divide that in half, 250 plus another 25, whatever, cubic feet, and then divide that by 27 for cubic yards, because you buy concrete in cubic yards. All right, so that's this, we'll just do that all over the place, right? All over this set for either this concrete pad, this one. We don't care about the striping because we're not doing that. Okay, if we were doing that, then we get our linear tool and measure, because it's to scale. So whatever I'm measuring here, I'm going to be measuring all concrete. Now, we have to go to, because from our plan view, right, we only see the plan view. We don't know the reinforcement details. We don't know anything else, okay? So we have to make sure we go to see note below, 15 feet, control joints. How would we do that when it's not shown? Pretty much this is how you do it. Control joints in any area, what you're going to have to do is take your segment tool, because it's not shown, and I'll call it CJs. I'm just going to have to go from one end till I get to 15. Stop it there. Okay. And then the control joint is this way. Same thing. Every 15 feet. I can stop it here. I mean, you're not going to be exact, but you are going to be close enough. Or you could just measure the whole thing, divide by 15. Right? Divide by 15. Do the whole thing, divide by 15. Because that tells you every 15 feet we need to. And then just do whatever this is. 30 feet. So divide by 15. If I got 15 of them, 15 times 30 feet, that's the length of the control joint, because you got to measure your control joints too. And if they're not shown, that's the best way to go about doing it. Okay, so that would be for our civil set. And then we go to our, we'll do the whole thing. We'll come back with all the totals. And you need to join me, because for all of our, we have the new program for every trade. So we have for framing only, for painting only, for concrete only, for electrical only, $9.99 a month. You join me live. You send me questions. You have your own set. We'll set up 45 minutes. You get that twice a month, or as much as you want. I love teaching. I don't care. But the whole point is to give you continuous access to everything related to your trade. So it's not only the estimating, it's basics. It's if you want to get your trade license, then we go over the particulars on that. The basics, anything related to OSHA and construction, right? We know what's related to the concrete and OSHA, right? The silica dust. So we teach you all of that, give you information about that to stay safe. So it's basics, three pretty much aspects. The basics of everything. So basics Could be anything from basic takeoffs to formwork basics. And then estimating, of course, what we're doing here. If you have any questions, we'll answer your particular questions for work that you have of your own. And then OSHA-related topics related to concrete and doing the trade of concrete, how to keep you safe, what's the PPE, what's the standards, what's the violations, all that kind of stuff. And for $9.99 a month, you can't lose. What am I saying? What are we saying? So let's go to, now that I've done my commercial, let's go to the foundation plan. And this is a little project. So they have our roof, and this for roof, well, for frame, for framing only. We'll talk about that one, and the for framing only, and what all this is, and if we have fabricated metals. Is this fabricated metals? No, it's 2x12s. Beautiful. Okay, so here's our top of slab with number 3 bars at the 18th, placed 1/2 inch clear from the top of slab, provide 10 mil vapor barrier. Okay, so yeah, this again, same way we did the control joints. If we want to get the exact how many linear feet of the rebar, we know we're putting it is it both ways, each direction, each way, EW. And so if we do how many linear feet for this way, right? Because we're talking about the rebar that's going to go this way. And so we say we have however many linear feet that is, divide by, well, turn it into inches, right? Turn that feet into inches and divide by 18. Right? Because you're placing every 18 inches, you're placing every 18 inches. So you're going to take that length divided by 18. You know how many positions you have to put the rebar, right? But then you're going to put it this length, right? So that's the rebar for this length. Opposite is true for this rebar, right? You measure how many linear feet, whatever that is, and it is 38, 39 linear feet. So we know 39 linear feet turn into inches. Divide by 18 inches. That's going to tell us how many placements our rebar is. And then those many placements times 18 feet. So you just that quickly have done your rebar totals. Okay. And so what's our continuous footer look like? We need to go to image number 1. On the S 2.0, let's see. I knew I'd go past it. Image number 1, so that's our typical footer. Oh, that's the hold down. Wait, hold on. Yeah, image number 1. Oh, there we go. Wrong page. Image number 1, continuous footer. So, yeah, let's do this rebar, right? You have 2. Number 5, continuous top and bottom with the number 3 stringer at the 18s. Okay. So you can figure that out. We got to figure out how many linear feet of continuous footer first, right? And then our continuous footer is 1 foot 6 inches by whatever this height, by 2. Okay, so we can break that down by how many cubic yards of concrete, and we can determine how many linear feet of number 3, number 5 we need. Very easy and very much fun if you're a nerd. Okay, so for concrete only, we got to be able to do that for our cost estimate. All right, so we got to also, because if the reinforcement is our deal, right, we've got to figure out how many of these we have as well. Anchor bolts, because that's going into our concrete. That's part of our reinforcement for the structural framing. Okay, and so that's why they give you these section views, so you can do the boom, 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 and do the math by the 18-inch, 3-inch, whatever it is, and do a very accurate takeoff. Okay, different section view is going to give us different information. Okay, so we've got to make sure we look at each one individually and do the takeoff based on what we see. Okay, so for concrete only, for this from the ground up, we're going to look at our civil plan, right? Civil is going to give us all of our concrete driveways and asphalt and curbs and gutters, and really the supports for all of our signs and things of that nature. All of that has to be looked at. Okay, our support foundation for our handicap parking signs. That's part of our scope of work too. So have to be aware of everywhere your scope of work is going to show up, but most definitely from the ground up project, you're going to review the full civil set. And then of course you are the foundation, right? The bottom of the building. And so you got to make sure you are looking at the foundation, all the section views, so you can determine how many cubic yards of concrete as well as how many linear feet of each of the types of rebar and the vapor barrier. And for excavation only, we'll go over how we determine how much to cut and fill, right, based from that grading and site plan on the grading plan, and depending on the condition of the site, we may have a site demo plan. We may have a, who knows what kind of band. We may be doing more than just grading, right? Light grading, we might have to do some serious excavation based on all of that. So join us here online at our website every day, usually Tuesdays through Saturday, where we review everything, every trade, every aspect, so you can be excellent at what you do. Thank you for joining me, and I will see you next time. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and now we are going to, in our continuation of the review of our community center, the Friendship Career Center, we want to look at now the power plan and the evaluation as we do the takeoff. And so here, just like the lighting plan, it gives us a general note: existing power devices in this area to remain. Contractor shall verify all existing devices and wiring are proper or in proper working order. Well, again, those sweeping arrows with no indication of how many we need to look at or review or anything like that. So again, I mean, if you want to go by math, you know, outlets will have one every 10 feet. So you can measure 10 feet and say outlet, 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 but we don't know if there's some in the ceiling. And so in cases like that, you'll give it an allowance of hours, man hours to take a look at everything. So I give it 2 or 3 man hours for that. And then estimate how many how many outlets you have. And I would go by the 10-foot rule. Okay, so measure how many linear feet of the open area. So however many linear feet all of this is. Okay, and then divide by 10, then you'll know how many outlets. And so I would just put that on there as an allowance, and note in the exclusions, or don't do anything at all. That's an option. Don't do anything at all and exclude all of that, keynote number 1, and say that you can't properly adjust for the cost of that until you have an actual walkthrough, or you may have had a walkthrough prior to, and then you can fill that in properly. But the whole point is to be able to base your cost that you're given something based on something that's real. Just not having any idea how many outlets you have and what you're looking at is not, for my purpose of producing an estimate where I have to be competitive, it's not going to work. Or exclude the whole thing and say that, we need to have a walkthrough, or do you have an idea based on what how many outlets we have. And see, that stuff like this for an estimator should be an issue. It should be something that like sticks very badly with you, because your job as an estimator is to be very accurate and only base your estimate on what you see. So if you can't see, then you can't give it a number. It's really that simple. Okay, so remember that. But you also have some items here that are noted. Okay. So they are noted, and what we're going to note too is the special way that they note the power home runs. Okay, so these are 3 circuits, and they're all connected through junction boxes. And so this is one circuit junction boxed with the second circuit, because they're all being home run to different positions in the panel with a common ground, maybe. I don't know. I'm not an electrician, you know what I'm saying? But you need to be able to allow for that. And so if we know that it's MC cable, right? Because when we do our power, the electrician is allowed to use MC cable for the branch circuits. But when it comes to the home runs, they have to use the actual number 12 or whatever in wire. So I would definitely, in which I have in this case, because this is an actual estimate, consult with the actual electrician how you want this in actual linear feet, right? Because we have to determine how as close as possible, right, to how many linear feet of conduit and wire we're going to need for the power. And so, again, this indicates that we have a home run going to 3 circuits. This isn't equivalent to it being a piece of mechanical equipment, right, that has 3 number 8s and 1 number 10 ground. That's not the equivalent to that. This is 3 outlets that they have joined in this way, and 3 circuits going to this panel. Okay, so that means that 3 times the home runs are going to that panel, where this is just the home run, right? But this indicates it's 3 times the home run. Okay, so we have to make sure we present it in that way when we're doing the actual measurement. And here's the panel right here. So not very far distance. Okay, so not very far distance. That is the tricky part. So make sure you're looking for that notation. 2 times the home run. 3 times the home run. Okay, very, very tricky. Right, what else do we have? That's the communications, and we'll do a separate video for that. We already looked at all the lighting. And remember, this is a building that has multiple rooms that are being renovated, right? So, and of course, if we were doing this for real, right, we would look at the specifications, make sure we know what's what and where's where. More of the communications plan. Lighting plan, vague, and then power plan. See, these are easy, right? Easy. Easy. Communications. And then we have a bigger power plan, so the larger power plan. Okay, so you know the story with the larger one. We do all of our counts. Make sure you're identifying each of the outlets. Are they GFCI? Are they just regular, right? GFCI maybe. Read the keynote. Make sure you know everything about what it's trying to tell you, right? So the home run is going to, this looks like K1 is the kitchen panel, position 8. And you'll note when we're doing kitchens, right? Most of the equipment outlets are going, everything, nothing is daisy chained together, as we discussed pretty much, branch circuited together. Most of all the outlets have its own direct home run to the position of that panel. Okay, unlike this. What is this? This is just connecting this to this and home running it. Okay, so junction box just connects one thing to something else. Like this, whatever one is, this junction box is connecting that piece of equipment to the power source to the panel. Okay, so this is a lot different. We got a lot of different outlets, a lot of junction boxes. Here is that home run we're talking about, going to 3 circuits, branch circuits in between all of the junction boxes. So this is just a bigger project to do a lot more counts. Okay, and because we have different panels, I always recommend your home runs, run them when you're doing the work. Note which set of home runs is going to which panel. So you'll have a total for home run K1, home run A2, or however many panels you have, and we'll go over the single line diagram. Okay, so existing panel A2, existing panel A3. Okay, so when we have existing panels along with new panels, and we'll go over it again with the single line diagram. But when we have existing panels with new panels, we do have to do something to the existing panels, reconfigure the existing panel. And so that's going to take a certain amount of labor. So you always want to include that. We call that balancing the panel, where we have to reconfigure, reconnect something different to it, or even connect it differently to the main distribution panel. You always want to account for that time that's going to take, and I give it, a couple of hours. So, I mean, that's really up to the electrician, but that's something that don't forget. Any of the panels that are existing that have to be reconfigured for the new equipment, the new everything, because now they have to, and just put it this way, when panels are connected, they're connected in a certain way for a certain power, distribution, consumption, all of that. So when you add new panels to that, then you're redistributing all of that. And so in some cases, most cases, the existing panels need to be rewired in some way. So you just don't ever want to forget that. And when we look at the single line diagram, you'll be able to see where that comes into play, and you'll be able to note that and add some man-hour totals for that. Okay, so power plan, pretty big, a lot of branch circuits, some home runs. Make sure you separate all the home runs based on whatever panel that they're going to be running to. That's very important for this exercise, and it helps you to easily determine, if you've covered a home run. Because I know the home run, well, when it does it in PlanSwift, it's going to give it a different color. So I know all the blues were the K1s, and I know the purple was the A2 panel. So it helps me visually make sure I take care of everywhere I see that there's a home run. And 2, for the mechanical equipment, you want to make sure that you leave probably that for last. Okay, because for the mechanical equipment, it's not going to be number 12 wires, right? It's going to be 3 number 6 for the rooftop unit, 3 number 6, 1 number 10 ground, and a 1-inch conduit. Okay, it also tells you here the disconnect. Okay, and we know it's a fusible disconnect because it's telling you the size of the fuse. Okay, so for this, you have to incorporate the wire, the conduit, and the disconnect. The disconnect is not the same as the breaker in the panel. Okay, so keep that in mind. So for mechanical equipment, yes, you have to remember to account for the disconnect as well as whatever the panel shows you. And those are breakers. Okay, so in terms of running the home runs, I do all of the panel home runs. right? And then, yes, I go through the task of each of the pieces of a mechanical equipment over here to the left is accounted for with the distance. See, U3, we got at 45 linear feet. And remember to add the extra 10 feet because all of the mechanical equipment's on this roof, right? So you want to bring that conduit down to down through the roof into the panel. Now, as far as what type of conduit specifications, of course, it's going to tell you if it's EMT, and you could use different, right? Because if it's underground for any period of time, it's going to be PVC. If it's inside, it's EMT. If it's outside, it's rigid steel. So, or, you really, when it comes to the mechanical equipment, it's really important to make sure you know what type of conduit, but for the purpose of our exercise, and because I don't provide you with the specs for it, use EMT. Price it for EMT. You can price for EMT or rigid, whatever you feel, but not for PVC. Okay, either way it'll work. But rigid is way more expensive, see? And so they'll always try to use the least expensive route when it comes to the conduit. But again, the specifications, that's the whole point of the specifications, to tell you what material you're supposed to use for every piece of the scope of work. Okay, so as far as the power, first thing, count all the devices, right? Count all the duplex outlets, all the specialty outlets, because we have a kitchen, right? We have to make sure we look for the kitchen schedule, because if they're NEMA, right? They're not going to be, they may or may not be noted on the actual plan. And so this is what I do. So if I know I have some NEMAs, right, on here on a schedule, but I don't have them marked on the plan, they may or may not be. And so I'll just go ahead and I know that those are quads, probably don't apply. So I know that an AC, remember, it's above counter, so make sure you know too. Above counter, below counter. Well, if it's above the counter, it'll have AC. Otherwise, it's in the normal position where they show you every outlet's going to be. Okay, so I have to make sure too. I look at all the keynotes because there's a ton of keynotes on here, and you look on the keynotes for what? If they ask you for a particular type of material or conduit or anything where it applies to the takeoff, right? So you always want to make, because some keynotes just apply for the electrician to tell them where to put the device, right? Well, that has no bearing on your takeoff. But you do look at the keynotes always, because you want to see, does it have bearing on my takeoff? Okay, wherever that is. Where is it? I don't see anything on here that goes to 24, 26. It must be somewhere else, but yeah, we'll look for it. You look through it, or it may be these item number. So this is going to tell you which piece of equipment. So that's going to be on the piece of equipment. That's how many you have. So you know that you're going to count the outlets, and then subtract from the full list if it's not telling you which ones are the NEMA 5, 15, or whatever. So I'm going to count them all, and then I'm going to go back to my equipment schedule and subtract for each one that I accounted for. Now, they should be, if they're in the kitchen, they should be GFCIs, right? And so you just have to figure out the method you use to not double count your outlets, right? So you could just count the outlets, period, and don't be concerned with this. And note in the end that, yeah, the kitchen ones, the ones in the kitchen, and find the kitchen. Where's the kitchen? That's corridor. This is the kitchen. So you're just going to assume that all the ones in the kitchen are GFCI. Okay, this is the kitchen. So these outlets here should reflect the number of outlets on your kitchen schedule. Okay, so that's the tricky part about kitchens. They're going to give you a kitchen schedule with the outlets, or they may have a direct connect. There's no outlet. I think I saw a few that were, oh wait, up here. One's connected by junction box. So that tells me junction box, probably hardwire if it's a junction box, you know, and then direct connection. That kind of tells me that's a hardwire too, so may not necessarily be any kind of outlet, right? You take whatever comes out the back of the equipment, it's going to give you a set of wires. That's a direct connect through the junction box to the panel. So these are the only two things that would not have but then there's a Note 26. So yeah, that's probably what they're talking about with the numbers are. And you see, we're not 1, 2, 3, whatever. So they have 2.1. So it's important to match these outlets up with the outlets that you count. But remember, those outlets are strictly just for the kitchen area. Okay, so, and that's, yeah, just for the kitchen area. And read the keynotes, because there's some keynotes that are unfortunately not on the same sheet as the plans, which poor set of plans, let me tell you, because it's not supposed to be that hard to go back and forth. Okay, and so we have 1, 2, 3 circuits. So for the purpose of this, we're going to have 3 times the home run. Okay, so home run times 3. Okay, keep that in mind. Home run times 2. This is just 1 home run. Okay, so this one's just a little more difficult, and more detail involved, because you have to look. Is it 1 home run, 2 home runs, 3 home runs? I might have saw. It may not be this one. I saw one that had 6. Because you have to account for the number 12 wire that accounts for that home run. That's why it's very important to make sure you sign up for your weekly classes and that we meet them. I've had some difficulty because of the holiday, but it's over. And we have to meet, because these are the kind of questions you need to be able to ask me one-on-one to get the full understanding. The power plan, yes, is the most challenging of all the plans. But if you just think about step 1, step 2, step 3, and reading all the keynotes, especially when it comes to the electrical plan, so you can make sure you understand what they're telling you as far as the conduit you're supposed to use, the wire you're supposed to use, the home run, and where are the panels, right? They give you the single line diagram, which we're going to go over later, but that's not giving you any indication where the panels actually are on the plan. And so you have to make sure you know where the panels are, where where they are in terms of the main distribution panel, because what do we have? The power comes into the building, and then it comes into the main distribution panel, and then that conduit, those power feeders, right, are shared or broken off to existing panels, and then existing panels, and then new panels somewhere in here, kitchen panels. Okay, so you got to make sure you know where all of your panels are. Where's another panel? We'll look in more detail. Wherever the wires are jumbled up, it's probably where there's a panel. Yeah, there we go. Kitchen panel KP1 is here. So you're probably going to need to know the distance for the power feeder from whatever KP1 is branched off of. It's branched off of either one of the panels or the main distribution panel. And so you're going to need to, that's another step, getting the lengths of all of the wire and conduit, but then also looking to see where the panels are, if there's a transformer, where that is on the power plant, where all the panels are, transformer, main distribution panel, And then if we have to go to the site plan, if it's from the ground up, which this one isn't, the one before was, where is the utility transformer in terms of the main distribution panel? So those are all of the things that you have to go back and forth and look at between the single line diagram and the power plan. Single line diagram is going to show you in one line how the panels are in relation to each other. And then for visual purposes, it gives you the wire configuration. So you can determine what wire needs to be the feeders between the panels. But it doesn't give you any indication of the actual lengths between the panels or the main distribution panel. That's where you have to go back to the power plan, scale it, and get your actual measurements. So this is a long, drawn-out explanation of that power plan for the renovation for the school, but it's a lot of stuff. And that's the whole purpose of us getting together and going over this, because each one is supposed to get more and more difficult. If you have any questions, email me, and make sure you sign up for your weekly help, which can be more than twice a week if you so choose. So email me at education@sfjohnsonconsulting.com, and otherwise I will see you at the next class. Thanks a lot, guys. Talk to you later. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and we will be talking about the why should I be a drywall contractor portion of our discussion on the whys. And, drywall is one of the most important trades because every room has drywall. But what's more important is that if you are going to become a drywall contractor, that you pay close attention to all of the OSHA standards if you're training or whatever, because that silica dust that is associated with the finishing of the drywall can be extremely deadly. The labor is very labor intensive, so you make good money doing it, but you just need to always make sure that you are following OSHA strict standards when it comes to the finished portion of installing the drywall and all of the solvents that's used in the mud and all that, mixing all that stuff. It's very important, not only in drywall, but every aspect of the construction trade. If you are going to be coming into contact with chemicals of any kind, any solvents in the air, dust, particles in the air where you are, you should always make sure you're wearing the proper PPE, okay? And so, remember, we're talking about if someone is going to get a license in this trade here in California. The drywall license is a C9 license, and there are 5 portions, and then we'll go over each one individually, and there will be a class for each one, a small video for each one, because we will be teaching and training and helping our students and clients to pass the class. So the drywall C9 examination, that's what we'll be talking about and what's involved in getting the license. So, of course, with everything, it's planning and estimating. So knowing what it takes or what you're looking at when we're talking about drywall in the planning stages of a project. And estimating, of course, you have to know what's involved in that. You have to be able to evaluate the plans, of course, and the specifications. There's drywall specialties, so when it comes to firewalls and that kind of thing, you have to be very familiar with what that is. And of course, when you're going to get your license, again, I can't emphasize it enough, it's not something you can just decide one day, okay, I'm going to go get a license. Well, you have to have hands-on experience for a number of years in order to qualify, in order to be proficient enough to qualify for the license. So these are things that you are going to naturally learn as you go to work every day. But these are things that you also want to keep in mind and keep a journal of and know that these are things that you know. And these are items also that can be put on any resume. So it's not just, I know drywall. Drywall, in order to install drywall, there's a number of things that you have to be familiar with. And so when you get your license, these are the things that you're going to be tested on. Okay. And so the planning and estimating portion, again, evaluate the plans and specifications, estimate the cost, and perform the mathematical number. So how many square feet of drywall do you have, and evaluate material specifications. So, being able to know the type, and are you using, what's the dimensions of the drywall that you're using. You want to make sure you know all of that. Okay. And how many sheets of drywall you need if you're using the 32 square foot drywall and you have 5,700 square feet of drywall to install. So how many sheets, that kind of stuff. Of course, you'll be able to do that. Next is preparing for installation. So there are certain portions of that, like evaluating the job site readiness. So our, prep, basically. Managing materials on the job site, lay out various assembly types, install metal framing systems. And so, yes, drywall, specialty, you're going to lay it on the framing. So, yes, they do require that you know the metal framing portion and to install backing onto the drywall. That is part 2 of the preparation for installation. And that's 14% of the grade, where the planning and estimating portion is 20% of the grade. Part 3 is install drywall, ceilings, and related materials, and that's 28% of the grade. And in that, we'll be studying and focusing on installing various ceiling assemblies, installing standard dry board assemblies, installing fire-rated wallboard assemblies, installing specialty wallboard assemblies, installing trim, repairing damaged drywall systems, and then to follow the EPA and Cal Green, and this is for California, requirements for waste disposal and recycling. So that is, again, you'll be tested on those portions if you were to take the test to get the license, and we do teach you on each one of those. Part 4, finishing, 22% of the grade. So they want to make sure that you are proficient in select and mix various compounds, prepare and tape surfaces, finish and coat surfaces, sand and or sponge wallboard, select level finish, the level of finish, level 1, 2 through 5, texture surfaces, and that would be the finishing portion of your license, and that would be 22% of the grade. And last but not least, it's always the safety portion, which is 16% of the grade. So, right, first thing here is, how do you apply personal safety procedures? Okay, when we're talking about drywall, and that is, again, very important because that silica dust is very dangerous. Apply job site safety procedures. So you have to know your personal safety procedures and the job site safety procedures. Operate the tools and equipment for safety. Handle and dispose of products safely. And last but not least, work safely at elevated heights. And these are all of the 5 points if you were to get your drywall here in California. It's a C9 license, and those are the topics that you would have to be proficient in answering the questions to. Keep in mind, we do assist you in every aspect of that, so you can pass your test the first time. If you have any questions at all, please email me at education@sfjohnsonconsulting.com. Otherwise, please join a class. We have a variety of different platforms and classes where we guarantee that you will learn a lot. Our students are very happy with the service. It's fun, and it's named after me, so I got to make sure you know everything. Thank you for joining me, and I will see you next time. Thanks a lot. Bye-bye. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services. Just want to quickly go over our construction basis and our framing and rough carpentry information. If you were to want to get your license, or you think you're ready to get your license, and this is also part of our why do I want to be a framing and rough carpentry contractor? Why would you? Just like I say, for any of the small businesses, usually a rough carpenter, a framer starts as a small business, which gives you tons of independence. And now the construction industry is really losing all of the workers. They're all getting old like me, and we are trying to do our best to help the young folks know that being a part of a construction trade is very lucrative, is very it's important to America, really, and it's fun. You get a lot of freedom when you are a contractor, whether because most of them are small businesses, so you work when you want to work, and you run your own life pretty much. You do have to work under someone, of course, when you begin, but that's a short amount of time, just like getting a degree, a very short amount of time with respect to the life that you can live once you learn the trade, practice the trade, and become very proficient. So this is just a little introduction as to what you would need to study in order to be able to proficiently pass any exam pretty much in any state in the United States. So construction basics for the rough carpenter. So what do we need to know? Pretty much in every one of the trades. So here in California, it's the C5 certification, and that's the examination that you would take. In all of the trades, you have to have a planning and estimating portion. And for the framer, we look at the areas, and we also teach this as well. So if you are trying to get your license, email us at education@sfjohnsonconsulting.com, and we can set up a private study plan and curriculum for you so you can pass this exam the first time. So part of the planning and estimating portion, which is 27% of the test score, is project planning. So you got to make sure you know the terminology and all of the pieces and parts of a project when it is being planned in terms of your trade. The blueprints, specifications, and shop field drawings. So you of course have to be proficient in knowing how to read those with respect to your trade. Three-dimensional drawings, have to be familiar with that. Estimation, of course, and math-related estimation. So we would go over assisting you with construction math with the word problems that would be related to what you need. There's a specific way to determine the slope of a roof, all that kind of stuff. All right, part two would be the structural framing component, and that would be 36% of your test score. And for that, we'd be going over the framework, load and span for our structural, like roofing, pretty much roof trusses, bracing, shear walls, structural hardware, wood and metal framing. So that's part of the structural framing component. And again, we would walk you through each one of these, test you extensively based on the questions that you would receive in your state exam. Part three would be general framing. So let's see what we have. The flashing and weatherproofing. Well, I say waterproofing pretty much, but it is the weatherproofing, right? Siding, roofing, and flooring, doors, windows, and stairs, fences, decks, porches, and gazebos. Let's see, access to ventilation, materials, tools, and equipment. So that's the general framing, 21% of the grade. And last but not least, as always, the last thing would be safety in terms of, and in this portion, it specifically states OSHA and Cal OSHA requirements, EPA requirements and regulations, asbestos and environmental hazards, and transportation and traffic control. So those are the four components. You would have to study extensively with the subparts of that to get your license in framing and rough carpentry. Any questions, any assistance in passing any of the tests, or just getting some test questions on each of the subcategories, let us know at education@sfjohnsonconsulting.com. Otherwise, I will see you at the next class. We have a lot of good stuff coming up now that school started, a lot of good programs for our clients. So hope to see you soon. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and I am very excited to start even today with our Why Should I Learn a Trade and What Should I Know? Because I've been getting a lot of requests for the concrete contractors as far as, the proper way to, all the book work that they need to know, and so we're going to start with that one. That I'm very excited to say. And so what we're going to be doing, and let's go over to what is comprised with that. Okay, so we're going to go over this week, and I'm probably going to have one of these for each of the trades that I mentioned in the GC one, because I kind of mentioned all of them in that one where I really need to do a separate intro for why should I study a trade in? What do I need to know? I probably need an intro, but the full list is on there. So I'm going to try to set up special channels for each of the trades, and 2 on our website. We have lives every day where we do some live training. So I would say spend the $40 a month. You can cancel at any time and learn this stuff with us, especially the OSHA safety stuff, because all we need is 3 students in the class, and we typically have more than that. So you can join a class and get your OSHA 10 or OSHA 30 certification for the same $40 a month, and learn every aspect of everything that you need. So if you are a concrete contractor, we're going to be going over, and remember, these are the major examination points, or the major things, whether you're getting a test or not. If you're in construction and you're in concrete construction, these are the things that you need to know, right, to do your job proficiently and to have that book knowledge. Well, before you got your driver's license, right, you had to study that book and pass that test first, right, before they put you behind the wheel of a car. So whether you are going to get your license or you just do this every day, as your job, and you're just a concrete person, there's no just, because that's very hard work. You're a concrete person. You want to know the most about your business, because one day you'll have enough man hours out there, right? On the job hours to get your own license, start your own business. So we want to teach you how to do everything the correct way, like our mommies and daddies told us to do when we were babies. Let's get it together. All right. So concrete, we have these always some 5 divisions, right? So planning and estimating. You have to be able to assist in the planning stage, know what you're looking at when the project is in the planning stage with reference to your concrete, and of course in estimating. So that section alone, we're going to come planning concrete projects and estimating concrete projects. That's that part. Next, in the pre-placement preparation, that has 4 parts in that. So we have to learn how we go about the demolition process, the grading and excavation process, and then the layout form work. We got to figure out how we determine the form work in terms of how much lumber do we need and how many linear feet and what's the size and height. Installing drains and moisture barriers, installing reinforcement, and embedding items. So with that, we'll go over rebar, how to determine rebar totals, and everything's based on looking at the set of construction documents, right? So that's what they're there for us to get a very good digitized software, to take very good measurements, and to come up with a good pricing from somewhere, either on our desktop or with our supplier, and come up with a cost for this stuff. All right, so that's the pre-placement preparation, and in the placement and finishing, we'll go over placing the concrete, applying the finishes, and curing and testing. So the different curing and the totals, when do we know how many percentage this, that, and something else. It's all in a book, and we all need to know it. Whether, again, we're going to get our license or we're doing this every day, uh, at work. Okay. And let's see, post placement task. We're going to go over applying stains and sealers, stripping forms, repairing, grouting, and caulking concrete. Have you ever seen the vertical walls being built in the formwork on high rise buildings? That is the most fantastic, amazing thing God ever created. And we'll be going over that too with the awesome videos. All right. And last but not least, we always got to talk about safety, right? How we keep you safe. What's your PPE for the concrete person knee deep in chemicals, right? Inhaling, cutting the concrete. What's standard? What are we supposed to do to keep our concrete contractors living into their 90s? Okay. So that will be the last part. So again, join us this week, and please study with us on a regular basis. Like I said, $29. Why'd I say 40? It's $29.99 a month. Sign up for SF Johnson Presents Live, and you can join us live, study, get all the study material, get your own student site where all this stuff will be up there for you as long as you're a student. And continuous learning, that's what we need to do around here. So thanks a lot for joining me, and please email me any questions, concerns, or whatever. And if you like the video, please say so. Tell your friends, especially your contractor friends of all trades, because we're going to be covering everything. So have a good, today is Sunday fun day. Have a good day, and email me at education at sfjohnsonconsulting.com. And I will see you next time. I'm on a roll, so let's go. Let's go. Hey, it's football day. Have fun. I'm more of a basketball girl myself, but in baseball, slow as that is, but have fun. See you next time. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and I wanted to introduce you to a new set of videos that we are going to produce called Why Should I Learn a Trade? And this is to help young adults understand a little bit more about each of the construction trades, what they are, and more importantly, what is comprised in knowing and learning about the trade. And really, it's also set up for individuals that are trying to pass the test for their trade license. And because we're in California, a lot of this is in reference to the California state laws. But in any state that requires you, and California almost requires a license for everything, even construction, cleaning, everything, this would apply to pretty much any state, and what you would need to know, or what is recommended that you know. And so, again, we try to help young adults know being a part of the construction industry can be a lot of fun, very profitable, and can be a career that just takes you places you would have never expected, and a regular 9-to-5 definitely could not take you. So here we go. Why should I learn a trade, and what do I need to know? So what we do is we talk about, this is pretty much part one, and this is what we cover in this first part. So it's quite a lot. Basically, what is the trade? And then we go over ones in particular, and we start with the biggest one. We start with the general contractor, framing contractor, concrete, drywall, HVAC, painting and decorating, roofing, solar, sheet metal, tile, and most importantly, why do I need to study law and business? And let's go to the next page, and we'll go over the law and business as to why. Well, what is a trade? And why do I need to study law and business? Because my last sentence here, that most contractors, or most of the subs, and even a great majority of general contractors, are small, self-owned small businesses. And so as a small business, you need to understand how you will prepare your business. Are you going to be a sole proprietor? Are you going to be a limited liability corporation? Are you going to be, what is your business structure? And those are the types of things that you need to know. And it also goes over insurance requirements, bonding requirements, and it's vital to know that, and a lot of things you need to know as a business owner prior to having to hire an attorney if you need to, right? So you should know some things, especially as a small business owner. And majority, again, of small business owners, subcontractors are small businesses, family-owned businesses, and that's a excellent reason. Big corporations have a legal staff. Well, as a small business, you need the same thing. So, what is a trade? Well, every definition, I tried to get the most basic definition. This is actually a dictionary definition. They include the word trade in the definition, right? And I'm kind of up there in age, and I've always been taught that you don't use the word to define the word, but they do everywhere I look. So construction trade means any trade or occupation involving construction, alteration, remodeling, repairing, wrecking, or demolition, adding to or improvement of any building, highway, road, railroad, dam, bridge, structure, excavation, or other project, development, or improvement to to other than personal property. So, other than personal property. Okay, so the difference between personal property would be more like your cell phone would be personal property as opposed to your house. That's how I guess they want to put that in there and add that to it. So a trade is basically any of the professions that are used in building or renovations. And so, we're talking about framers, drywall people, everything. Painters, drywall, concrete, underground utilities, excavation, survey, just about everything. Photography, aerial photography. There's so many different aspects of construction, but a trade is someone that has the profession that they are contributing to the alteration, remodeling, repairing. And so we're going to go over individual ones. And our first one we're going to start with is the general contractor. Okay, so the legal definition is a person or business entity that contracts to be in charge of a building project, usually involving the use of subcontractors. General contractors manage and hire subcontractors while acting as the primary contact with construction clients. And so it says here that a bachelor's degree is usually required, although I have many friends that don't have bachelor's degrees but are general contractors because of the experience that they have, and so they're able to take the test. So, bachelor's degree is great to have. And I mean, nowadays, usually it's very rare that a student actually later on in life is in the profession that their degree is in. I know I was a claims adjuster for quite some time. I have a degree in electrical, so it's this, the degree having part that helps you, and people don't know, it's not so much what you learn when you go to school and get the degree, it's the process of getting the degree that is the valuable process in life. It's the process of going to class, studying information, passing tests, writing papers, thinking about stuff. That is the most valuable part of getting a degree. It's not what's on the paper. So, they try to confuse, you have a degree in whatever. Yeah, in most places, most businesses, you can take your bachelor's degree anywhere and get any job because it's not the degree. It's not what you've learned. It's the process of learning that's valuable. Okay, so kids, don't let them confuse you. And in all cases, that's why I recommend, you may not want to get a bachelor's degree because there is such value in becoming a contractor, general contractor, a flooring professional, a HVAC professional, and electrical professional. There's so much value in that as opposed to getting a degree in some field where you sit at a desk. So I always advocate, and really you should be able to do a little of both, because if you're going to become a business owner, you got to be able to sit behind the desk and then go also out into the field and do the work, right? So, and usually, of course, you're going to start by working under someone, especially in the trades, is going to be required that in any of the specialized trades, you have to get the book knowledge, but yeah, you have to get the hands-on, in the field training too. And so that's very important. So a general contractor is required to have a full range. They are the general contractor, which means they handle all the other trades, make sure all the other trades are doing what they're supposed to do, all the HVAC, the plumber, the excavator, they help to make sure that the project schedule is staying aligned with the plan and the money, right? And so it gives a little information. And I start with the general contractor because, yeah, they basically take care of all of the other trades and make sure the project is going to plan. And if it's not, they have the crew and the staff with them to get things in order. And so it gives us a little 2020 construction managers made about $98,000 per year, the median salary, with an 8% growth outlook over the next each year through 2029. So it's not such a shabby thing considering you're managing people. You may not necessarily be, humping it, but you are managing people, which is a very important thing. Okay, being able to manage people is very, very important. All right, so what does a general contractor need to know? Now, this part, these are giving us the general portions that would be on any test. So if you're going to be tested to be a GC, these are the things that you need to know in general. And under each of these points, there are specifics. And so we're going to be in the future having videos on each of the specifics. So we'll have a new video on general contractor planning and estimating. And what does that consist of? And then we have to go a little deeper because that in itself has 6 points. So there are 6 points within the planning and estimating and what the general contractor needs to know. And here it is: scope of work and code compliance. Okay, so scope of work means that the person knows the details of that project. They're able to look at the project and break down the scope of work based on what's needed. So if I'm building an Arby's, I'm able to look at the full set of plans, which is basically the scope of work. Scope of work is technical terms in construction for this is what I have to do. So the scope of work for a framer is to, if you want to get into details, set the bottom plates and, are we talking about structural framing or A-plan non-structural framing? It really depends. So scope of work is very specific to what you're doing. So it's what you're doing is your scope of work. Okay, and code compliance, what's that? Well, you have to know for that state, for sewer pipe, am I allowed to use PVC or is it all cast iron? Right? That's code compliance. So each of these topics will be individual videos. Okay, so that's just, like I said, to become a general contractor, there's these points. And within each of these points are individual topics. So within planning and estimating, there is one scope of work and code compliance. Just talked about that. Design and construction error identification. So when you're in the design phase, the GC needs to be able to assist in that or know what that's all about and identify problems or errors within the design of the plans or the whole, even within the design. I mean, this is really good, GC, but in the design of any of the mechanical, electrical, and plumbing scopes, they're able to identify. That's a really good GC. But again, a general contractor's job is to be able to look at every scope of work, everything performed by each of the trades individually and know that they're doing what they're supposed to do. Okay, and so design and construction error identification for all of the trades. Shop drawing, plans, and specifications. So you need to be familiar with the question. These will all be questions that you'll have to answer in with regards to shop drawings. Maybe they'll ask you things about scale and, it really depends. But of course, if you're going to this someone that's going to be a general contractor is not someone that's a young adult, probably a little older, that again has had years of experience in all areas of construction and feel that they're able to take the test to cover that. So again, this is for someone young. This is something that you'll want to aspire to, definitely. Yeah, I want to be a general contractor. Yeah, well, this is what you have to do. These are the steps that you have to, over the years, work your way up to being very proficient. And of course you can. Field inspection performance, coordination of the project. So are you got to think about construction schedules, that kind of thing. And again, each of these topics will be individual videos that will go into detail onto, okay, what is that? So don't let your brain explode right now, right? Because to be a general contractor, you have to be the GOAT. You got to know all this stuff. All right, so cost estimation for material, equipment, and labor, and that's all we have right now on the videos, right? You got to be able to look at a set of construction documents and come up with the cost estimate. All right, so that's just planning and estimating, and that's for California, that would be 24% of your test score. Okay, next, framing and structural components. Well, of course, now it gets to more of the core building stuff, right? So the framing and constructional components, that comprises of 6 things itself: subfloor and wall framing, roof framing, seismic and load requirements, decks, siding, and stucco. So that's siding and stucco. Why that's part of framing and structural components, I have no idea, but it is. And again, each of these, we're going to have details that a person that is trying to pass this test would feel that they're proficient in taking some of the, taking the test. All right, number 3, core trades. Here's where it gets into, you have to have experience. You would have probably been a project manager, maybe even performed one of the trades. So yes, you have to have a good proficiency and be able to answer questions about plumbing, electrical, HVAC, concrete, earthwork, and surveying, insulation, acoustical, and weatherproofing, and then roofing. And so that would be 26% of your full grade to answer those questions. The framing and structural component would be 23% of your grade. And last but not least, we have 2 more sections, finished trades. So you got to know about painting, staining, coating, interior wall covering. Have to know about tile and stone, floor coverings, cabinetry and millwork. Those are all finished trades, right? Plaster, drywall, and ceilings, windows, and landscaping. So finished trades is everything in your architectural set, right? Core trades is everything in your structural set, right? And your MEPs. Okay, core trades, structural set, MEPs. No, core trades, if we're talking about earthwork, right? And so we'll be able to look at each of those. So plumbing set, electrical set, concrete, well, we got to look for that. That's in a couple of places in a full set. So the concrete could be either the site concrete or it can be the structural concrete for the foundation, right? Earthwork and surveying. So the core trades is just a combination of being able to look at a full set of construction documents, A, S, C, okay, and know what the scope of work is, know what each trade has to do, know how to price it, know how to organize it. When the project is ready to go, who comes first, who comes second. Okay, so that would be part of our cost estimating. And then what part would that be? Where we would do a coordination of projects. So that would be basically construction schedule, coordination of projects. So we'll go over a lot of stuff when it comes to that, because that is the most important part. That's where the project manager comes in, right? For the general contractor. The general contractor has everything, right? And then have the project managers that assist them in breaking down every aspect of the project, coordination of project. All right, finished trades, we know what that is. And then last but not least, and I think the most important part is the safety, and that would be 8% of the grade of the test that you would take. And personal safety, transportation and traffic control, and then environmental safety are the three components of that. And so, if you were to want to become a general contractor, again, that means you're able to assure the owner of the project that you can coordinate all of the subcontractors and get everything working and rolling in line with the construction schedule within the budget limits. And if not, you're able to employ your team to fix everything. Okay, so again, we will have videos on, and then of course you can assume that the GC videos will be numerous, and so that'll probably be its own, no, probably not its own channel, because this is new, and so probably, I don't know, my mind isn't really figuring out how I want to separate this, but this will be a separate channel for you to go through the videos. And again, it's why do I want to learn a trade? Why do you want to learn a trade? Because of the independence that it gives you, right? That's the first and foremost. Just me working for subcontractors and working for general contractors, it's offered me independence. So, and I can teach you to either, well, definitely to work in the office, right? With all of this stuff, if you're proficient in it with the paperwork on this part, you can easily work in an office for somebody that's doing this on, as a small business. So you could either use this information to become the trade itself or to be a administrative partner to the trade like I do. So, it's vast. So why you want to learn a trade? Maybe to do it, right, yourself, or to assist, which is the fun part, because you could just learn so much more because you can ask the sub so many questions about what they do, and that just helps you be better administratively. So there's a lot of options, but we start you with general contractors. Our next is going to be, and so we're going to do a full review. Well, the next is going to be law and business. You know why? Because that's important. We need to figure out how the business structures are put together, the organizational structure, how the finances, employment regulations, all that kind of stuff. So that's next, because someone actually did ask me, they want to learn more about law and business with respect to construction. So keep in mind, each of these presentations will be a snippet of a class that we actually give. So if you have any questions or would like to take the test, or if you think you want to take the test for the trade, or you've been thinking about it, you definitely need to study, right? Because it costs money to do it. Let us know what state you're taking the test, and we will be able to guide you better on the specifics of those classes you need to take. And again, because our home office is in California, we are all always talking Pacific time and California regulation. So if you have any questions, you would like to take the class, or just have any questions in regards to any of the things that we do teach, please email me directly at education@sfjohnsonconsulting.com. Otherwise, I hope you enjoyed this. Please let me know that you did or did not. Okay, and I'll see you next time. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and I just wanted to introduce you to top 10 cited violations number 3, and we're talking about respiratory protection, failure to provide. And what is the standard? Well, the OSHA standard is 29 CFR 1910-134. It is in the general standard, and also in the general standard for the construction industry as well. It requires that employers provide employees with respirators that are, quote, applicable and suitable. And so what does that mean? Well, if you're going into a confined space and vapors and that type of thing, you can't just go in there with a N95 mask. Okay, so they have to evaluate the situation, as in all cases in construction. They're always supposed to evaluate the situation and give you the PPE that is appropriate for the situation. Okay, so applicable and suitable for the purpose intended when such equipment is necessary to protect the health of the employee. Now, the OSHA standard is going to tell you, uh, it is going to be necessary for respiratory protection if you are in a situation where, and it is specific in the standard, we're not going to go into the specifics, but basically, like everything in OSHA, if there is a possibility of hazard to your health, or you may ingest through breathing, right? Respiratory is all about your breathing. If you may take in something that is dangerous for your health, where you're required to be protected from that. Okay, so there is a hierarchy of controls, and if it is determined that the type of work you do requires a respirator, then they must have a respiratory protection program. And the program requires an administrator that's qualified and knows how to train and knows when the respirators are defective, knows the different types of respirators that are needed within the different situations. And also, the program requires that, of course, all of the PPE to the employee is to be provided at the expense of the employer. Okay. And so let's go over, they talk about if you can't perform engineering controls and administrative controls. So I just want to go over what that is and then go over, and this one's going to be a little longer, where we're going to go over a short video that goes over this, because this is really, really important in terms of your health. I mean, every year when it's time to saw, cut concrete, that's the one thing you always see, right? You'll always see that silica dust in the air. So that's pretty much what we're talking about right here when we're talking about respiratory programs and protection, because that silica dust goes right into your lungs, and over time it affects your breathing. So let's talk about engineering controls in terms of respiratory protection. Well, what is an engineering control? Well, basically, it's a change in the design. So I've performed, let's say, for welders in the sparks, right? I will perform an engineering control where this is the control part, where we'll only have them welding in a specific area at a specific time. And there'll be an enclosure, right, where the sparks can't go beyond the enclosure. Okay, so that's an engineering control, as opposed to an administrative control where they will, it's more about admin. What's admin? That's more changing the times, including relief workers, exercising breaks and rotation of workers. So we're going to move people out of the way when we have to perform this work. So that's more of an administrative control as opposed to an engineering control. Okay. And so what we want to do now is show a short video from OSHA in terms of the different types of respirators. That's what's important. I mean, most of the time, I don't even see the gentlemen, because it's usually gentlemen that either doing the drywall, right, with the silica dust, or cutting the concrete. It's all still that same silica dust. Never see them with the appropriate PPE. In some cases, with the drywall, they're covered in drywall. They're covered in the silica dust with no mask. 20 years, they're not going to be able to breathe if they do that every day. And so what I'd like to do right now is show a little OSHA video on respiratory protection. We're going to make it big, and then I may stop it every now and then to have a personal comment.
This video provides a brief overview and general information on respiratory hazards in construction and respiratory protection program requirements. The Federal Occupational Safety and Health Administration, also called OSHA, and state OSHA agencies require employers to have respiratory protection programs if their workers are required to wear respirators on the job. This video does not cover all of the things that your employer must do under federal OSHA or state OSHA respiratory protection standards. This video can be a part of the OSHA required respiratory protection training, which includes many topics, like how to put on While this video discusses some of your employer's responsibilities under OSHA's respiratory protection standard, it is important to remember that the purpose of a respirator is to protect your health and safety. Gases, dusts, mists, and fumes may be present at construction work sites. Some of these can make you sick or kill you if you breathe them in. These gases, dusts, mists, and fumes are referred to as respiratory hazards. Some respiratory hazards act quickly, like carbon monoxide, which can make you unconscious or kill you in minutes. Other respiratory hazards can take years to make you sick, like asbestos, which can cause lung cancer decades after you breathe it in. More examples of respiratory hazards in construction include lead dust and fumes from grinding, welding, cutting, or brazing surfaces coated with lead-based paint. Silica dust from cutting concrete or sandblasting. Solvent vapors from adhesives, paints, strippers, cleaning solvents, and spray coatings. And isocyanate vapors from spray foam insulation and certain spray paints or coatings. When there are respiratory hazards at your job site, your employer must use several methods to reduce your exposure to them, including engineering controls, such as local exhaust ventilation, work practice controls, such as using wet cutting techniques, and administrative controls, such as minimizing the number of workers exposed to the hazard. When you and your coworkers cannot be adequately protected from respiratory hazards through use of these methods, then your employer must provide you with an appropriate respirator to protect your health. Respiratory protection must be selected based on the hazard you will be exposed to on the job. Not every respirator will protect you against every hazard, so it's important for your employer to select the right one. For example, filtering face piece respirators may protect you against particulate hazards such as dusts. However, a filtering face piece respirator will not protect you against gas and vapor hazards like solvent vapors. If you are exposed to gases and vapors, you will need a different type of respirator. For example, you could use an air purifying respirator with chemical cartridges or an atmosphere supplying respirator, such as an airline respirator or self-contained breathing apparatus. In addition, atmosphere supplying respirators are the only respirators that will protect you against hazardous atmospheres, such as carbon monoxide and lack of oxygen. Selecting an appropriate respirator is your employer's responsibility. When respirators must be used on your job site, your employer must have a respiratory protection program. This program must meet the requirements of either the federal OSHA or your state OSHA respiratory protection standard. The standard requires your employer to do the following: develop and implement a written respiratory protection program. Evaluate the respiratory hazards in the workplace. Select and provide appropriate respirators. Provide worker medical evaluations and respirator fit testing. Provide for the maintenance, storage, and cleaning of respirators. Provide worker training about respiratory.
All right, forgot my mic's not on. You may have a little difficulty with some of the sound for 2 or 3 minutes earlier. going between the desktop audio and the mic. Okay, so I wanted to stop it there on the medical evaluation. So this is why this is the third highest violation, because really you can go to any job site where they're cutting concrete and chances are they're not using the water source to reduce the amount of silica dust, or they're just not wearing anything on their face, or they have scarves or something else on their nose. Okay, so that's probably, it's real easy to find because you have to have something in a proper way for all of the dust and the particles. But you see there are so many different kinds and types of respirators, and yes, they most do require, especially the ones that require you the scuba gear and all that stuff, the ones where you wear the air on your back, that's actually like you're going underwater. Well, those are used in the most extreme cases where the air is just so contaminated that you can't take it in as a human, and you don't have to be underwater. Okay, so it's important that medical evaluations are performed. So you see why there's a lot of violations, because, if you have to use this gear, it's a lot of expense to train you, to get you fitted. You have to actually be fitted for the proper gear. Every face is different, right? Everything is different. And so that's why you don't put your life and your family's livelihood in jeopardy because somebody doesn't want to give you the proper PPE for the job. So we'll keep it moving.
Respiratory hazards and proper respirator use. Evaluate workers' use of respirators and correct any problems. And provide you with access to specific records and documents, such as a written copy of your employer's respiratory protection program. Some of these requirements, such as training and fit testing, can be provided by an outside party, including a union, an apprenticeship program, a contractors association, or a past employer, provided they were conducted within the last 12 months. However, it is still your current employer's responsibility to ensure that all of the requirements of the standard have been met. Because each workplace is different, it is very important that your employer's respiratory protection program address the conditions found in your specific workplace. For example, workplaces may differ in the following ways: the types and amount of respiratory hazards present, the people who manage the program, the policies and procedures for tasks such as respirator selection, maintenance, and use, and other methods for controlling exposure, such as using wet cutting techniques to reduce airborne dusts. Since construction work settings change over time, the written program must be updated as necessary to account for those changes in workplace conditions that affect respirator use. For example, changes in workplace conditions could include new work processes or techniques, such as introducing sandblasting into an area, the use of new or different building materials or chemicals, changes in the amount of a respiratory hazard in the workplace, or changes in the types of respirators being used. Notify your supervisor if something changes in your workplace that conflicts with or may not be covered by your respirator training or established workplace policies or procedures. Your employer's respiratory protection program must be managed by a qualified, trained program administrator. This person must monitor the program and make sure that you and your coworkers are adequately protected. The program administrator will know a lot about your workplace respiratory protection program and should be able to answer any questions you may have about respirator use. The program administrator must know about the requirements of the OSHA Respiratory Protection Standard and must periodically evaluate the program and make any necessary changes. This video has provided you with a brief overview of respiratory hazards in construction and respiratory protection program requirements. There are many other things that you must know and do before you can safely use a respirator in a hazardous work environment. While this video may be a part of your respiratory protection training, your employer must also provide you with additional training on respirators, including worksite-specific training. Remember, if you don't know if a respirator is needed for the task you will be doing, or if you are unsure about how to properly use a respirator or which filter or cartridge to use, talk to your supervisor before entering the hazardous area. For more information about respirator use in your workplace,
Okay, so I think that's pretty complete. Violation number 3, failure to provide respiratory protection and program. So remember, just about anything, if you're at work and you're performing an operation, you can smell something that's not like food cooking. That's like the only thing that's okay to smell at work. Then chances are, or stuff flying through the air, right? Or fumes or anything like that, chemicals that are being used that are going through the air, chances are you need respiratory protection. And so make sure you, take heed of everything we show here. And of course, join our program. We teach OSHA 10 and 30 every day of the week. And we'd love to help you complete your safety education. Any questions at all about this, please don't hesitate to email me at education@sfjohnsonconsulting.com. And I never ask, I'm supposed to ask, I'm new to doing this, even though, I should not be. But if you like this, please say so and subscribe. Thanks a lot, guys, and I'll talk to you soon. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and in this video for our framing and our drywall takeoff class, we're going to be reviewing the ceiling plan and what the framer needs to look at and review in order to prepare a takeoff for ceiling framing, and then we'll again also use this for the drywall takeoff class as well. So what we see right now is the overall plan, and when a set of construction documents or the plans are really large, or you have a very large area, they'll show you the larger area, and then they'll break down each of the areas onto its own sheet. And so what we see here is the reflective ceiling plan for the first floor, the overall plan, and of course how they represent drywall on the ceiling is white, and let's just take that off real quick. It's white with the speckles, so we know that that is a drywall ceiling as opposed to a 2x2 acoustical ceiling tile or a 2x4 or any kind of acoustical ceiling tile. So we know that that is the area of drywall that we're going to have to both frame in order to put the drywall on it. Now, also on the ceiling plan, what you don't see reflected on the plan view, or in most cases they have some soffits in certain areas, which are walls that extend down from the ceiling, where the floor plan has the walls extending up from the floor, right? Well, soffits are that extension of wall that comes down, say like a menu board at a restaurant or something like that. Well, that's a portion of the wall that's coming down from the ceiling. And so there has to be a way for the plan, just like they show you section views of the walls for the floor, right? You have to have the same thing for the walls that are extending down from the ceiling. So we'll see that too. And so that's the first floor overall plan. And we'll put the area back up there. And then it also had a second floor, which was a little smaller. But then that was the area also for the drywall, and all of this was included. Now, as they broke it down, right, this is just 1/3 of the full area, first floor area A. The one thing I wanted to note or to make sure when you are doing the takeoff for the ceiling drywall and the ceiling framing is to look for the section views that indicate that there is some kind of something you need to pay attention to when it comes to either the framing or drywall or both. Okay, and so throughout this portion of the plan, I've just noted certain detail call outs or detail views they want you to look at, because this would probably indicate a type of soffit coming down from the ceiling. And so what we do, let's look at this one. We'll look at image number 5 on page A9.08. And so let's go to page A9.08, image number 5. So yeah, this is a small portion of the ceiling detail. With the ceiling now, there's a portion of a small wall that's coming down. Now the length of it is the length that we measured from the ceiling plan. Now this is the height of that section. Now, one thing to notice though is this right here, this little heartbeat symbol, basically means that we've cut off the view of this wall at this point, which means there's more you need to reference above that. But we're only showing you what you need for that one ceiling detail. And so now I'm the framer. I got to do a couple of things. I have to determine the actual height, because this wall that's coming down from the ceiling is coming down from the ceiling joist, apparently, well, of course, and then it is attached, secured with the 3 5/8, and we know it's metal because it's 3 5/8 metal. Even though it says it would not need to say it, because we know that the studs that are referenced in mixed numbers are metal studs. Okay, so basically we have a small little wall that's coming down from the ceiling that's secured this way. And we have drywall on the full portion, it appears, on one side, but drywall only to 1 foot and 6 inches probably on the other side. So what we'd have to do, well, how large is the wall? Well, we're going to assume that the wall goes to the ceiling joist. What's the distance? Well, then we'd have to go back to the floor plan, get the section view, see how far up that the ceiling joists are for this wall. So it's a couple, 2, 3, 4 process. But again, if you're at this point, you've already done the floor plan, you've already done the wall framing, so you probably have a good idea if it's a 16-foot stud. So you would know it's again, the ceiling has a height. So if the ceiling in this area is 9 feet, well, you have to go the 9 feet plus, because this would be the ceiling, right? This is the acoustical ceiling. That ceiling every ceiling plan gives you the height. Let's go back to, because your ceiling plan's job is to tell you the kind of finish, okay, and then the height of the ceiling. I think we were right here. Okay, and so we know that this soffit that we're talking about, we're referencing from that image number 5, A9.08. We know that that is 9 feet, and it's always AFF, above finished floor. And, well, what this is telling us is certain parts of this ceiling is 11 feet. The amphitheater ceiling is 11 feet. Now, the studs, right? The studs have to be higher than 11 feet because that's where the ceiling ends. And so we probably have a 12, 16 something foot ceiling. And so what's the height? Remember, from the ceiling plan, we're going to get the length of this soffit. Then we go to image number 5 on A908, image number 5. We know that this is 9 feet. So if the full height of the stud to the ceiling joist is usually where it's going to go to the ceiling joist. If it's 16 feet, well, we know we need 7 feet. This is going to be a 7-foot soffit because we know this is 9 feet. If the total is 16 feet, 16 minus 9 is 7 feet. Okay, so that is the pain in the butt part about figuring out the soffits. But if you're an estimator, if you're doing the takeoff, if you're doing it properly, then that's what you have to do. So if, say, for instance, 7 foot, this is a 7 foot by however many linear feet we measured on the ceiling plan. That's the square feet of that soffit at that location. So the drywall would be 7 feet on this side. You got to account for, just give it another, I just give it a foot for this. Why not? And then this is a foot, a foot and a half. So one side for drywall is going to be a foot and a half. This is a foot, right? So you could say 1 foot by that length. That's how many square feet of drywall for just this strip. Then you say 1.5 feet times that length. That's how many square feet of drywall for this side of the wall. And then however many, we said if that's 7 feet by the length and that's how many square feet of drywall for that side of the wall. And so you can imagine for every soffit, the soffits are different. This area is different now. For an area that's larger than this, you probably measured the area on the initial plan. You probably measured a large area like that, more like the soffits we're just doing is like this. You don't really measure that. You just take that from your section view. But the other ones that are wider, you probably got that area that is showing you. This area is very visible from the ceiling plan. So you don't even have to account for that area in the same way you would for that area, because you've already accounted for this area when we did the larger area calculations in red. But what you do have to account for is all of this, all of wherever the soft, you may have accounted for that area too. You got to see where 6, let's go back and see if we can find where it leads us to 6908. See if we can find, because I didn't mark all of them, so maybe not. Let's see, 6908, oh I did. Let's see, 6908. Yeah, we've accounted for that area too. Or see, now this may be drywall, which we did not account for, and it's not very clear. Oh, yeah, So this is, see, and that's where it's kind of confusing, right? Because we know that this is acoustical ceiling tile. All this is 2x4, larger sizes, 4x4 maybe. But this right here, even though it's not speckled, may be drywall. So we'd have to go deeper into it to make sure. Probably so. Because let's see what 8 over 908 is. What is that? 6 and 8. One's little, one's big. 6 and 8. Okay, yeah, that 8 is the larger. If that's the window, remember one side's near a window. 6 and then, yeah, so yeah, we wouldn't account for that one. The 6th one, we wouldn't account for that area. See, and it says see reflective ceiling plan to see what that width is. So we would have to account for it on that area because it's not even giving it to us there. Let's go back. That's 6. That's over here. So you see what a pain in the butt it could really be, but that's your job. All right, 6 and 8. And that's the little part. And the 8, I'm confused. 6 and 8. See, and this part is the part that would really confuse me. This right here, but see, it's not speckled, so I wouldn't assume it's drywall. So, have to ask questions. That's when we'd have to send a request for information just to make sure. Yeah, no, it's not drywall because all of this would be speckled if it was all drywall. And there are no section views sending me here to tell me that that's drywall. So it's something else, but it's not drywall. Drywall is clearly marked, even if it's a little soffit or the larger of the areas. Okay. So yeah, that's what we got to do when we look at the ceiling plan. Not only do you have to count for all of the area, that's straightforward, that's easy. Where it gets complicated is where you have to go into detail, look for all of, and I just marked out a few now, look for all of the section views. First thing you do, you got to measure how many linear feet of each one do I have, just like you do when you determine how many linear feet of wall you're going to build from the ground up. It's the same thing. It's just a wall from the ceiling down. The only other tricky part is when they cut it off like that. Okay, when they cut it off like this. Okay, you still have to determine what's the additional height because you're building your wall from the ceiling joist down. And remember, this is always going to be marked, or this height, the ceiling height is always on your ceiling plan. Every room is going to have a ceiling tag and it should tell you what the height of the ceiling. How come I just don't see that there? Oh, it's on the detail one. That's why it's not going to give it to us on that one. It's going to give it to us only on the detail plan. 8 foot here, 9.6, 9.6. And so that tells you in terms of the soffit, it starts at 9.6 and goes up to the ceiling joist with that additional blocking to hold on to it. Okay, so any questions about this or anything else, please email me at education@sfjohnsonconsulting.com. Otherwise, you know what? I will see you in the next class. Thanks a lot, guys. Talk to you soon. Hey, guys, this is Stacy with SF Johnson Consulting and Construction Services. And I just wanted to review our information for our video quiz for our OSHA 10 class for our students, where we will have them discuss our enforcing the standards, how to report, how OSHA enforces the standards, how we report the safety hazards, and then we'll go over the whistleblower protections. And there'll be a scenario for each of the students in the breakout rooms to use the OSHA specific language in order to answer the questions on the scenario on the study page. All right, so how does OSHA enforce the standards? Well, the only way to enforce the standards is really to go to the site to see if any of the standards are being violated. In certain years, they may focus on a certain scope of work. Like years back, they focused a lot on excavations because of improper slope and no means of egress. Contractors were dying and getting smashed by when the dirt would move. So really the only way is for site inspections. And so when there is a site inspection, there is a process that OSHA takes. And when they come on site, they have the opening conference, which basically they get whoever's in charge of the site. They give them notice that they're there, show the credentials, and let them know why they're there. And then they go and perform the walkthrough, which they will take a look at the site itself to see if the site is, the way it's set up, is in violation of any of the standards. May speak with one or two of the employees, and I would always recommend to work with them. Some people get so offended when OSHA shows up. But they're there to help you in the whole concept behind OSHA is to keep employees safe and to help really the employer's bottom line by keeping everybody safe. So they have certain standards that have been set in place for many, many years that anybody in charge of a work site, a project, they know by now that they should have certain things in place, to keep their workers safe. So they perform a walkthrough, may speak to one or two people, and then they'll have the closing conference, which will more than likely they will discuss with the owners what they found. And sometimes it takes up until 6 months for them to get back with you. It may or may not result in a citation. But that is the process. And again, the workers have the right to speak with the OSHA inspector if they so choose during the inspection. All right, so next we're going to talk about reporting safety hazards and what happens and how OSHA responds. Well, the way that OSHA responds depends on the way that the hazard or the injury was reported. There are 4 different scenarios that could be possible. And remember, you're thinking in terms of the scenario we have on the study page and being able to answer those questions. Now, if the complaint or the hazard or whatever is reported, filed by phone, and it's not of a serious nature, then OSHA will contact the employer by phone as well. Number 2, if it is a serious hazard, meaning someone was injured, there's a serious fall, an ambulance showed up, someone died, something very serious, then OSHA will conduct an on-site inspection. Number 3 is if OSHA is notified in writing and it's signed and submitted to OSHA, that may also result in a on-site inspection. And last but not least, if it is submitted online, they handle the complaint using the phone or the fax. So it really depends on the nature of the initial notice of complaint. And again, if it's very serious, they're going to show up. If it's a serious injury, head injuries, falls, death, they're definitely going to show up on the site. And last but not least, we're going to discuss whistleblower protections, because nowadays, whistleblowers are very important because of the intimidation that goes on at the workplace. It's, just in general nowadays, OSHA thinks it's very important, and it is very important that they protect workers who complain about the employer. OSHA, they will protect you. If you complain to OSHA or any government agency regarding your workplace safety, you will be protected. Workers cannot be transferred, denied a raise, fired, hours cut, or punished in any way if they exercise their rights given to them under OSHA. And it's very important that if during the inspections, not to be afraid to speak to them, and because there can be no repercussions. In the event there are, you have 30 days to let OSHA know. And, employers know that they cannot retaliate because you exercise your right under the law, under the Department of Labor. And so it says that every employer should post this in their workplace. So, they're letting the employees know that we fully support your safety. And if you feel in any way that you've been intimidated, they want you to know that you can contact OSHA. So every employer should post the following: if you have been punished or discriminated against for using your rights, you must file a complaint with OSHA within 30 days of the alleged reprisal for most complaints. So keep that in mind. And these are the 3 things that you're going to have to consider when you are reviewing the scenario for the OSHA 10 class. Each of the members should be thinking in terms of these 3 aspects: how OSHA goes about enforcing these standards, what happens and what scenarios in the event that there is a reporting, under what circumstances does OSHA do what things, and what's the protections for whistleblowers. So if you have any questions, please email me at education@sfjohnsonconsulting.com. Otherwise, I will see you at the next class. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services. And in this short video, this is actually a video quiz for our OSHA 10, OSHA 30 students, going over what the general duty clause is, and just a couple of thought questions that we're going to give them. So, in our 29 CFR 1910 is for the general industry standards, and 1926 is our construction standards. And then 1915 are for maritime standards. So if you're on a boat, ship, on sea, those OSHA standards apply. Well, the general duty clause, which is section 5A1, explains what is required when there are no specific OSHA standards in a certain situation. Okay, so when any other work environment, because again, in general industry, we have the 1910, which are specific standards. 1926 is construction, we have specific standards. And in maritime, we have specific standards. So if you as an employee find yourself in any of the other situation or any other work environment, the general duty clause would apply. And the things that are situations that they apply to are these. And so when you go into your breakout rooms and you discuss it, you want to come up with specific circumstances, situations on the job where you had this come up and maybe it was an issue where you weren't prepared or you weren't covered or you didn't feel safe, or if you were, then you want to discuss or let us know how the situation was covered. So these are the situations that are covered under the general duty clause. So noise, right? You're supposed to, there is a standard of level of dB of noise that an employee can be exposed to within an 8-hour period. So that's part of the general duty clause. Chemicals, the handling and storage of chemicals, have to be trained on that. That's part of general duty. Protective equipment, regardless of the trade, regardless if it's maritime, construction, or whatever, you have to provide protective equipment for your employees. Fall protection is part of the general duty. Guarding of open-sided platforms is part of the general duty. Scaffolding, there are rules that apply to scaffolding, part of general duty. And last but not least is the right to know, is part of general duty. Okay, and so again, in your breakout rooms, in your sessions, you're going to discuss these: noise, chemicals, protective equipment, fall protection, guarding of open-sided platforms, scaffolding, and the right to know, where these may have been situations or circumstances where you did not have what you need in terms of safety, or if you did, either way, you want to discuss those together, and then we're going to discuss those as a group and see where we go from there. Thanks a lot, and I will be very excited to hear your answers. Talk to you soon. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and welcome to our A-Plan Framing Takeoff class. In this class, we go over what a framer needs to look at when they are going to frame whatever it is that needs to be framed. This is a small coffee shop, and it is from the ground up. And so right now we're just looking at the A-Plan non-structural framing. And we know that the non-structural framing would consist of all of the walls that would connect all of the structural framing in terms of this exterior wall and any of the interior walls as well. What's structural framing? Well, that would be all of the beams and columns and headers and all of the roof framing, considering this is a single-story building. So in this set, what we're looking at right now is how we determine the takeoff for the A-Plan or the architectural set framing. And so the first thing we do, of course, we're going to look at the floor plan. And the floor plan, the framer also frames any of the new ceilings, right? That's not going to be a acoustical ceiling tile. He's gonna or she's gonna frame all of the gypsum board ceilings. So we'll look at the ceiling plan. We look at the floor plan, and our framer also installs all of the door frames. So we'll look at the door frame schedule. Okay, and so first thing the framer needs to know in terms of the floor plan are what types of walls are we going to put together? Are they going to be wood frame walls, or are they going to be metal framed walls? And so we're always going to look for the wall legend. The legend is just basically the list of all of the walls that are going to be built. And so in this small coffee shop, the exterior walls, they tag A, and it gives us a good description of what the A scope of work, or what the A walls are going to be made of. We know that they're going to be wood, even if they didn't put the word wood there. We know it's going to be wood just because of the description. Anytime we have a 2x, that lets us know that is a wood stud. If it is a 3 5/8 mixed number, we know that that's a metal stud. But in this case, yeah, it's most exterior walls 2x6, 2x8. Okay, so all of the A walls, 2x6 wood. B3 is an interior partition, and that's going to be a 2x4 wood stud. Okay, and right now we're not going to concern ourselves with rough carpentry, which is the sheathing, or any of the FRP, which is a finish. And if it had drywall, we're not going to concern ourselves with that as well. But it looks as though all of the walls have a plywood finish. And a FRP on both sides for the interior partition. And for this one, more plywood. And this is a single. They're worried about the single side. More plywood. So it's really no FRP. No drywall. Just FRP and plywood. So that's good. All right, so we know the kinds of walls. And so at this point, we just need to measure. Now, we know we have openings, right, which are the doors and the windows. And so most of our takeoff, we're just going to go through the openings. And if you want to be very detailed, then we would go through the openings, right, and then determine the size of the opening, and then deduct that from the total framing that we have originally determined. Or just keep it as waste. Either way, it's going to work. And so on the floor plan, we're able to determine how many linear feet of each of the types of walls. And so that's already been done. And so we know that wall E is about 3.5 feet. D is 1.6. A is 110.6 or 111. C is in cat, almost 8 feet. B3, 30 feet almost, and B6 is 2.3 feet. So we know how many linear feet of wall, but we need to know the height of the wall, because walls have lengths and walls have height. So what do we have to do? For each of the segments that we have determined, we need to go to the section view. Right, the section view, which is, this is a section view marker, which symbol is the circle, the little hat, and the leg, and the leg goes through the wall that it is referencing. So we have a 4. So we're going to look at image number 4 over at page A3.2. And so it looks like all of our exterior walls going to be that same section view. So we'll use that section view as the height of the wall, and it gives us a different. Now this section view, 3 over A 3.1, now you see that it's going through the wall, but it's also going all the way through the building. So that's going to be a building section view, not a wall section view. And then we have another building section view cutting the building this way. So we can look at the building as if we cut the building, and now we're standing here and we are at the same level of the building, and we can see inside the interior construction from the roof until the foundation. And then this section view, they're giving us to show us the section view at W1, which is the window. And so this helps the framer determine the height of the wall under the window and the height of the wall above the window for the purpose of determining, you don't want to always buy 12-foot studs. You can buy whatever length this is. And we know that this is a highly dimensioned plan, right? Because we can see that it has dimensions that coincide with the openings that we need. Meaning, we know that if we have two measurements, two lines, this would be one line, and the opening of the window would be the other line, and they're parallel, meaning they'll never cross, right? If we know the length of one, we can use that length to determine the length of the other. And so the way we determine this length is from hash mark to hash mark and the number in between. So we know that this opening coincides with this parallel measure, which is 6 feet 6 inches. So we know that the opening of the window is also 6 feet 6 inches. And so it gives us a section view for that. Okay, so but we're going to go to the section view for the main exterior walls, which is again image number 4 on page A3.2. Okay, so these are all of the section views, page A3.2 and image number 4. See, it's always backwards in construction. Instead of this being 1, 2, 3, 4, nope, it's 4, 3, 2, 1. And so I know that the exterior walls are this height. And it looks like we've already measured it. 18 feet, 9.5 inches. And here's a section view at a window. The bottom of the window is usually 3.5. But this, in this case, is 3 feet, 3 1/16 of an inch. And so we know for that every portion of the building that has a window, we can get 4-foot studs, right? Instead of getting the full 20-foot stud. And we get the studs in even sizes and cut them as needed. Here we get a 20-foot stud for the main building. And then here we have, this looks like the drive-through window. But, we're going to make all the walls under the window the same height because that's what we do. It's not a residence where, we'll make it all nice and pretty and everything looks different. No, this is a store. We want to have a standard way we make everything. And yeah, so all of the walls under the windows are that height. And we have another section view. I'm sure we have a door somewhere in this building, which would be probably right here is where the door would be. And so, yeah, and this is a representative of a header. And that would be the structural framing we would be looking at on the S plans. And it just tells us, doesn't even really give us the dimensions because all of the structural components, all the dimensions of structural components would be only found on the structural set. Okay, shows us the foundation, right? But the dimensions of the foundation is only going to be found, again, on the structural set. So this is not going to tell us the width of the foundation, the continuous footer. You have to go to the appropriate plan because in a set of construction documents, everything is broken up, right? So the plumber doesn't need the A set. The framer doesn't need the electrical set. And so, but the framer doesn't need the architectural and the structural set if they're doing both scopes of work. All right. So that is the takeoff for the walls, right? So we go to the floor plan again. That tells us how many linear feet of each section. And then we go to the section view that tells us the height. And then we know how many square feet of each type of wall that we have to build. Okay, so there's that. And let's go to the reflective ceiling plan. Because if there are any soffits or any drywall ceilings, then we, the framer, have to frame that. But in this case, it's all what? Acoustical ceiling. And so There'll be nothing there for us to be concerned about. And let's see if we can find our door schedule. Of course we can't. Okay. Interior window schedule. Maybe that's with the door schedule. Yeah, there we go. And so with the framer, so we need to know the size and type, height, width of the door frames. Okay, and so we know we only have 2 in this building. And they're both the same size and thickness. Insulated metal, and then one is hollow metal. Okay, so that's what the framer also needs. Okay, and the painter needs it too, because they need to know if the door frames are painted. But that's a whole different takeoff class. Okay, so that's what the framer that is putting together the A-plan framing. Floor plan. From the floor plan, you need to look at the section views to determine the heights of the walls. You look at the reflective ceiling plan to see if you have any drywall ceilings, because the framer will have to frame that in some way. And then we look for the door schedule. And because the framer frames, sets all of the door frames. Maybe not necessarily the doors, but the door frames. So if you have any questions in reference to anything that I have covered, in addition to what we've covered in the class, please make sure you set your office hours as you have been instructed to do during the week, and I'll be more than happy to give you additional time to go over anything. Thank you for joining me, and I will see you next time. Oh, questions you can also email at education@sfjohnsonconsulting.com. See you later. Hey guys, this is Stacy. Just wanted to go over a little information you should think about in addition to all of your takeoff information when you have your demolition cost. Do you need temporary enclosures? Do you need temporary structures? Do you need temporary power? Are there going to be an amount of cleanup fees? And definitely with your demolition, you're going to have waste fees, your disposal, your dumpster fees, recycle fees. You know, those are things to think about. And two, when you think about demolition, in a lot of the cases, the costs are reduced. Your estimate cost would be reduced if there is value in some of the items that you are going to retain. If you're going to retain a lot of the demoed items and they do have a value, they have a salvage value, then you should, or you probably will, be required to deduct that amount from your estimate cost. So keep that in mind. Anytime, and in the laws of demolition, you know, there's laws associated with this stuff, that unless the owner requires or requests the item returned, then it automatically becomes the ownership, or it comes under the ownership of the demolition contractor. And so if that is the case, you should typically reduce the amount of your estimate. So you want to think about all of these waste fees and all of the salvage value information that you're going to deduct from your estimate. Will you have fencing costs? Do you have to, do things of that nature? So always keep that in mind. And those are costs in addition to the cost to actually physically remove an item. You got to think about the waste fees, disposal fees, the hauling fees, and the cash value of any of the items that you retain. And so if you have any questions in addition to that, please email me at education@sfjohnsonconsulting.com, and I will see you next time. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and I just wanted to present a small little video on pricing and determining man hours. We have a takeoff class, and I'll be teaching demolition takeoff today, and just wanted to remind you, when you are trying to do competitive bidding, it is very important to make sure you are accurate in the number of man hours that you are determining for the job based on the scope of work, because if you over determine how many man hours it's going to take, you're going to overestimate how long it's going to take, which means you're going to charge too much for labor, which means you're going to charge too much and you're not going to be competitive. And so we always recommend that you have a very reliable way of determining man hours, and we use a cost book. And for this class, in a cost book, it will break down what you're going to do, and it will also tell you what portion of a man hour it's going to take for you to do that. So if you have 100 of those, then you multiply that number by 100. We have specialized Excel spreadsheets that we've created that will do that for you if you know how much, right? And you know how much because you're going to do a takeoff. So make sure when you are determining your labor that you have some way to accurately determine how long a scope of work is going to take. And in the construction industry, they have tons of ways for you to determine how long something's going to take by a cost book. The cost book will include all the information you need to determine, if not the material cost, if you input it correctly, but also your accurate labor. And that is very important if you're going to do competitive bidding. So have any questions, please email me directly. I'll be happy to answer any questions you have related to the construction work that you see me presenting. All right. And you can email me at education@sfjohnsonconsulting.com. Have a good one, and I'll see you next time as soon as I turn it off. See you guys. Bye. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services. Just wanted to review something very quickly on, a few people have asked me, what exactly is OSHA 10? What's in the class, what's required, and how do we now with COVID take the class? Well, last question first. With the COVID, we can now take all of the classes or teach all of the classes online. As long as we have 3 students at one time, then we are able to do that. We just need to let OSHA know ahead of time. And now, what is OSHA 10? Well, the 10 and the 30 refer to how many hours of instruction, and it doesn't include breaks, and it doesn't include testing and things of that nature. So it's always usually a little more than 10. It's all of the industry standards, which are the laws, of course, established by the Occupational Safety and Health Administration, a department part of the Department of Labor, right? OSHA was established in 1970 to keep employees safe at work, right? So that's what this is all about. So OSHA 10, it's 10 hours required. So let's go over just some stuff here. And let's see. All right, so what is OSHA 10? How does Fed OSHA differ from Cal OSHA? We'll talk about that. What classes are encompassed or a part of the program? What classes are mandatory? And what are the elective classes? Well, Fed OSHA is the set of standards that's good for all 50 states. And Cal OSHA, some states like New York, California, there are quite a few others that have additional standards that they try to make a little more strict than the Fed standard. And so in most cases, the Fed standard is appropriate unless your company wants you or the government asks you to do in our case, Cal OSHA, in addition or to have that. Okay, and so that's how that differs. Now, what is a part of the program, and we'll just go over that. Next slide, please. Okay, so OSHA 10 is a 10-hour workplace safety program developed by the Department of Labor in 1970. We feel that anyone in the field of construction, whether you work in the office or out in the field, you should have an OSHA 10 certification because it helps you to be aware of the hazards in construction. So whether you're personally related or a coworker of yours you can assist the office, the company, in maintaining a safe work environment for your coworkers and office staff and all of that. So there is a difference between 30 and 10. Of course, 30, you're going to do 20 more hours. We recommend that the 10 again is for anybody in construction, whether you are actually a carpenter or work in the office. And 30, we recommend for anyone in the management position, because there are a lot more classes. I mean, you should take 30 if you're in construction, period, as far as I'm concerned. I'm a nerd. I love to learn. So, but 30 is really company-wise if they want to, in terms of cost effectiveness, right? 30 is for managers. And the only difference is in that you have a lot more classes, of course, more detailed classes. So we'll go over that. Where are we? Here we go. All right. Now, OSHA has designed the plan with a set of mandatory classes, and another set called electives. So the mandatory classes, of course, are mandatory. Whether you have OSHA 10 or OSHA 30, you have to take those sets of classes. And then the electives, you can choose from a variety of classes based on the work that they do. So if you are a company that works with cranes, well, you'll take that as opposed to one that doesn't and has no need to have safety standards related to cranes. But if you are a general contractor, of course, you need to have the OSHA 30 on top of it and make sure you have all of that. So that's pretty much it. And so mandatory classes introduce OSHA and focus on actual injuries experienced by the workers and how to protect them from those. So basically, mandatory classes focus on what is OSHA, why was it established, and then workplace injuries covers that, and owners or employees' responsibilities, employers' responsibilities, and then it focuses heavily on the focus for or fatal for hazards, health hazards, and PPE. Everyone's heard of PPE because of COVID. It's your private personal protective equipment, so headgear, feet gear, respiratory, that kind of stuff. Okay, and these are the mandatory hours that must be no less than 6. And so all of that you got to cover in 6. But each of these individually, like the focus 4, you have to do an hour of this, hour of that. You have to have at least 30 minutes of intro to OSHA. So there are set standards where we have to make sure you are in class, face to face, even online. You have to your face has to show on your computer, and we have to make sure that you are aware and that you're paying attention. And so there are a lot of activities. And then the good thing about the breakout rooms, that's always a lot of fun. So we do that. That's how we help the students become interactive and kind of take a real active part in the class. And so that's what we do. So that's a little bit about, now let's see. I think on the next slide we have there we go. So the elective courses. Okay, so 6 hours of mandatory, and then the remainder can be these. And so 30 minutes in length, cranes, derricks, hoists, elevators, and conveyors. These are your electives that you can choose from. Okay, so excavations, material handling, storage, use, and disposal, scaffolds, stairways and ladders, tools, hand and power. So those are your electives that you can choose from for the remaining time. So if you have any additional questions or would love to join OSHA Live, which is our ongoing OSHA class that we have for our students, where we teach all this stuff on an ongoing basis. And so with OSHA, if you have up until 6 months to take your classes to get your certification. And so our OSHA Live class is a live class where you join with us and we go over everything that's required for either OSHA 10 or OSHA 30. It's a monthly plan and it's not expensive at all considering what we do and what we help you learn and retain and achieve. So, any questions, please email me directly at info@sfjohnsonconsulting.com. Otherwise, I will see you on the next video, and then the one after that, and the one after that. And look for OSHA's 10 most cited violations. I think we have that coming today, and today is Monday, September 12th. So that'll be showing up real soon this evening, probably at the end of the evening Pacific time. So thanks a lot, guys, and I will see you soon. Hey, guys, this is Stacy with SF Johnson Consulting and Construction Services, and I just wanted to give you a little video communication about a new program that we have that I think you will love, because a lot of you are watching the videos every day quite a few times, and I try to have a variety of things, even though because I have a degree in electrical engineering technology, the electrical is my forte, and I really love it because it's the hardest, actually, to tell you the truth. But I wanted to just show you a little bit about a new program that we have, and it's very inexpensive, and I think you would value it a lot because you'll learn a lot. And I have a variety of things, again, that I'm going to be teaching on indefinitely and like forever, because I know every division of construction. I've probably, oh my God, I've put together an estimate in every trade, whether it's residential, industrial, maybe not so much industrial because that's kind of like commercial, and it's just a big place when you talk about industrial. So tons of commercial, but we have two live programs that we call. The first one is OSHA Live, of course. And what do? We talk about everything related to OSHA. And if you sign up, and if your company has at least 3 people, because to get your certification, you need at least 3 in your company teaching or training at the same time. But we are allowed to do them online, which is great. And that never used to happen before COVID. So yeah, we have classes on a rotating basis, everything that you would need to know for OSHA 10 and OSHA 30 on a rotating basis. And it's $29.99 per student, and it's per month. And so as long as you're enrolled, and OSHA does give you 6 months to qualify to be certified, although it shouldn't take you that long, right? They make you do it or we have you do it in 4 to 8, 5, 6 days. 8 days for 30, 4 days for 10. But yeah, so you could work on that really easy. And then the other one, which I like, which covers everything. So we'll go from the basics to estimating to project management to how to be certified under certain circumstances. And that is SF Johnson Consulting Presents. And I'll be presenting many different things. So hopefully one of those 2 things or both will interest you. And so, yeah, just let us know, and we will be more than happy to sign you up, get you going, and have lots of fun. This is Stacy, SF Johnson Consulting and Construction Services. Have any questions at all, please send me an email at info at sfjohnsonconsulting.com. It is Monday, so make it an awesome week. See you later. Hello, everybody. This is Stacy with SF Johnson Consulting and Construction Services. Just wanted to talk briefly about a communications plan that you would have to analyze as the high voltage electrician's estimator and what to look at. Okay, so keep in mind, the high voltage electrician is responsible for bringing in the power into the building, power to all components in the building, including the lights and everything on the power plant. Well, the low voltage electrician is responsible for bringing in power, the wiring, the outlets for TV, computers, the fire system, Muzak systems, things of that nature. So the high voltage electrician's job will be to It's Monday. Provide junction boxes and conduit, usually just to the ceiling in most cases, unless it's specifically stated. Like in some cases, sometimes they'll want the fire conduit to run to the IT panel, or some conduit, some part of the conduit to run to a different part of the building. So make sure you account for that and look in the notes. It will be specific on the plan, on the communications plan. And so you just need to make sure that you account for, and all the dots here indicate that we are accounting for junction boxes. And so by definition, and the way I teach my students is that, yeah, if you're going to account for a junction box, also account for, just say, times however many, and I always multiply it by 10. So I give the electrician 10 feet of conduit to get to the ceiling, unless we know specifically that it's a huge auditorium or something crazy that you need 16 feet to the ceiling. But then we look at section views, and then that'll tell us, right? Section views not in the electrical set. So you have to look, go through the other sets to make sure you know the height of the ceiling. The ceiling plan, right, has the ceiling tag, and that will tell you the height of every ceiling. So in the event you don't know and never guess, you're going to go to at least the reflective ceiling plan to tell you the height of the ceiling. So in two cases, you'll either run the conduit to the ceiling, and it should say that specifically, or you'll have to run the conduit to a particular room in the building, the communications room, the electrical room, whatever, the IT cabinet, whatever. Okay, so always want to make sure you account for a junction box. And what do junction boxes do? They just hide the connection between the actual, maybe power wire for the piece of equipment and what you as the electrician have to connect it to. That just hides it, so nobody can mess with it, and it can be secure. It might need to be a waterproof junction box if we're outside. It may be a tamper-proof one. It may be an explosion-proof one if we're working in a hospital or a gas station. Usually gas stations have to have explosion-proof components, that kind of stuff. So, and one other thing to note in terms of the conduit, here it tells me 2D, so this is a duplex junction box. And so I always assume if we have a duplex junction box, we're always going to have twice the conduit going to the ceiling. And so instead of 10 feet of conduit, we're going to assume that we have 20 feet. And you never assume, but these are the ways we think when we're doing our estimate. You might have a 3D, 4D, it really depends. So you always want to look for that as well. All right, a lot of these are 2D, mean 2 data, right? And black and white usually means, but you got to look at the schedule of the symbols, because some electricians like to get fancy and don't mark it in the universal way it's supposed to be marked. Okay, so universally, it's supposed to be in a particular way, okay? So white is supposed to be data, black is supposed to be phone universally, but usually they don't do it that way. And so, sometimes they don't do it that way, so you have to make sure. But this definitely tells me it's a duplex junction box, meaning I need twice the conduit to go to the ceiling, or again, wherever they need it running it. You're going to look at the keynotes. There you go. Provide 3/4 minimum to all C devices in open, exposed, and hard ceiling areas. Okay, so, that's easy. For the communications plan, that's typically all you do. All of the devices, you provide junction boxes, and then conduit to the ceiling. So if you have any additional questions, please email me directly at education@sfjohnsonconsulting.com. Otherwise, I will see you in class, dear students, and have a great week. It's Monday where I am, and today, as I'm doing this, make it awesome. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and I wanted to go over, we started the 10 most cited violations for OSHA, and now we want to go over number 2, which is hazard communications. And what is hazard communications? Well, when you have in every industry, of course, you're going to have chemicals that you use. And so, in our effort always to keep the employee safe, we want to make sure that we properly label the chemicals, properly store the chemicals, properly teach and train the employees how to use the chemicals. And there are certain chemicals that don't require labeling and all of that. So we want to make our employees aware of that as well. Now, that is part of the OSHA general standards. So in OSHA, we have standards that are, or laws, right? Standards mean laws that are specific to individual industries like construction and the hospitality industry and all of those. They have different standards, and within those laws, some are general, some apply to all and everybody, and so the hazard communication standard applies to everybody, and so that's why it has a different begins with a different number after the CFR number. It's 1910 as opposed to 1926. So, those are just numbers that equate to the standards or the laws that the Department of Labor put into place to keep employees safe. Okay. And so it's a general industry standard related to the handling of chemicals. It ensures that the hazards related to the chemicals are properly classified and labeled. And so you'll be familiar, once I show you, with the labels that we have on different chemicals, and the labels in the pictures. They're called pictograms. The pictures are universal now, so we use them all over the world, and the pictures are used to identify the type of hazard that chemical will cause. And so there are requirements for labeling again. Also, when you use those chemicals in your place of business, or if you use it in everyday work environment, there should be what's called safety data sheets, right? And the purpose of the safety data sheet is to tell you all about the chemical, tell you how to protect yourself from the chemical, tells you all about the irritants and what possible hazard that they'll cause you. And so they're supposed to be on file, and everybody's supposed to know where they're at, and you're supposed to have a organized program. And that's one of the other violations that's coming up pretty soon, not having a standardized safety program for your employees. See, America only lasts by people like you and me going to work every day. And if we can't keep those people safe, then nobody makes money, right? The people that go to work don't make money because they're sick, and the owners don't make money because their employees are sick. So it's kind of like a you pretty much don't have to think if you're a human being and you care about people that work for you, that you want to keep them safe. And so the fact that we have 10 of the laws broken by employers all the time since 1970. Remember, OSHA was in place since Nixon, the good old guy, right? Compared to today, the Boy Scout Nixon. To keep us safe. And so people can't abuse us and make money off of us, right? And so when it comes to chemicals, ladies and gentlemen, you have to be aware of what you should know, right? You should know this when you go to work. So they should be properly labeled. There should be safety data sheets that tell you all about the chemical, tell you all about the damage that it may cause to you, and tell you how to protect yourself. Okay, and it also speaks to the handling and the storage of the chemicals. And then again, this standard also shows you some, a lot of chemicals that don't have to live up to this standard, which a lot that are like used for, cooking and stuff like that. You don't have to do all of this for cooking, chemicals related to cooking. And so that is the second of the 10 most cited violations. OSHA, don't get up high on a ladder over 6 feet without a way not to kill yourself. That was number 1. Number 2, now don't inhale alcohol, right? Like we all used to do when we were kids. Go and do the alcohol. Oh, I love the smell of gas. Some old people. Yeah, that's why your brain's fried. Because chemicals are not to be ingested, except for the kind, that the adults and the beverages, and that's not even good, right, all the time. But at least they won't kill you as quickly as the chemicals we're talking about here. So make sure your employer keeps you safe. Now, please join our monthly program to keep yourself or your employees safe. It's OSHA Live every day, 1 to 3 p.m. We'll go over the classes that you must have to be certified. And we'll also go over all the fun stuff you don't need, but you really should know. It's a monthly fee. It's only $29 a month. You get to have all this fun and keep from killing yourself at work. So pass it on. Thanks a lot. And I will see you at numero uno, dos, tres. Let's see what's good old, because this all guys, right? It's all guys not doing this stuff. So I don't blame girls. But girls are here. Girls are here trying to help. And this girl can't see. Let's see. Number 3, kind of like number 2, respiratory protection. That's the third most cited violation, meaning, something like last week when we're cutting up concrete, gentlemen, without a water source, and all the silica dust is going up your nose and on your face and in my window. And then I say, hey, you can't do that. And then you want to yell at me. I'm like, hey, I can do that. I paid a lot of money to tell you not to be stupid at work. Here we go. See you guys next time. Join. Have a good weekend. What's today? Have a great weekend, and I'll see you at number 3. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and just wanted to go over almost our very last component here of the top 10 cited violations for OSHA. Now we have number 9, which is the requirement to provide proper eye and face protection. That is OSHA Standard 29 CFR 1926-102. And it is Subpart E, Safety and Health Regulations for Construction. This standard covers the requirement for the employer to provide eye and face protection for the employees exposed to this hazard. The PPE has to be appropriate to the proposed hazard. So there are different types of eyewear, of course, that you would use. And so we'll look at the actual standard here. And it says that the general requirements, the employer shall ensure that each affected employee uses appropriate eye and face protection when exposed to eye and face hazards from flying particles, molten metals, liquid chemicals, acids or caustic liquids, chemical gases or vapors, or potentially injurious light radiation. So that covers just about everything in the field of construction, from welding to everything. So your eyes are very important. I have a video that's kind of dated, but it does show some of the seriousness around using the proper eyewear and making sure you're not just wearing your regular glasses or sunglasses. When I worked for Motorola, and I do wear prescription glasses, they had to buy me prescription eyewear because I worked on pagers, repairing pagers, and we used soldering irons. So, of course, the vapors would get in your face or whatever. So they would make sure we had what we needed. And, I had to get a prescription set of eyewear. So they have to give you, that's appropriate to what you need. Eye and face PPE shall be distinctly marked to facilitate identification of the manufacturer. And so there are standards, and we uploaded a previous video on the ANSI standards, which is that's the nonprofit association, American National Institute for basically what they do, American Standards National Institute. And what they do is they set the standards for all of the, basically, in this case, the PPE or the eyewear and what's appropriate for the appropriate use. So, shall be durable, shall be capable of being disinfected, shall be easily cleanable, and then all of the other different standards. Shade numbers that are required, shielded metal arc welding. So it covers you pretty good. Okay, so that's the standard. That is the ninth most cited violation, and that's not cool because they're not protecting your eyes. And Lord, if you don't have your eyes, you pretty much your life is drastically altered. So make sure when you're doing work that may affect your eyes that you are provided with the correct stuff. It's a law; they have to. And let's just watch a quick little video that I found here. I'm gonna cut off the mic.
I'm sitting here on the floor of the Tacoma Dome, the world's largest freestanding wooden structure, to help you visualize what might otherwise be a dry statistic. According to the U.S. Department of Labor, enough Americans suffer eye injuries at work each and every month to fill this entire area past its seating capacity.
And if that's a depressing statistic, so is the related one. 90% of those injuries would have been prevented just by the use of proper eyewear. There are dozens of things in every workplace that pose hazards to our eyes, the most fragile, exposed parts of our bodies. Sparks, chemicals, flying particles, and a significant number of trips to the emergency room every year are caused by splinters in the eye. The effect of those hazards can be demonstrated by a common tool and one that's a common cause of injuries, the stapler. An injury like that would probably have been prevented just by wearing ordinary eyeglasses. However, ordinary eyeglasses aren't really an effective form of eye protection, as this person discovered while using a powered lawn edger. Nail guns, for example, are causing more and more workplace injuries with every passing year. Regular eyeglasses simply aren't designed to protect eyes from sharp, high-impact objects. To demonstrate, we put a pair of regular eyeglasses on our friend Yorick. Not only did the glasses fail to protect his eyes, the lenses themselves created their own hazard when they shattered. It's also common to see people depending on sunglasses for eye protection. Again, not only inadequate as protection, but adding to the hazard when hit with an object. And even some of those things we think are safety glasses don't protect our eyes like they should. A pretty high price to pay for some companies' decision to sell shoddy imitations. To put it simply, if they don't have the ANSI Z87 stamp on them, don't gamble your precious eyesight on them. Sometimes you have to look closely to see it, but it's worth your effort to find the stamp. It's also important to note that these have side shields. Many of the injuries to people wearing regular glasses came from the side. So let's see how well the ANSI-rated safety glasses hold up to a nail gun. Note off to the right the muzzle of the nail gun. It's at point-blank range. Quite an impact, but not an eye injury. And with a different pair of ANSI-rated glasses, see that dimple? What a difference from regular glasses or from the so-called safety glasses that weren't ANSI-rated. And a third pair of ANSI-rated glasses, and a third success. It's pretty impressive. But what's even more impressive? Some of these glasses cost less than $7. Not much more than most of us can find on the cushions of our living room furniture. Seems like a pretty simple choice, doesn't it? $7 for something that will protect our eyes against a 16-penny nail fired at close range? Compare that to the others. Regular glasses won't protect you, or sunglasses that won't either, or the fake safety glasses that only give you a false sense of protection. It really is an easy choice when you know what to look for. But I was curious, just how good are these safety glasses? So I asked John Crossman, shooting coach instructor with the NRA, to help me find out.
Range is clear.
Ouch! That was quite an impact, and poor Yorick. At first, it didn't look like the bullet went through the glasses, but what happened was that the lens material closed back up as soon as the bullet went through it. The important lesson, of course, is that a pair of safety glasses by themselves won't protect against all the hazards in the workplace. It's important to choose the right kind of eye protection. Handling chemicals, using a grinder or a lathe, welding, you'll want more appropriate eye protection. But for the majority of workplace situations, just a simple pair of ANSI-approved safety glasses will keep your very precious and very vulnerable eyesight protected. And it's important to remember that there is no substitute for practicing safety at all times. In closing, let me go back to the statistic. 90% of workplace eye injuries would have been prevented simply by wearing proper eye protection. Basically, that would empty out all those seats in the rest of the dome, but still leaving 2,000 to 3,000 people in these sections. Again, each and every month of the year. But it's worth asking, would we still have that many eye injuries if, just by the act of putting on eye protection, people were more aware of eye hazards and unsafe practices where they work? Then maybe we could, month after month, keep these seats just as empty as they are now. Because eye injuries are about more than some temporary pain, medical bills, and some days away from work. They're about people losing part or all of their ability to enjoy the beauty we're surrounded by and often take for granted every day. It's about being unable to fully enjoy those things that used to make our lives so enjoyable.
I just love this dress that Grandma sent me. I feel so pretty in it. Oh, Mommy, I only wish you could see how pretty I look.
Okay, so they tried to pull at your heartstrings right there, but it's absolutely true. So you want to make sure you are using the approved eyewear for the situation, and just make sure, and it is something that your employer does have to provide. So if you have any questions on this or any other topic or additional questions on this, please email me at education@sfjohnsonconsulting.com. Otherwise, make sure you tell us how you have been enjoying these safety videos. Please subscribe so you can be added to our giveaways on the 1st, 15th, and the 31st or 30th, whatever applies of every month. Thanks a lot, and I will see you next time. Hello, and thank you for joining me. This is Stacy with SF Johnson Consulting and Construction Services, here to talk about the last of OSHA's 10 most cited violations, which would be the machinery and machine guarding standard, or a violation thereof. Okay, and that is OSHA Standard 29 CFR 1910.212. It is part of the subpart O, Occupational Safety and Health Standards. This standard sets the general requirements for machine guarding, sets the standards for the types of guards. So basically, if you're using grinding or cutting machinery, there has to be some way where the point of contact, where it's doing its job, is secure or guarded from your hand as the operator. And any of the byproduct of that, if there's anything flying off, that type of thing, you have to be protected from that as well. And so the hazard comes in, and where you can get your finger cut off, or if it's a pressing machine, you can get your hand pressed in the machine. And so that is number 10. And let's take a look at the actual violation. Then, of course, we're going to have a little video to look at. And so this is machine guarding, types of guarding. One or more methods of machine guarding shall be provided to protect the operator and other employees in the machine area, which is very important, from hazards such as those created at the point by the point of operation. Ingoing nip point, so that nip is, we can get your hand smashed. You get the idea, right? So general requirements for machine guards. Guards shall be affixed to the machine where possible and secured elsewhere if for any reason attachment to the machine is not possible. The guard shall be such that it does not offer an accident hazard in itself. And then it talks about the point of operation guarding. Point of operation is the area on the machine where the work is actually performed upon the material being processed. So if you're cutting a piece of wood, the point of operation is where the saw meets the wood. Your hand has to be protected from that. So we find that that is the last or the least violation. Well, like number 10, it's 10 out of 10. So that's like number 10, which means people are out there having you cut stuff with the guard off. Not only can you injure yourself, cut your finger off, nip points, smashes, that kind of stuff, but then you can hurt people around you, which is not cool. And so what we're going to look at here is a nice little OSHA video, which will tell us where we messed up in the operation and of what we're doing because we failed to follow our standard. Here we go. I'm going to turn off the mic. Hopefully I'll turn it back on.
A mechanic needed a workbench-mounted grinder and went to the tool room to get one. None were available. He decided to construct a grinder by modifying an electric buffing wheel. He created a mount and attached the buffing motor to the bench. He removed the buffing wheel, installed a grinding wheel in its place, and began constructing a guard. Before the guard was finished, he decided to test the grinder. He plugged it in and turned it on. As the wheel gained speed, it reached a point where the centrifugal force caused the wheel to break apart. The wheel shattered into pieces, striking the mechanic with tremendous force. The mechanic died from multiple wounds to the chest and abdomen.
Equipment must never be modified for use other than its intended purpose. Ensure that the grinding wheel is appropriate for the RPM rating of the motor's spindle, and ring test the wheel before it is installed. The mechanic used the grinder without the guard in place. A grinder must have a guard with a properly adjusted work rest and tongue guard. An operator should stand to one side when starting any grinder. An operator must always wear eye protection when using a grinder.
All right, so that's pretty clear, right? I'll give him credit for the modification, but what's the point in making a guard and then you're going to test it without the guard, right? So, and eyewear and face covering of some kind. So, OSHA was designed to keep you safe because people will have you out there doing stupid stuff. Okay, let alone what you do in your own garage, right? So make sure these types of violations really fall protection. This is the last. So this is the last of the series, but I'm just going to end it with going through 1 through 10. Number 1 was fall protection. So we have people out there not wearing proper fall protection. Okay. You're going to fall, you're going to break something, period. And so OSHA says, look, if you're going to be above 6 feet, attach yourself to something so you can't fall, right? If there's a chance for you falling a vertical 6 foot measure, whether it's you're above the ground 6 feet and you fall and hit the ground, or you're at ground level, right? And you're doing some digging or whatever, and you fall below ground. And I'm thinking that's 4 feet, something about 4 feet. I can't remember all my standards. That's why there's a zillion, and that's why there's a book. But you got to make sure you protect yourself from falls. Okay, 2 was hazard communication standards, meaning you got containers out there filled with all kind of chemicals. Employees don't know what it is, or they're using it improperly and they're causing breathing problems and that kind of stuff, or it splashes in their eyes and then they go crazy. Okay, so that's number 2. Number 3 was respiratory protection. So yeah, you go out there with your drywall and you're doing your finishing on your drywall, and it's just like a dusty mist all over the place, and you just out there with nothing on your face, or you've got a handkerchief, or you've got a bandana or something. That's not respiratory protection. Okay, so that was number 3. Number 4 was scaffolding. Yeah, you're climbing up the scaffold on the X's. It's not intended for that use, period. Or they're not put together properly, or they haven't been checked, that kind of thing. That's number 4. Number 5, ladders. Yeah, of course. We're standing on the top ring of a ladder trying to reach something because we have the wrong size ladder. No. Okay. So number 6, control of hazardous energy. That is lockout, tag out. So yeah, you have to, do some maintenance work on the lift, but nobody told you that just because you cut it off doesn't mean the power in is going to keep it from doing something, right? So that stored up energy has to be released before you go in there and try to work on it. Well, we got people out there not doing that. So you go in there, put your hand in there, and then the belt moves and cuts off all your fingers, or it takes your hand with it. Okay, so that's number 6. Control of hazardous energy. That's also known as lockout, tag out. And all of these are all on the YouTube page. Number 7, powered industrial trucks. Yes, of course, we're putting umbrellas on the forklifts. We're putting radios on them. We're doing everything except for what the manufacturer says we're supposed to do to the forklift. Okay. So, yeah, violation. That was 7. 8, fall protection training, period, right? So number 1 was you're not wearing your fall protection, but number 8 is nobody's even training you. That's why you're not wearing it. Well, okay. Right? So number 8. Number 9, eye and face protection. You just out there with your sparks and your stuff, and you're not wearing proper stuff on your face. Okay, that's number 9. And this one, number 10. You're out there putting your fingers in stuff, and they might get cut off. All right, so that was 10. And thank you very much for joining me for all 10. They're all on our YouTube page. Please tell us how you like the whole series. And soon we're going to start OSHA 30 on our YouTube page, but you only get the certification. Unfortunately, if it's live with me on a Zoom type situation, but we are having the drawings for those, so you can join in with us. But yes, you have access to everything that we have, links that are active at the time. Eventually, all the links on our website for the free OSHA. So if you go now to our website, sfjohnsonconsulting.com, you'll see OSHA Live, you'll see free, sign up. Whether you sign up there or subscribe here, you'll be entered into our drawings and stuff. And thank you very much for joining me for this. I see a lot of people like it. I like keeping people safe. I have 3 children of my own and 3 grandkids, and they're very important. So if you're doing work that's dangerous, don't risk your life for somebody paying you $25 an hour. I mean, this is ridiculous. All right, so see you next time, and don't forget to comment. Thank you very much. See you later. All right, here we are again. We are going to discuss now section views and flashing as it pertains to our roofing estimating plans. And so what we're looking at here on our screen, and let me close it out a little bit. Section views are important because it's going to tell us, give us information once we go to the section view. It's going to give us information about what we don't see here, and it'll become vital for our scope of work. And so in this short presentation, this is just in an addition to the live class that we have, so you can go over it again. Anytime you have a section view on a roof plan, it's trying to point you to more detailed in the flashing, or somewhere where the wall and the roof meet, or something of that nature. So you want to always make sure you go to the section views. In this set, we have 2 separate section views, 2 over A 4.1 and 1 over A 4.1. This is at the new roof. There's a little overhang past the roof, and so we want to look at both of these to see what the section view is talking about. And so we see the little representation of the section view. The little circle gives us what picture and what page to go to, and then the leg on there tells us what section of wall we're talking about. So we'll look at both of those to see more detail. 401, 4.1. Okay, so this is image number 1. Let's start there. So at that section view for our roofer, it's really important. So we need to be able to, at that section, which was about 14 feet, 13.8 feet, 1 over A 4.1. So we have 13 feet. Let's just say 14 feet. So whatever we see at the section view, that is how many feet we're going to have. So we're going to have 14 feet of this coping, 14 feet of that one, and then this length is 14 feet. Okay, so, but we took care of the area from the plan view when we did the area calculation for how many square feet or how many squares. And so we want to look here to see, we want to account for that. So we have 14 feet of that on that side. So that's why we want to look at the section view. So that's section view 1, and it's only going to show us the part that's vital. So it broke off the wall right here. Okay, so we can't use this to determine the height of the wall right there because it's broken off right there, because it's only going to show us what we need for that section view for the roofer. So that's 1 over A 4.1, and this is 2. So with this section view, we need to understand, the slope and then the coping and the flashing and all of that for that. And so for that section, we had 67 linear feet of that. So that means we have 67 linear feet of that coping. Okay, so at the masonry wall and then at some other portion at the exterior. So we always want to look at the section views last when we're doing our calculations, because now it's going to tell us this was 2 over A 4.1. So we had 67 feet of that. And then we had 13 feet of this. And we always want to make sure our plans are to scale. If it has a measurement on here, we want to scale it. So this scale is 1/4 equals 1. So we just want to, even if there's not a measurement on here, you want to try to find something on here where you can make a measurement. Usually a door is about 3.5 feet if you can find an interior door. And this one is pretty bad. But we're going to go with, oh, look. How many feet did we say? 67. And so this said it was 65.8.5. So that's about, we're close. So we can measure that to tell if these plans are to scale. But see, we didn't even use that. So that's beautiful. All right. So any questions regarding this? Again, this is just used in conjunction with our live class to give you a brush up or help you remember some things and to help you use it for any quizzes and tests that we may have. So if you have any additional problems, please sign up on our online office hours. You can sign up there at our homepage at the lower right at S as in Sam, F as in Frank, Johnson Consulting.com. This is Stacy, and I will see you at the next class. Okay, thank you for joining for our roofing estimating class. And what we're going to discuss in this portion of the class is the roof plan and what we need to discuss in terms of the takeoff and the measurements that we need to obtain in order for us to produce the estimate. So the roof plan, of course, is where our roof finish is applied. And a couple of things you need to make note of is what type of takeoff software are you going to use. If you're going to use a digitized software, then it'll be relatively very easy to do the takeoff and to get very accurate measurements. So really that's the first thing that you need to decide. So when we're producing a roofing estimate, we need to measure how many squares, right? So how many squares of roof finish do we have? And we need to take particular notice of any of the section views that they show us, because chances are the roof finish is going to go up the wall. So we need to determine how many, the vertical height of that wall. And so that's why they give us the section view that we're looking at right now, 1/A425. So we'll look at that. That's the parapet wall. And it will help us determine how many linear feet high, right, that wall is, because we need to add that to the amount of square feet or the number of squares for the roof finish, right? So that's the one thing we have to do. So all of the components now that are in the roof, so the first thing we need to do is roof finish. So we'll know how many squares depending on, again, what type of takeoff software you have. If you have a digitized software, to be very easy. If you don't, then you're going to have to do a lot of estimating, maybe from the floor plan, to determine how many linear feet across and wide the roof is. So it really depends, again, on the takeoff software that you have. So you're going to determine how many squares. Then you're going to look at the section views to determine the vertical height of the parapet wall, because you're going to add that. And I think in this case it ends up being another 1,800 square feet, or another 18 squares of roof finish to go up the parapet wall and over the wall. And we'll look at the section view. So that's the first thing you do. Second thing, we're going to look at everything that makes a penetration into the roof, because all of that, those holes are going to need to be flashed. And so what we typically do for the estimate is determine how many linear feet, or the perimeter of each of the mechanical units. That's one thing we do. So that's for the flashing, for the roof curb, so that kind of gives us maybe a little more than what we need. But for each of the pieces of mechanical equipment, we're going to measure how many linear feet. Even for the exhaust fans, even though it's circular, we're going to measure the perimeter. One thing we're also going to do is determine the area of the openings for the mechanical equipment, because we're going to deduct that from the total area of the roof finish. Okay, so two things we do with the mechanical equipment: measure the perimeter for the flashing, and then the area, how much area we're going to deduct for the total area for the finish, because that's something we'll need to know. Not that we're going to deduct that or not order that from the supplier, but we'll know how much of that is going to end up being waste. So on this roof, we have 3 rooftop units. We have a number of exhaust fans we'll have to do the measurements for and determine the area for. And then we have these cooler freezer condensers. So we'll do both area and linear feet of flashing that will go around it. Okay, and this is a walk pad. That's something else we'll have to determine for the roof. Okay, so 1, how many squares? 2, all of the mechanical equipment. First thing we do is for flashing, the perimeter, and then determine the area for everything mechanical. And then when we see the venter roots or the pipe penetrations, then we just need to know how many, what's the diameter of each kind, because that flashing, you just need to know the diameter and how many. So I'll know that in this case I have 2 3-inch pipe flashings, because that's how they come. And then the roof latch, I'm going to have to flash around that. So everything that makes a penetration into the roof, we're going to flash around it and determine how many square feet of area it takes up. Roof drains, same thing, flashing, area. And if there are any gutters and downspouts. That's pretty much the last thing we're going to determine, gutters and downspouts. But in this case, there are none because we have the internal roof drain that all of the water goes down internally through the building. So we don't have exterior gutters. But if we did, then we'd have to measure how many linear feet of the gutter and then count the number of downspouts. And then again, we'd have to go to the section views or the building view, building section view, to determine how many, or the length, the height of that downspout. Okay, so this is just an addition to what you'll be learning in the class, just to back up from what we'll be going over directly in class. But to do a roofing takeoff is just as simple as that. How many squares? And then look at each of the section views, which we did in class in detail, which we, if we haven't had the class yet, we will. Look at each of the section views in detail. That way we determine the vertical height of that wall. Then we add that to the number of squares that we have for the flat finish. Then we measure all of the perimeters of all the mechanical equipment, the area that the mechanical equipment takes up. Are there any pipe penetrations? Count those up, roof latch penetrations, and then that's our takeoff. So we'll be able to use those numbers now, go to the cost book, determine price, put all of that on our Excel spreadsheet to produce our professional roofing estimate. So if you have any questions, remember online office hours, sign up on our homepage, S as in Sam, F as in Frank, johnsonconsulting.com. Lower right, you can sign up for additional time, but this is, again, in addition to our live class. So hopefully you got a little bit more out of it, but please make sure to contact us directly if you have any additional problems with any of the classes. But thanks for joining, and we will see you at the next class. All right, here we are again, another roofing estimating little snippet, and in this one we're going to review how we format the Excel spreadsheet. Having a professional estimate and a professionally formatted estimate kind of reflects the type of professional that you are. So on all of our estimating, we design specialized spreadsheets so the contractor can clearly see each line item, how much. We combine it with the material cost, labor cost. We can determine man hours for the project, and it looks very nice. So it really depends on your estimate and how we break it down. We try to reflect everything on the single in a single line that's reflected on the estimate. And so in one of our estimates, or one of our sets of plans, I'm going to try to make this a little bigger. Let's see if we can make it bigger. Zooming in a little bit and then moving it over. Okay. So let's move it over a little bit. And so what we try to do is, depending on the plan, this is a TPO roofing, gives how many square feet, and then we break it down into how many squares, the cost, and then we break down every line item. So it had 8-inch gutters, 5-inch K gutters, how many linear feet, everything specifically. So for the downspouts, they had 2 different kinds. And so we determined each of the length of the building was 13 feet. We had 6 locations for one of the types. So we calculated, did the math for that and did the math for the other. And then all of the flashing. So it can be very detailed. And this too is for the contractor as well as for the general contractor. Now in this sheet, you can incorporate a material cost markup in your cost portion, because that is an equation. In the material cost portion, that is an equation. So you could say that we have D times F, and we can say times 15% or 25%. That way you can kind of hide your material markup in the equation. But this is how you want to have your estimate look. All of the line items, it's always going to give our location, address, based on plans dated, whatever the date is. Okay, so again, it really depends on the type of plans you have, how detailed you're going to do your estimate. So we have all the flashing, we had 6-inch pipe, 4-inch pipe, the metal coping for the parapet walls. And then something you want to always add is a cost for roof loading, which means an individual cost, to get the material off the ground up to the roof, so cranes and the labor and the cost is so much per square. And so for this roof, all the material that had to go on the roof was 61 squares. And so the cost per square, basically, it determines a cost based on a cost book. Okay, so everything we get from here, minus the labor rate, we try to use the base rate for that trade. Okay, but the cost comes from a very good cost book as far as the material cost. But the most important thing we feel to make a very bare bones tight estimate that's based on something is that your cost unit is taken from a cost book. Cost book, like when you go to the mechanic, they tell you it's an hour for an alternator or whatever. Same thing for construction. They know how long everything takes to install for everything in construction. So you want to always use that cost unit, or what portion of a man hour it takes to perform that scope of work. Okay, so for this estimate, let's just scroll over a little bit. So for the TPO roof, it's saying that it takes 1.05 man hours per square, okay, because it's always per unit. And so the total man hours based on industry standards, not you've been in business 20 years or it's the price you've always charged, whatever. A lot of people are undercutting themselves or charging too much because they're not going by industry standard. So industry says it should take you 1.05 man hours to install 1 square of the TPO roof. And so our professionally formatted Excel spreadsheet's going to tell us or do the calculations for the total man hours, 64.05, which took D times I and calculated the man hours. So this row right here is the total man hours for everything. So then you'll know how long a job is going to take, which is excellent, and you do need to know that. Okay, so professional Excel spreadsheet all the way across. It's going to now help us calculate the total labor, the labor cost, because it'll take our labor rate and take our man hours, how long it's going to take, multiply that together, and it's going to tell us how long or how much labor just for this each line item. So we go all the way down. At the end of that, we didn't add any overhead and profit because we're estimators, right? So we let our client determine what they want their overhead and profit. We didn't even add tax. So this is also formatted so it'll only take tax on material cost. Okay, so an Excel spreadsheet professionally formatted, whether it's roofing, painting, electrical, whatever the trade is, it lets the general contractor know that one thing, everything that's in your scope of work is reflected on here, so they'll probably choose you as opposed to someone with a lump sum. Now, if your problem or your issue is hiding your cost, well, you shouldn't hide your cost. And if you do need to mark it up, as I suggested, you can alter the equation for the total material and add 15, 25% or whatever, and they won't know you've marked it up by 25%. You could do the same thing with your labor, really, if you wanted to. But the whole point is, if you're a professional, you want a professional-looking estimate to go to your potential client, right? And let's just see if we can go back. Okay. All right. Trying to get as much of it in there as possible in the recording. Okay, so that's the full thing. Each line item reflected, how much, the unit, so square, linear feet, square feet each, the cost taken from a qualified cost book, a good one, or from your material supplier. But if you bid a lot, it's really makes a lot of sense to have a good updated cost book you can go to at your computer at any time. Total material, and then your labor rate. Always use, well, we use the base rate, and then there's a philosophy behind, what labor rate to use, depending on the organization, the type of organization you are. If you're a mom and pop where you do the work yourself, you're going to typically leave that labor rate as is. But if you are a corporation with trucks and folks and fringe benefits and insurance and workers' comp and all of that, then you want that number to reflect all the additional cost. And your overhead or your profit would be probably a whole lot less. And it'd be a mix of your overhead. So it's really a philosophy. And competitive bidding is trial and error. So you kind of mix all that up and you bid a lot. That's why you try to get a estimator that's good and detailed, like we are, that will do a lot of estimates for one price, so you can get trial and error. The more you bid, the more you're going to win. So if you bid one, and there have been times we've helped our clients bid one and they won it, because we're good. But everybody's not like that. So, especially if you're learning to do estimating, you're not going to just, unless you're really good, but it's going to take you some time. So, having a format you already have set up. Some people set this kind of format up with every type of roof finish, which I think is kind of tacky. If it's not, metal, don't leave it in the form, because you just confuse people as if you don't know what you're doing. Some companies make this and leave everything in it and just leave everything zeros that don't apply to the project, but that's lazy. Don't do that. That's tacky and lazy. Just delete the rows. So your estimate will reflect only what's in the scope of work, only what's in the plans. And rule of thumb, please also review the project manual as well as the specifications for things that may not be reflected on the plan. So any questions about formatting any of the scopes of work, we will give you access to any trade professionally formatted this way. Just give us an email, let us know. And if you have any additional work that needs to be done, set up online office hours by filling out the form on the lower right of our homepage. S is in Sam, F is in Frank, johnsonconsulting.com. But thanks for joining, and I will see you at the next class. Hello, this is Stacy Johnson, the owner and operator of SF Johnson Consulting and Construction Services. And in this video discussion, we will be going over the RFIs, or the request for information, the best practices for contractors, and what you should be looking for and how to organize them and navigate through them. So what is a request for information? Well, by definition, the request for information, this refers to a solicitation of details or additional information about an aspect of the project. Usually it's sent by one party when they need critical information to proceed or to make a decision. And the goals of the request for information, actually, what are the common reasons why we send the request for information? Sometimes when we're missing or have incomplete information, of course, and just from personal experience, most of the times the plans are not to detail, or they have many, many mistakes. And anytime that you recognize that there is a mistake, definitely send through a request for information. So if there's any missing information or if any of the information appears incorrect, I would request, additional information. Common reasons also, the plans or the details may be changed because of a design flaw. And again, this one that you probably would find yourself. They could be changed for material availability or for cost or for some other reason. So there's a variety of reasons for the request for information. Also, updates may be made to the plans based on new or previously unavailable information and change requested by owners, designers, or contractors. So, those are some of the common reasons for requests for information. But from the day-to-day process, it's because something is not clear on the plans. And I also always recommend that if something in the smallest, slightest event seems unclear, request more information. Next, some of the goals for the request for information. Well, the goal for the request is to, or the ideal of it is to formalize the request for information for changes to the plans. So the request actually, again, formalizes the information so we can change the plans. Documents concerned about the materials or cost estimates. So that's what the goal of the request for information. It documents concerns about materials or cost estimates. It shares information and highlights changes to all key players in the project. And all of this helps the project progress smoothly and limits legal and financial liability for groups that stick to the process using formal requests for information. So it's always, everything definitely needs to be in writing. So that is really the goal. Again, to formalize the request for the information so all the parties receive it. It documents the concerns and it helps to move the project along. And if there are any changes as a result of the request for information, that has to be documented as well. So let's go over some general best practices for the request for information. So anytime you're seeking information, always ask for one thing at a time. So don't make it a multiple request unless they say it's okay to, then that's fine. Use a specialized form or a standardized form, and note the time frame in the contract, and that's important. Every contract should have a time frame as to when or how long it will take to get the answers back for the request for information, so make sure you review the contract. Store all requests for information in a centralized database so you'll have them available. Keep a record of delivery of all requests for information. And note the construction schedule or budget may be changed based on the response from the request for information. So again, note that the construction schedule or a budget may be changed as a response to the request for information. And create a permanent request for information audit trail so you'll know the days you receive them, the day that you receive back the information, and it keeps everything clear. Read all contract documents because the contract will give you all the guidelines for the handling of all requests for information. And in some cases, you have to consider the cost for the RFIs to all parties involved. Each may cost up to $1,000 to administer. So they try to keep those questions to, or those requests to a minimum. But if it's needed for clarification, you do need to request. Next, how to write a request for information. The best practices for that. And without the guidelines for creating and submitting a new request for information, contractors may be confused on exactly how to create an effective one. So use clean and simple formatting, follow a consistent format, and naming convention, the way you're going to name things. Make sure all abbreviations are used by the same parties, meaning the same thing. Ask one question or request very specific information. Provide complete and accurate context of the situation or question, and provide any documentation, images, video, whenever necessary. Okay, so what happens after the request for information is answered? Typically, if the response answers the question that was answered, then there's a record and there may be a change. So in most cases, it's a delay in the response, and the delay in the response typically is about 25% of the requests for information don't get a response. So always make sure you keep up with that and apply or comply with the timelines for the request for information. Tips with dealing with RFIs. Thoroughly read the contract, and the contract will have accurate guidelines on how you deal with them in terms of how much time it's going to take to get a response back and how to properly submit them. Address any request for information as early as possible. Depending on the delivery method for the project, it may be more difficult. Anytime you have a design build type of project, those are the most difficult to deal with requests for information because you receive plans at the time that the project is designed, which means, and a lot of times there's a lot of questions to be answered. So that delivery method, in that case, you usually have a lot of requests for information because a lot of things are missing and a lot of things don't make sense. And so address the request as soon as you think it's necessary or as soon as you are asked information, make sure you answer. In any of the other integrated delivery methods, meaning integrated labor delivery, a lot of times the contractors themselves are directly involved, and so they have more insight on the project, so you have fewer requests for information. And then last but not least, use some kind of document tracking, so you can know when you received it. It's all documented. Everybody has a copy of when everybody received everything and when everything was sent. And last but not least, there's a sample request for information in this presentation, and all of the video discussions go hand in hand with all of the live classes. So this is an addition to the live class for you to review. So review the sample request for information. The first part of any of the request for information is record keeping. Record keeping information for internal needs and uses. And so it's always an automated number. Make sure you know what company you're specifically sending it to, the dates that you send it, and the name of the project and number of the project. And the rest of the document, is a detail about the information that you request. So again, this video discussion presentation goes with the live class that you should have attended. And if you have any additional questions, please make sure you sign up for online office hours on our homepage. Again, this is Stacy Johnson, owner and operator of SF Johnson Consulting and Construction Services, and I will see you in the next class. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and this is an episode of For Plumbers Only. And we are going to be reviewing a set of construction documents for the plumbing plan and for the plumber, and we're going to review. This is a project from the ground up, so we're going to review first the utility plan, and that is the plumbing that would take place outside the building. And then once the plumbing gets into the building, then of course we're going to look at the individual plumbing plan. And so this is a very small, same little project, this coffee house that is going to be built from the ground up. And so what we're going to look at really is everything that's related to the plumber scope of work. So WL, that's the water line. And so what we typically do, right, is we tap into the utility line wherever the public utility water line is running along the street, which they do, right? We tap into it, and then we bring it into our new building. And then underground utilities are always, well, it really depends on the state, but we're going to assume PVC and for the underground utilities until it comes into the building. So what we always do first is look for the scale. It's the same scale for 1 inch. It is 10 feet. We've already scaled it. That should be 5 feet, which is correct. And so for the plumber, what we're going to do is just look for all of the plumbing scopes of work, everything related to the plumber. And so we have the water line, and the water line is going to tell us, we're going to look somewhere, it's going to tell us the width of the water line. Okay. 1.5 inch. That's the water line. And that's why I like looking at these when I do the recording. So I don't whip through them, right? I have to take my time. So we have the water line, and then we also have an irrigation line, which is, probably the same PVC. And so what we'll do here is WL, our water line. You know what? Let me go back because it's hard to see when it's not caps. So our water line, and we know we're going to go back and so you see all the angles, right? We know that we're going to have 45s and 45s, right? Until it gets into the building, water line. Yeah, let's see, where else? Sanitary sewer, SS. Okay, and it's going to tell us somewhere what the size of that is too. So, it's a 6 inch. So we don't care right now. Well, we always have to go back and check. So we'll see the SS. And it's going to come here. Proposed sanitary sewer. Yep. All the way here. This is some kind of manhole test system or something. It should be noted, though, if it's something that we need to really look at, like this one. E, that's electrical. So our utility plan has the electrical, right? But our electrical plan is always going to have its own site electrical. So just in case the site electrical is missing something, we don't really need to look at this one for the electrical. And then I'm going to take this all the way to here. And now this is a 6x4 reducer. Okay, so I have to account for that because that's part of my plumbing scope. All right, that's that. Now, what is all this is what we want to talk about. So that's that. So basically what it's telling us is a 6x4 reducer. And this is giving them the elevation of the 4 and the 6. Okay, just a little off by what? 1/10 of in whatever this is. It's based on GPS coordinates. And so that's what all of that is. 6x4Y. This is the GPS coordinates. So when they set it, they know exactly. So it'll fit to where we're setting the pipe. Because the pipe is run. Then we have to set it into the component. Right? And sample, proposed sample well. That's our plumbing scope of work. It's 4 inch. Okay, and then we have a grease trap. It's the grease trap. That's also a plumbing scope of work. And it looks like this is a 4 inch, right? Because this is the grease trap. Okay, it has 2, 1 in, 1 out, in and out. And there it's telling me it's 4 inch. So I'm just going to go ahead and I'm going to say the grease trap. So GT 4 inch. So I know this was what was going in and out of the grease trap. And you know all this is underground, right? So I'm just going to go through for waste purposes. Right, so this is a 6x4, so this is got to be the 4, and the other end is the 6. Okay, so plumber, site, work. Let's see, that we always take our time. And then, yeah, we have to count for meters. And, yeah, the size makes a difference. So the irrigation meter is 1 inch, and then the domestic water, domestic, I'm sure, domestic, I don't know. I'm not thinking. I've done a million of these today. So that's, yeah, for the water, and that's for the irrigation. And the irrigation plan is also, I have to look on the landscape plan. It should also show our irrigation on the landscape plan. It may not, because it's showing it here and they're trying to get more bang for their buck, so it may not. So as far as the plumbing, okay, grease lines, 4-inch sewer connection, 1.5-inch water line, yeah. So that's once it comes into the building. So now we look at the plumbing plan, right? Because that's once it comes into the building, we transfer to the plumbing plan. So that's the plumbing specs, plumbing notes. So what are we going to be installing? So we know we have the sanitary waste, water, condensate pipe for our HVAC equipment, indirect drains, okay, and then the kitchen equipment, right? Anything related to the plumbing scope of work. So the ice maker, coffee maker, espresso, da 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 da. And of course, we also always need to know the size of the pipe that's coming in and out, and the vent pipe, if it applies to all of the equipment, whether it's the kitchen equipment or the plumbing equipment, the lav, which is the term for the sink only in a bathroom. So when we see lav, we know we're talking about the bathroom sink, and the cold water, hot water, waste, vent. Plumber needs to know the sizes of all of that. So we look through, make sure we know the typical symbols. Da 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 da. Da 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 da. Okay, we got the recirculation pump, mixing valves for probably the bathrooms, right? So we just instantaneous water, instantaneous heat. That's what those are for. So we don't have to worry about water heaters for the bathrooms, sinks. The expansion tanks, always got that. So always have to make sure that you are noting all of your plumbing equipment and the sizes of the pipes for water, hot water, cold water, vent, waste. Hold on 1 second. We're going to have a frosty drink for 1 second here. All right. So you have to know all of your equipment because of your rough ends, right? So you're going to have a rough end for every piece of equipment. So if you have 10 lavs, you got to have 10 rough ends. Okay, so you got to make sure. Now we go to plumbing details. We see our circulation, recirc pumps, our backflow preventers. So it's like, oh, I used to take my walks all the time, and then I would see those. I'm like, oh, now I know what those are. You always see those on the outside of buildings, right? These big things, maybe if it's a place where it's cold weather, they'll have the little green insulation jackets over everything. Construction makes you smart, let me tell you. All right, so that's so the plumber can see what the elevation views pretty much of their plumbing scope of work is supposed to look like. Typical, right? That's a typical reduced pressure backflow preventer. So meaning they always use the same kind. All right, so let's get to the plans. So we know the difference between the riser on the left and the plan on the right. The riser will give us all of the horizontal measures. So all we got to do is get to it. Right? We have two plans for the plumbing. So we have the sanitary, and then we have the sanitary and the vent plan. Then we have the hot water, cold water plan, and gas if there is gas in the building. Okay, so this is just the sewer plan and the sanitary riser. What does the riser show us? The vertical measure of the pipe. And so, yeah, we always need the riser. It's always a great set of plans that gives you a good riser because you can determine because we have to determine our material costs, right? Our material quantities. So, yeah, we need to know for plumbing what's the vertical measures as well as the horizontal measure. The plan is giving us all horizontal measures, right? This is all horizontal measures of pipe. But the pipe go up and down, and that's the purpose of the riser. And so every time I see this is a vent, right? Symbol for vent is the broken line, right? We have broken lines in a lot of cases, so you got to make sure you know the difference. On a plumbing plan, broken line means vent. On a demo plan, broken line means demo. Take it out. Underground on a grading plan, broken line means probably underground utility, and it's gray broken line, underground existing. So you got to know based on your plan what that symbol means. But for plumbing, broken line always means your vent. So this is a 2-inch vent line, and what you'll see on the plan view is the horizontal measure. The riser gives you the vertical measure. That way you can measure up and down and you don't mess up on your material quantities. Every time I see up and down, I say 10 feet, period. Rule of thumb for me, right? Because a building is between floor to floor is pretty much 10 feet. And this is a single story building, so you can give it a vent to roof, right? Vent to roof, you see the vent to roof. That's going to be out the roof, up out of the building. So I give that one an extra 2 or 3 feet. Okay, 3-inch vent to roof plus the little vent to roof thingy. Okay, what else? All right, for what the riser diagram is very good for is to count your equipment. Sometimes it's difficult to count your equipment from your plan. Sometimes it's okay, sometimes it's not. It really depends. So, but you got to recognize that there are some items that are on your sanitary riser that's not on your cold water, hot water riser. The clean water. I call one the dirty water plan, which is this one, sanitary, right? It's all the waste, vent. That's the dirty water. That's the sanitary plan. Okay, you can say nothing mentions hot water, cold water going to any of these components, any of this equipment. This is all the sanitary plan. The next plan is the water supply plan. And if there's gas running in the building and it's not a lot of gas, unlike a dental office where you may have a separate plan just for the gas lines and all the different gas that a dentist has, or anybody having a lot of different gas lines, they would probably have a third set of plans for just all of the gas pipe. So this is the second plan, which is the water plan. So all of the pipes go to the same components, different size pipe, 2 dot, 1 dot. 1 dot is cold water, 2 dots hot water. You got to look on the schematic. You got to look on the symbols to make sure. And then here too, we have a riser diagram, which means the up and down vertical measure of the water. Same thing applies. It's going to show you the size, and these are the controls. So everything you see here you have to account for it. Okay, and so every time you see it go up, well, I have 10 feet of 1/2 inch, and water pipe is typically the copper pipe, unless it says otherwise. And sanitary pipe is usually PVC, unless it says otherwise. Sometimes it's cast iron, depending on the state, and if it freezes. I know New York, for some reason, I keep thinking New York, everything has to be cast iron, unless it's some other, hotels. Once it enters the hotel room that has courtesy sinks and wet bars and stuff like that, then you can use a different kind of plastic for those types of situations. But okay, so plumbing, that's why plumbers can't mess around and have somebody that does not know how to do a takeoff. Because imagine if you don't consider the vertical measures. My goodness, you're screwed. And the rough in cost. Rough in cost again is the additional cost for the piping systems that apply to the dirty water plant and clean water plant for the first time that you install that piece of equipment. So when you have new construction, not renovations pretty much, because with a renovation, unless you're installing like an addition that has a brand new plumbing system where a brand new toilet is now introduced into the home or whatever, not just where you took an old one out and put a new one in. There's no rough in cost associated with that. But when you have a project from the ground up, it's very important that you include the rough in cost, which is the additional piping systems for both plans the very first time you install that piece of plumbing. So it could be anywhere from, depending, it could be $1,000 for a shower, rough in cost. So you never want to exclude that. And again, especially for new construction like this is. Okay, so what we would do on this one, we just got to get a good takeoff tool. What's the scale? 3/8 = 1. And we just, you just got to take your time. And like 1/2 inch. Now, I normally don't differentiate cold water, hot water, because I don't have a lot of time in my life for that, because both are the same. But, I mean, you might want to go back and do it later, right? So, now these little symbols, that indicates that the pipe is going up or down, okay? If you can see, like the white, it typically means the pipe is going up. If it's darkened, that typically means the pipe is going down. But that's why you have good riser diagrams. And then let's see what 3 and 4 is telling us. Shut off valves. Let me see. I didn't look at the symbol. The symbol makes a difference. Oh, and I don't know where I was. Okay, no. Octagons. I gotta look for the octagons. Where's the octagon? Okay, right. 3 and 4. Yeah. Yeah, that's just shut off valves. Has nothing to do with whether it's going up and down, because you have the awesome riser diagram. So the riser diagram tells us it's going up. And so you can account for that way. All right. And so I guess that's it. I mean, if you're doing this takeoff, this is a good project. Civil plan, underground utilities. Once it comes into the building, you switch to the plumbing plan. And the main thing is to understand, don't forget every time you see a pipe going up, make sure you know the size of it. 10 feet, 10 feet of 1 inch, 10 feet of 3/4 inch, 10 feet, right here, 10 feet, 10 feet, 10 feet. Now remember, the horizontal measures are what's on the plan. So you're only looking at the riser diagram for the riser, right? The up and down, the vertical measure. These measures are the horizontal measures that in one way or another are reflected on the plan, in the plan view, right? So if you have any questions for this, please let me know. Please sign up for our class for plumbers only. It's $9.99 a month, and we add new content every week. If you have questions, you can sign on and have a office hour where I will answer any of your questions. If you like the video, please let us know. And we are running some specials. One, October 15th, a $100 Starbucks for all of our nice listeners. And then also free training, a contest for free training as a Thanksgiving present. And for Christmas, we're also giving away every month some free estimating if you have a company that requires estimating. So you can lose one way or another. But if you have any questions at all, please email me at education@sfjohnsonconsulting.com, and I will talk to you soon. Hello, and thank you for joining me. This is Stacy Johnson, the owner and operator of SF Johnson Consulting and Construction Services. And in today's small class, what we're going to do in a series of small videos, we're going to break down our understanding of project management, and in particular scope management. What that means, the steps that we take to understand that, the parts of a scope management plan, what those are, how to define those, how to work with those, and steps to make your scope management successful. So in this small recording, we are going to just talk about what our class is all about. Now, in the full class, we go over the definition of project scope management. We go over what the project charter is, because project scope management definitely begins with a project charter. So we define what that is, and it's broken down into its individual pieces. We go over what the statement of work is. We go over the difference between the statement of work and the scope of work, which is much different. We go over scope creep. And there are 6 steps in making a scope management plan. We go into those in detail and break down with a very good breakdown of the thing about the scope management, or whether it's scope management, schedule management, integration management. It's just a series of steps that you take in order to make sure that all of the processes, all the processes you need are there. And then once you've determined what processes you need to complete a full project, then you go over certain steps in making sure you plan those processes, you control the processes, and then at the end you're able to close it out and evaluate the process. And so when we talk about scope management, that's the bigger picture for the whole project. So when we talk about a project, it's a thing. And so the scope is, what does it take to make the thing successful? From the planning stage all the way through to closing. See, so as contractors, they always think of scope in terms of scope of work. But when we talk about scope management, that's such a broader concept, okay? And that's the first thing you have to think about. It's a much broader concept. Okay, when we talk about scope management, we are talking about the planning stages. We're talking about planning. There's 3 processes: planning, controlling, and closing. And so in the planning stage, and let's move it a little forward. Okay, so project scope management. Okay, project scope management includes 3 processes. Planning, which is defining the project. Okay, so defining the project is a lot of things. Okay, the project is defined, and the work or the process is needed, okay, to deliver the project is determined. Okay, so that's what we mean by planning. We have to say, what do we need? What processes do we need in order to get this project going? Second is the controlling aspect of it. Okay, this involves we must track everything. We manage it, we track it, we monitor it. Okay, the activities involved in the project. So this would include things like, change orders, right? That's a form of tracking to make sure that anything that is changed, we got a way to review it, approve it, and, change what we need to do. Because anytime there's a change order, right, it's either going to subtract time to the full project that we've already determined ahead of time, or it's going to add time to it. So when we start changing stuff, then that's what causes our creep, right? Because everything starts to change, we start to slow down. Okay, so that's the controlling part of the management plan. And then last but not least, the third aspect is the closing it out. Okay, so this is the last part of the project. And this would include, we're going to audit deliverables, right? To make sure that what we planned in the beginning is what we ended up with. Okay, so, again, we're going to cover all of these things. What we're talking about in this small video, and all of the videos are going to be posted on the website, so that way you don't have to review the whole thing in order to review each individual part, because you're tested on everything. Okay, so right now we're just talking about what is scope management. And keep in mind, again, when we're contractors, we always think about scope of work. That is a tiny portion of what we're talking about. Okay, scope management is the planning, controlling, and closing process of the full thing, from, again, very first stages, the planning stage, all the way to closing out the project, and all of the processes that are needed to make that happen. Okay, so again, we're going to be talking about the full project, in full, and this is just maybe part 1 of 6. But again, this is Stacy Johnson, and if you are a part of the class, please make sure to review every video, as well as all the documentation on the study sheet. And thank you for joining, and we will meet you at the next class, where we will talk about the project charter, which is the very first step in creating a scope management plan. Thanks a lot, and I'll see you in the next class. Hey guys, thanks for joining me. This is Stacy with SF Johnson Consulting and Construction Services, and this is a episode for finishers only. And what we're going to be talking about in this video are the finishes, FRP. We're going to be determining some wall base lengths, cove base, and then it looks like we're going to seal concrete, chip XPL system, probably some kind of coating as well. And remember, I always look at these for the first time in detail when I record them, so I don't rush through them. When you're so familiar with something, you're going to rush through it, but that's not the purpose of the video. So we're not rushing. And so we're going to paint some stuff too. And the good thing about this, if like I will be doing, if I'm doing the takeoff for the finishes, then I'm also doing the takeoff really for construction cleaning, which is good because I have a client where I need the construction cleaning takeoff totals, because, for the finishes, they put them in, everything's still dusty and everything. So the final or construction cleaning has to go through and clean basically the same surfaces, the same linear feet, and that's how that's priced too. It's like how many square feet of flooring are you mopping, or mirrors are you cleaning, or storefront glass glazing are you cleaning? You multiply that by 2, so when you do the takeoff for the finishes, it kind of helps you out because you're doing the takeoff for the final cleaning too. And so this is the plan view for the floor finish plan. And what we'll need is the plan view for to get our linear measurements, right? But we need to know how many square feet of FRP, right? We need the height of the walls. And so we'll typically look at the interior elevations, or if the heights are all 9 feet or whatever, we'll look at that. Or worst case scenario, we can look at the reflective ceiling plan, because let's go to that real quick. Because the reflecting ceiling plan is the purpose is to give us the ceiling height. And so, worst case scenario, we can assume that the height of the finish on the wall is 6 inches above the ceiling height. Worst case scenario, if you don't have interior elevations, because you do want to get as close measurements for your wall paint. There may be a portion of the wall, like in bathrooms, where it's tile 7 feet and then painting the remaining 2.5 feet or whatever. So you always want to have interior elevations, and this one does. So here's the interior elevations. And so, yeah, it's a 10-foot height. So we guessed that pretty well. And so what's this? And what is that? I don't know what that is. And so sometimes the interior elevations aren't the best. It says open beyond. Open beyond. I don't know what this is. But okay. And so we can take our FRP totals really and we just do the whole wall, and we have to paint the doors. And so we know the door square footage is this times 2. And then we also have to paint the frames. And so you have to measure the frames times 2. So, and then the wall base one here, and I don't know what 3 is. Let's see what 3 is. Floor sinks. Okay, we don't have to worry about that. That's in the floor. They're trying to show that. That's okay. That's not cute. All right, and then 8 conduit. Okay. So, for our FRP, everything has to be to scale, and I know all my plans are to scale, so I'm not really worrying about checking it. But you are supposed to check if you have because this is 10 feet, right? So let's get our dimension tool, like our ruler, from hash mark right in the center to hash mark in the center. Yep, 10 feet. So I know my plans are to scale. And so now I can just use the interior elevations. FRP, FRP. But we won't include the door, which we actually could, but we're not. And see now, this is the wall base. I like to be accurate, so I'm not going to include that. And we won't include the door. We'll give it a little extra for that. And so that wall is 146 square feet. So we do that for the whole thing. And then, of course, we have our cost book. Let's see how much FRP is. All right. That's ugly. Let's take my name off of there. That's ugly. Take the name off? Okay. Where's our search? Where did it go? Let's bring that up here. FRP paneling. So, here we go. Here we go. So, that's the typical almond or white $1.13 a square foot. Let's get that off of there. FRP wall and ceiling paneling, fiberglass reinforced plastic, textured 0.09 of an inch thick, class C, flame spread. Oh, that's the flame spread is the class C. So we'd have to look if that is what they want for our project. It may be class A. If it's kitchen, it may be a higher rating. Who knows? But this is what the cost book is telling us the price is for this one. Spread 24-inch by 48 panels, includes fasteners, adhesives, and a 5% waste. So for that is what's included in the $1.13. So, and that's the man hour total, meaning that's how much of a man hour it takes to install one unit. One unit's 1 square foot. So we do if we have 1,000, then we say it takes what? 1, 2, 3 zeros, right? So we move 3 zeros to the right. It would take 32 hours, right? 32 man hours. So what, you would have a couple folks doing it, so it'd take you a day. You knock it out in less than a day, right? Ta-da. Okay, so let's go back. Excuse me. I always got to cough. It's like, why can't you cough before you start recording, ding dong? I can't, because I'm always recording. All right, so we do that for that. And then, these are windows, right? That represents windows. And so we might have to paint the window frame. So we want to designate window frames from door frames. Okay, and then the wall base, I'm going to go back to the floor finish plan for the wall base, right? And then the doors, I just know how many doors. And then the wall base, let me make sure this is to scale. And again, when we do this for the finishes, we're basically doing it for the final cleaning too, because we have to wipe down, clean down, all this stuff. So now we know all of the FRP is 10 feet. So I can measure, shoot, let's just do it this way. FRP. It's all FRP. But we can go through the door and then we can delete however many square feet the door is, right? Because we know it's all FRP. And then if the wall bases are different, now we'll do that separately because the wall base doesn't go through here, right? Wall base doesn't go through the door. But see, you got to make sure too that you measure both sides, right? Measure both sides of that door for the FRP. And then it's all FRP. FRP. Da, 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 da. And we just gonna do this. Probably corner guards that go over there, but that's okay. We want to make sure. So let's go from here and back all the way up, and then we'll look at the section view if we wanted to. It's typical, whatever, 2 over A 5.2. Let's go look at that. 2 over A 5.2, because you always want to look at your stuff. 5.2, what page are we on? 5.2. 5.2. All right. So it's just telling us about, I don't know which one I looked at. Okay. Conduit, floor base, FRP. And we got this here. And then we have a sealant. So we know how our, at our floor, what it's supposed to look like. And then at the ceiling, of course, yeah, we typically go 6 inches above. All right. So yeah, that's good for that. And floor finish plan. So I need to do, I mean, they even have FRP in the bathroom. So altogether we have 146 linear feet. So times 10, because we know it's pretty much all 10 feet. 1,460 square feet of FRP. And then basically, let's see, wall base 1. Is it all wall base 1? Because we could really subtract this length. Is it all wall base 1? Yeah. So we know wall base 1 is the same length minus, oops, look, boop, boop. Da, da, da. Almost forgot that. Let's add this. And then we really know that wall base 1 is the same length as the FRP minus 2 times the door, right? And that door. So let's just call this deduct WB1. And then we good. We saved us some time. So we'll go from like here to here, do actual lengths from here to here, and then here to here. And everything else is wall base 1. Probably just do it also at windows. We'll just give it the benefit of the doubt. Just say on the estimate we've included wall base 1 at the windows. All right, so we deduct basically 9.5 feet. So 10 feet we'll deduct. And then we know wall base 1. And then the doors are painted. We know we have 1, 2, and we just look at the door schedule really. And we know the amount of that caulking in between is the same length as the wall base. Pretty simple. Oh, and then the sealed concrete, because the whole floor is sealed concrete. Let's see. SC1. I think that's everything. Right? SC1. Oh, yeah. SC1. SC1, so that'll be real easy. Yeah, everything's SC1. So we just say concrete area or floor. Let's say floor because we do a lot of takeoffs. It's like concrete. What is this? The foundation? What are you talking about? Cover. That way we really know we're not talking about the foundation. But what I will do is I'm just going to include all the walls. Well, no, I won't. Because it's always fun to do this. We won't include the walls, right? Ooh, let's see if it'll not mess me up. Watch. Here we go. Sometimes it does its own thing. Let's go back. Tighten it up a little bit. Watch my perfect wall. Bam. Because we don't want to include that. Because we are experts. New section. And let's take care of that old bathroom. Or is the bathroom? No, bathroom's concrete too. They're not really spending a lot here. There we go. Bam. All right. So we know our area, which is our area of the ceiling. If it's all acoustical, let's look at our reflective ceiling because that's a finish too, right? That's a finish. We need to know our reflective ceiling plan from our, if we have any gypsum board, which we don't, so our 2x2, 2x4 ACT is the same as our floor pretty much. Our concrete floor, which is 604 square feet. So that's the same square footage. You might give or take the, for the lights and for the supply grills and the return grills. We don't care about that because they still have to adjust it. So anytime it's less than 2,500 square feet, they charge a little more anyway because of all of these that have to be adjusted for the size of the building. So, same thing. All right, so let me see. I think we got everything for our 4 finishes only. Our paint, right? Let's go to our, where are we? Let's go to the interior elevation. Ta-da. All right. So we call this door area and then times 2, right? Because we have to do both sides of the door. So, I mean, we could just, because we have 2 doors, we don't have to do it, but I like to show the kids. All right. New section. Where's that other door at? Here it is. Here's my friend, the door. All right. All right. And they say I shouldn't go longer than 10 minutes on these things because you guys get bored. But this is, you can't get bored when you're learning. All right, kids? All right. So let me stop that. And then our door frame. So we're just going to say times 4, right? Because 1 on the other side is 2. This one, 3, 4. So, I mean, we already know it's the height times 2 plus like 3 feet, whatever the width of the door. But let's just measure it. And we'll call it door frame times 4. Remember that. But then if we have like a zillion, then we'll have a different procedure to do this. We only have 2. Okay, that's close enough. So that's what? 17 feet usually. All right, 16.9 feet. So 17 times 4 because you price when you paint, right? The labor to paint something that's per linear foot, because that's how you paint that. It's a different labor rate than when we're painting something that's obviously a larger area. It takes more precision, so the labor rate on painting anything that's linear like that is more. So we always want to separate when we paint the wall paint, if we were painting the walls, we're not. From the ceiling paint, because ceilings you have to go up higher, so of course the labor is going to be more for that. And for linear, that's a higher labor rate. So I think we got everything covered for this one. So if you have any questions at all, please email me at education@sfjohnsonconsulting.com. Please give me your comments below and enter and subscribe to enter. I like giving away stuff. I also have a nonprofit, so giving's in my bones. We every month starting the 15th of October, we're going to give away a $100 gift certificate for Starbucks. I'm going to be giving away some free construction training of your choice to all of our subscribers by entering, and if you so choose, or somebody you know, and for companies that listen, we will be giving away $1,000 in free estimating credits for any of the trades that you see us teaching about. So thanks a lot for joining, and I will see you next time. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and I wanted to invite you to our SF Johnson Consulting Live presentation that we will have hopefully on our YouTube page, but definitely free and live on our website, sfjohnsonconsulting.com. And this week, this will be for Mondays. This is all of the free presentations are on Mondays. And this Monday, between the hours of 10 a.m. and 11:30 a.m. Pacific time, and again at 2 to 3 p.m. Pacific time, we will be reviewing and going over the full takeoff and some estimating tips for our new project, which is actually the shell for a Chipotle. So this is the shell, ground up shell. We're not, completely doing all of the interior finishes, but it is just the basic shell, where we'll be going over some site work, utility plan, site demo. We have the striping plan, a grading plan, an erosion plan, the utility plan. We're also going to go over the basic floor plan because it is a shell, right? We're only going to do the exterior walls, the doors, the roof, and the basics for the shell. We're going to go over the roof plan and looking at the exterior elevations. We will also actually do the takeoff for the final cleaning because we're actually going to be bidding on quite a few of the scopes of work. And if you are interested in bidding with us, please sign up at our website. Again, sfjohnsonconsulting.com. We do all your estimates for you. And we are at this point trying to build a winning traveling team for 2023. And we would love for you to join us. So we have to review all the section views, the building section views. So we will be able to determine the heights of the walls and the studs for the takeoff. We're going to do a full, complete evaluation of the foundation. Where is the foundation? The foundation, a complete review of that, shear walls, and last but not least, we're going to do the MEPs because this is the shell, right? All we're going to be doing is all of the electrical, mechanical, and plumbing that's coming into the building. And again, there'll be another set of plans, right, for the interior finishes and all of that. But at this point, sometimes they ask you to bid for just the shell. So it's just the foundation, all of the MEPs that come into the building, the foundation, I already said that, all of the load-bearing walls and all of that stuff. So, and a little bit of electrical, not much electrical, right? Because we're just, again, it's the building shell, which would be all the emergency lights and all the panel and all of the parking lot lights, it looks like, or just the stub-ups, not even installing the lights. Okay, so join us again on Monday. That would be October tomorrow, which is October the 3rd. Yes, October the 3rd. And again, our live performances are from 10 a.m. to 11:30 a.m. Pacific time. And then what we don't finish, then we will finish from 2 to 3 Pacific time. So again, join us, please. And if you have any questions at all about anything we present, please email me at education@sfjohnsonconsulting.com. Otherwise, I will see you on Monday. Start. All right. So we are going to first complete the floor plan because we are going to complete a cleaning estimate for a client. And also, we are bidding on this ourselves, so we are always looking for all of the trades, framing, painting, drywall, in this case, concrete, because this is from the ground up, and we'll also be reviewing the foundation. And so let me make sure we have everything set before we start. And the first thing we always want to look at is the scale and make sure we have the scale correct. And so what we're going to do right now, before we do the foundation, actually, because this is pretty much easier to do, we're going to look at all of the call-outs, detailed call-outs for how it's going to probably, who knows what it's going to show us, because I don't try to look at it too much in advance before we do the estimates. And so we're going to first see we have here, we have wall here, but a lot of the building is a storefront. And so what I'm going to do is I'm going to separate the storefront walls from the main walls. I know that I'm not going to deduct an opening, because if this is the storefront walls, which we will look at the exterior elevations to see how that's built and everything, I'm going to separate these walls, the exterior walls, load-bearing walls, from our storefront window walls, because the wall portion is going to be totally different than if there are no openings or if it's not the storefront. And so we've already, so I'm going to call it storefront. As soon as it catches up, I think it's doing too much. Oh, come on, computer. What are you doing? There we go. Storefront walls, because those, in terms of construction now, it's going to be a lot different than the other walls. And then I am going to go through the door there, because we're going to do this for final cleaning, and the final cleaning is going to really have to clean both sides of the windows. And so that's good for that too. Looks like these are also some kind of window. It's a drive-through most likely. All right, so let's just finish the exterior walls. Am I spelling right? I really don't care half the time if I'm spelling right. Because I know what I'm doing. All right, so we're going to go through that door. We're going to go through all the doors, because in terms of the wall framing, it's waste, and usually if it's less than 16 feet, we go through it anyway. And so we'll go there. So those are our walls. Now, what we're going to do first, let's see how our walls are built. So 4/A 4.1 is what we're going to look at. Image number 4, page A 401. 401. Image number 1. So that's image number 2. Are we on page 401? Yeah. Okay. So all of the walls are pretty much this height to the roof joist, and this is the exterior. And we'll look at what the keynotes tell us. 2, 5, and 7. 2. Frame wall with that insulation, typical, so all the way around. 5. EIFS system, typical. And 7. Pre-finished metal coping so that's for our roofer. We've got that there. Parapet. So we have exterior walls that are, let's scale that, 1/4. This is very easy because it's a shell, so it's not really much that we need to do. And so the walls to the roof joist, that's what I want to know. Wall to roof, because our framer needs to know how many square feet. 14.9. So we're going to have to say 15. We'll just give it 15 feet for the exterior walls, because they are different at different heights, because it kind of goes up. So let's just do that one too. I'm going to use a dimension tool for that one. So just to the roof joist. 15 feet. Okay, so, and then the parapet wall is an additional, because we'll need that for 6.5 feet. Okay, so that's pretty easy. That's easy. All right, so going back here, we know that we have exterior walls of 145 feet times our 15 feet, we say. So that's how many square foot of framing, and we will have a professional estimate created from this takeoff. Okay, and so the framer's going to do that, and let's see. I mean, we need some, let's see. We got to have some more details as far as the walls. So that's the storefront area, all of that window. And so final cleaning, we know we're going to clean both sides of that, so that's easy. And then there's some other drive-through window. And so if I'm going to do windows real quick, which I probably will do real quick, let's do the scale, 1/4. Because we need to tell our windows, our final cleaner, how many square feet of window they're going to be cleaning. So this appears to be window. And if it's not, it's okay. We'll deduct it. And you know what? We're going to go through. All of that is going to be window. Because we got to clean it off anyway. And this is our exterior elevations. And so that appears to be window. We got to clean the door anyway. And all of this is times 2. And then we get this little window. Because we got to clean both sides. And so we'll make sure we have 4. It's like 2 no, that's 3 elevations. Make sure we have all the exterior elevations. So we can make sure we have all as many square feet of window. And you know what? We're going to include that whole thing because we have to wipe all that off when we do our final cleaning. Okay, so let's see if we have any other. One more page that has just a, no, that's the building sections. So that's okay. So, okay. And so we have that. We have the framing, roof plan. We're going, parapet cap. So now we're the roofer, and we need to know, we need a couple of things for the roofer. First, we got to scale it, and we have to tell the roofer how many total square feet of, I think it's TPO roofing, because we are going to bid this. So if you would like to bid this with us, we would love to have you join us. And we do all your estimates, too. When you work with us, we do all your estimates. And we always win. Why? Because we are the best. And then what we do, too. So we have the total square feet. But what we want to also do, remember this is a share. And so we're going to deduct roof openings because, oops, our roofer asked that we always deduct the openings from our square foot total of roofing material. And so we're going to make sure we do this. Isn't this exciting? Isn't it so fun? All right. These people in our country, they need to just do estimates and be happy. Oh, let's go over some more. All right, so the purpose of that is, we're a little off, but that's okay. And so roofer, with the roofer, and so we just finished what the framer needs real quick, right? And hood below, this is a big one. And what we also need is, because we'll have to flash the same openings, we really need to know how many linear feet, but because my tool I did point by point for each of these squares. See how that square is 28 linear feet? That square is, same thing, should be, right? Same 28 linear feet, so I don't have to do the linear feet. I could just do that. 7, I'll round that up to 8 linear feet. 9, 8.5 linear feet. 12 linear feet. 43, so that's the flashing. See how great that is? And then let's see what number 9 is. Solar ready. All right, so I'm just going to do this area just in case they need it for something special. Just in case I'm asked to price a solar panel or solar something. Solar is weird how they price it, so I'm just going to do that just for the heck of it. So I'll know. Just in case they need it. Oh, look. Forgot that. Look at that. Openings. Deduct. So let's go here. Oh, wait. I got to remember I didn't go all the way to the top, so my linear is going to be off. Or look. Bam. Yep. Let's start over. I don't know if I did that on the other ones, but you see the point. Okay. Oh, I did that again. Okay, so we know what Stacy should have done. All right, and another thing we need to get. We know we've got roof drains. So we're going to need the roof drain. We're going to need the flashing for the roof drain. Roof drain and overflow drain. And then we're going to need the perimeter for the parapet cap and flashing. Anywhere that window or wall meets roof, we need to consider we need some flashing. So if I would have done my roof like I did my openings, I would know how many linear feet this is, and I would not have to do this, but I'm doing it anyway. All right, so what we don't know really yet is about our walls. We did the measurements, but we got building sections. Okay, so we're going to go here, right? Because 3 over A 413 is probably going to tell me the makeup of my wall. 3, 4, 13. 3. Yeah, see here are all of our walls. So for our framer, what are we doing here? Okay, that's the foundation. So we'll do all of that from foundation. Rough carpentry, that's a 6-inch bottom plate or 2 of them. Well, you can always measure and make sure. That might be a little. Oh, that's about the same. Is it the same? We'll look on the foundation, but we know that storefront, height, tube, wood stud walls with that insulation, vapor barrier on inside face of wall, refer to structural for stud spacing. Structural for stud spacing? Okay. EFA system over waterproofing over exterior sheathing. All right, so we got that. We have all the measurements to do all of that. And then all of the window, we have to measure maybe the length of the windows for our bottom plates, for our window top plates, for our wall, whatever you want to call it. And then this is on our structural, any headers, everything above the window is the structural member. It's the header. Below the window, it's from the framing. Kind of rule of thumb, but kind of not. And we know that the insulation is going to go only to the top of the building. We don't need to insulate the parapet wall unless it was a second floor, right? We only insulate where the humans are. All right, so, and it's interesting right here. Whatever that is, that's a lot of little things. So we could look at, right? Call out 5 over A 421. Let's do that because when we do the actual takeoff, we need all of this and be able to determine how many linear feet. So how do we go from the takeoff, right? This is just a section view, but when we're at the floor plan, I'm so glad. Almost thought I didn't turn the mic on. Thank you. All right, so when we're at the floor plan, right? So we have to measure if we have a detail call out, say for instance, like this one. Well, this is referencing because we know where the section view is. We know it's only in reference to this opening in the door. We know that this is only referencing this because it is within the call out. And so if whatever I see at 2 over a 413 to do the takeoff, well, I'm going to measure how many linear feet from here to here. Let's say 6.5 feet. And so I'm going to go to 2 over 413. Next one, 2 over 413. So if I go to 2 over, where is it? Right here. And so I know that that was 6.5 feet. That section view was 6.5 feet. And so I know that I need 6.5 feet of this, 6.5 feet or whatever that is, 6.5 feet of this one, this one, this one, this one, and whatever this is. 6.5 feet times the length of that is what I need, because every section view, right, is broken down. And so when we look at the exterior walls are all 4 over A401. So whatever I see at 4 over A401, I mean, pretty much all of the exterior walls are this construction. So I go to 4 over A401. I go to 4 over A401. 401. 4, right? Where is it? It's up here. Okay, I go to 4 over A401, but then again, I'm the framer. This doesn't tell me anything about my framing. So I'm like, oh, okay, here we go. Because I'm the framer, it's got to tell me more specifically about my framing. I can use this like I did before to determine how many linear feet. This doesn't tell me the wall framing, the drywall, the insulation. But if I go to the call out, if I go to 1 over A413 now, I get more specifics. 1. Now I know how my wall is built because there's going to be some arrows hopefully pointing to my wall. And I know all my exterior walls are the same. So if my arrow's not pointing here, then my arrow's going to be pointing somewhere else, and I'll know it's the same wall. What's the and it says, oh yeah, look at the structural for the type. All right, so we go to the structural. That's the roof framing. Okay, roof framing is structural because the roof is a structural member. So the roof framing, not the roof finish, is structural. And so we'll look at this. We'll see what this is when we get there. It might be this afternoon's presentation. Girder truss. And let's see what we got. Oh, prefabricated truss by others is this distance. Now that's what I like. Is when I have a set of plans that show these things. Okay, so it only applies to structural framing. And so when you have these little things, that circle and that arrow, that tells the framer that only within here, only this part is whatever this is. So now we have it again, right? From this all the way to here. And then again to here. It looks like it's continued because it's not giving us any description. Yeah, so it's all the way through. So it goes from here to here, and then it connects here, all the way through here, and then again, just like that end, it tells you a different type of truss. And so what that means is from here to here, where one arrow begins and the other arrow ends, you got to look and find where they're trying to tell you about the trusses. And that would be, maybe they're breaking it up now. Yeah, they're breaking it up. We got arrows. There we do. There we do. Okay, so here we go. Let's start again. Because like I said, never look at this until I look at this with you. All right, so from arrow to arrow, we have this type of truss. 1 or 2 ply prefab trusses by others at the 32s. Okay. And then we go from, we have a new arrow, this arrow, to this arrow, and we look for the description. There we go. 1 or 2 ply prefab, Then we got another set of arrows from here to here, and we look for the description. So, when it comes to trusses, if they're putting them every 32 inches, then if you want to know how many you need, then you have to go 32 inch. Oh, wait. Yeah. Feet? No. Heck no. What's wrong with me? 32 inch. 1. 32 inch. Another one. 32 inch. Another one. Da-da-da-da-da. All the way through. Okay? So if you want to know how many, because you can't, I mean, I guess you can. I guess you can. You could do it just like you do. Oh, you could do it the same way. How many linear feet? Turn it into inches. Divide by 32. Either way, the first way is so much more nerdy and special. All right. So we always going to look for our headers, right? So this is a metal header, H hollow structural steel, and the dimensions. Okay, and usually with fabricated metals, the last digit on like W 84 by 115, the 115 tells you how many pounds per linear foot that can hold. And so if you know how many linear feet of that type of truss, then you know you can determine how many pounds, and they're determined price by the pound. So I rarely get those these days. All right, so we were looking here to see what kind of framing we got there. All right, here we go. Trusses, hold down, number 2s, wall, number 6. Oh, look at that. Tells you how many linear feet. That's nice. All right, so let's see. Our walls are, we already know they're 6-inch walls, and we know that they're wood framing, so it's not really difficult to determine what we got here. All right, so our post, right, and our columns are hollow structural steel. Then we look at 9 over S200 to see the makeup, and that's prefabricated, I'm sure. No, we got a couple of wood posts. That's nice. Okay, and so we do our framing takeoff for the structural framing. Our posts, are 15, 16 foot? So we just assume they're 16-foot posts with all this extra stuff to hold them down, embed them within the concrete. Slab on grade. We'll do that. That's easy. 6-inch concrete foundation wall with number 4s at the 16th vertical and horizontal. That's nice. So number 4 goes this way and that way. So you do it the same way. The number 4s are what, at the 16? Yeah, every 16 inches. So how many linear feet multiplied by inches, right? So you change that into locations, times however many locations, and then the length. That's for the ones that go in that direction. And then you do the same thing for the ones that go in that direction. For the how many linear feet of how many linear feet of number 4. Our whole purpose is to do this for the final cleaner. So they have to clean, wash down the walls. They're going to have to probably polish the slab on grade or wipe it down or buff it or whatever. So we're going to measure how many square feet for our concrete person too of slab on grade. Do, 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 do. And we'll look at the foundation section views for the footer, the stem wall, all that stuff. All right, but for now, we're going to say slab on grade. And we know it's 4 inches. So it's the whole kit and caboodle. How old are you? Old enough to know all my construction principles. All right. And see, now I'm going to go all the way to the top so I'll know my footer minus that piece because I didn't go up in there. I have 211 linear feet all the way around plus what is this linear feet? How do we read this, boys and girls? From hash mark, there is one, not one, but from here to there, the number in between is an extra 9 feet, 4.5 inches. So that's our foundation. Almost 23, right? 100 square feet. All right, so let's get rid of that real quick. Cut off the light bulb. All right, so if I'm doing, so my final cleaner's got to buff out 2,300 square feet of concrete. And let's go look at some foundation section views. That's our main wall there, structural, external wall there, and we know any walls that are connected to the footer, the concrete footer, is going to be a structural wall. So that is a structural wall if we have framing connected to it and bolted into it. And then we could look at section view 10 over S201 for the configuration of all of that. So you got a lot of section views here and a lot of call outs. So the concrete person knows basically how to form the concrete and more importantly, how to place the reinforcing steel. Okay, so let's look at 7 and 6 over S200. S200, 7 and 6. Oh, look at the beautiful stem wall there we've got. So per plan, I think our plan told us. I don't know. Per plan. It told us. Okay, so we've got from here. It's a 6 inch, I think. So this would be a foot stem wall. So I know my stem wall is a foot by 412. Right? So I know how many square feet of concrete. But then concrete is in cubic yards. Right? So how do I do that? Well, I always turn cubic feet into cubic yards by dividing by 27. Remember, with concrete, you have 3 dimensions. You have the length of the wall, which was 411 feet. You have the width of whatever it is, 1 foot, 2, 6 inches, whatever. And then you have the height, which is 6 inches. So that's 3. Multiply those 3 together, then you shall have cubic feet. And then divide that by 27. That gives you cubic yards. So now, if I know my my plate, I got a single bottom plate, stud wall, and sheathing per plan. We've got some shear walls, right? We got it when they talk about that. We've got also the waterproofing, okay, exterior footing. All the different section views for all the different concrete configurations. That's a stem wall at stud wall with 12-inch foundation wall. That's nice. Reinforcement per plan. I don't know what plan they're talking about because this is the plan. So I don't know. We don't want to spend a lot on our stuff here. We just do that and let the pros figure it out. All right, shear walls. Here we've got our steel. I can't even think. I just said it. Our structural steel headers, posts, beams, plans. So we don't have a construction defect. Okay, so this is typical base plate, concrete wall connection, HSS column. Okay, so 2 times with hex nuts, just 2. It don't say per side. Okay. All right, so we don't mess up and the thing don't fall, right? It don't fall. There we go. Isn't that pretty? All right, so you know what you're doing when you can look at your detail views. You got to be able to get down to your detail views and do the math. Okay? Very, very important. Stem wall or continuous footer, stem wall, and we got the hooks here, and then we also have individuals running the whole perimeter, right? This is a section view, so we cut it and then we broke it apart, and this is what the interior construction. So this is what we use for our detail material quantities. You got to be able to look at the detail views and determine your material quantity. So I've done that. So my foundation, I want to do my foundation. See, those are my 2x6s. And then, see, I have different continuous footers, see. So when you do your takeoff, let's just do that. Did we already? Yeah, we did, because we did. See, when you do your continuous footer, you want to make sure you break up your sections because you want to go back and look at each of these because what? The continuous footer is going to be different. The stem wall is going to be different, thicker, smaller, whatever. And then what we got here? Look at that. So we have a 4-inch slab on grade outside the building with Okay. And here too. So that's the additional concrete work. And then okay, so let's look at that. 9 over S201. 9. All right. Okay, so yeah, that's slab on grade. So what do we do in this case? So you have this this is almost like, this is kind of different because it's not like this. It's not as clear when you want to determine how many square foot, when you want to do actual, like how much. So with me, here's real clear. This is about, 6 inches. This goes from 6 inches to 12 inches. I'm going with 12 inches. Sorry, I'm just going with 12 inches stem wall because I'd rather have more than not enough, right? So to do the takeoff for this, you have this stem wall, this continuous footer, this stem wall, and then the flat portion slab on grade. And then, yeah, you're going to do dowels to match the slab reinforcement at the 24s. I mean, 24s, that's 2 feet. This thing isn't even 2 feet long, so it's probably at both ends of it. This one right here at the 24s. And this is a continuous, right? So it goes all the way through the slab. And this these two go all the way through the slab. And so however long the slab is, right? Let's go back. Where were we? I don't know. So yeah, so however long the slab is, that's how long that continuous is, which is this. I like that. So when you can go from plan view to section view, and the section view will take you to detail view. You'll make sure you have a good thing. All right, so we're going to take a break and see what else we got. Remember, this is a shell, so we don't have any. This is all the MP we got. Mechanical plumbing plan. We just have stuff when it's a shell. We only have things that are coming into the building. So even the electrical plan, right? Just coming into the building. No lights, no nothing. Just the panel. Even I don't even see that we have the panel. I don't even see the panel. So I just put the lights in. There's no panel. Let's see, the junction box, lights, yeah, we just putting everything in. So when there is, unless we have to provide temporary power, of course we will. To make sure this works, because it's just like junction boxes for the drive-through. What's one? Yeah, civil set. Yeah, we were looking at that. Civil set, site demo. Civil set utility plan, so that would be our power coming through. Water. Where's power? Water. Let's just look on the list. We're looking for transformer. I'm not really looking. Now I'm gonna look. Sewer, grease, trash. Existing cap, this, that, and something else. No? Do we have a electrical site plan? Other than, okay, no, so we just, panel A. It's just right there in the middle of nowhere. That's beautiful. Okay. So, yeah, we'd have to get more details. Oh, there we go. Shell, of course. We just had it floating out in the middle of nowhere, but it's going to be somewhere. And we have to look on I'm sure it's shown on the utility plan. We'll find it before the lunchtime presentation. See, so shells are nice. And again, let's go back. There's a whole bunch of stuff. This is a shell for a Chipotle. See, it doesn't even say, but yeah. This is a shell for a Chipotle that's going right there. Next to it, I think that's a hotel. That's coming up later. So, yeah. We've got everything, the civil set. Yep, 23, right? That's what in the pickup window. And then we're going to do site demo this afternoon. We've got some site demo. We knock out some trees. And that's always nice. And we're going to stripe the parking lot. Yep, it's going to be beautiful. And we got some site concrete now, other than the foundation, right? So the site concrete is going to be on the civil set. Grading plan, I'm not messing with a grading plan unless it has the section view of the earth, and it does not. So when they send me that and ask me to do the grading estimate, nope, unless it has properly been section viewed so you can see what the existing elevation is in comparison to the one they want. And that's the only way I can do it. Now, they'll sell you a $1 zillion program that'll take all of this and claim they're doing it, but nope. I'm good. Erosion plan, what's that? All of those fences, all that stuff. That's not really fun. But what is fun is the utility plan. So we'll do all of that later this afternoon. But right now, we are going to make sure we have everything for our framer and our final cleaner. Oh, you know what? For our final cleaner, I'm sure they're going to have to, I don't think they'll have to wipe down the exterior. Other than, oh, look, we left out windows. That's why you don't, come on. That's why you don't do the estimate in one day, boys and girls. Because it's not due till Wednesday, I don't think. All right. And so the framer has what they need. And all of this is that parapet wall. I'm assuming that I did get the roofer. Let's see. fix what the roofer needs. Let's get the roofer valley flashing. That's always fun. And we don't care about spelling. And we want, and then sometimes we have to have this insulation like doubled and tripled over. Because right valleys are lead us to water flows from the valley. Might be some parapet walls. I mean, some crickets in here, but it doesn't really say specifically. And that is another opening for our roof latch, roof thingy, so we can get on the roof. And that's where our ladder is on the other side. All right, so the roof is good. And what's 8? Let's see what 8 is. Canopy. Okay, we don't care about that. We're not going to install that. They have a vendor. All right, so we have our floor plan. And let's go to, because we got our walls. Let's see. We got the roofing membrane. So not only do we have it that the 23 square feet, we've got to have the roofing membrane up the parapet wall too. So that's an extra, let's scale that, 3/4 equals 1. Sometimes this stuff be off, but we'll try it. So the parapet wall needs to be in it. Oh, we did say it was 8.5 feet, right? Well, no, not the parapet wall, not the, no. Let's see. And if you had questions, you couldn't ask me because I'm not paying attention. But next time we'll make sure we do. Let's see. Dimension. Because we want the additional, and we'll add that too. Because it's got to, they say go up and over, right? And that's the insulation. So it's going on top of the insulation. So we can stop right there, extra 5 feet. So extra 5 feet times 411. So that's a lot of extra TPO that you don't want to mess up or forget about. All right. I think we got it. I think everything. Insulation, we're going to go up let's just do this. Insulation. 14 feet. Say 14.5 feet times 411. Right? That's the perimeter of the building. We got pretty much everybody's takeoff. Just have to do more in terms of the foundation. Or let's go, where are those shear walls? That was annoying the way that they did this. That was annoying. Let's see. Where's the foundation? Where is it at? Okay, no. Another thing, framer needs to know all of our doors, so we only have 3. And then the storefront, that frame really is questionable. The aluminum storefronts, usually the framer doesn't provide anything but the hollow metal one, so, that's another question. But if it's only the hollow metal, then it is one that is 3 feet 6 inches high, wide by 7 feet high, easy hollow metal, and only has to install that. And the storefront person most likely would install the storefront. All right, so we're gonna take a quick break until 11 a.m. to let it all sink in. We'll be right back. Okie dokie. We're going to get started again. I'm going to take a little longer break there. All right, so this is a shell for a Chipotle located here in lovely California. And we are looking for contractors to bid with us. And as you can see, we'll do your estimates for you. This is actually a shell of the building. It's not a complete interior fit out, build out, whatever they call it there. So it's just the site and the shell building. Makes it real easy. And so now this afternoon when we present at 2 o'clock, we're going to do more of the pricings because we pretty much know how many square feet or whatever. We're going to do all from assembly pricing. So we won't break down the individual pieces of, say, like the foundation until, we're ready to win and do the work and get an actual pricing. Foundation, assembly prices should not be much different than individual pricing of the concrete, the rebar, and the formwork, and all together. The assembly price should not be much different. So, all right, so here's the demo plan. So it has it's in the middle of somewhere, and we have to get rid of some things first. And so let's see what 5 and 6 is. Protect. Let's see what we're removing. All right, so 1 and 2. Okay, so removing a tree, it's important to know the size of the tree. And we go by the diameter of the stump or the base of the tree, that diameter of that tree. That's how they base, either putting it in or taking it out. Okay, so that's important to know. And if you don't know, it's important to find out. So can you just pull it up, right, with very little effort, or you got to cut it down? Those kind of things makes a huge difference in the world of construction. All right, so 1 and 2. Where's 1 and 2? Do we have a lot of 1 and 2? Not really. Okay. And so if this is dirt, then we don't need to saw cut anything. I don't know if it is. This may not be. On this side, this is probably. So we'll saw cut that. Include the price for our demo for saw cutting this, because this is probably attached to something, just like maybe this is. I don't know. But what's the scale? On these plans, scale's in a funny place. Here we go. 1 inch. Oops. Cancel that. We don't want that one. 1 inch equals 20. There we go. We agree. And so we're going to demo. We're going to 1 and 2 first. So we're going to demo curve. And in this case, we don't care if it's curved or straight. And in the afternoon session, we will be going over actual pricing. Okay, so now we want to saw cut because we don't know. We can delete that if it's no need once we win. So we think that's connected to something, but that doesn't appear to be. And so now we're going to demo. Let's just say remove concrete. We'll assume that it is reinforced because that's how we price it. It's priced different if it's reinforced. So we're going to go like this, this. Let me go down. There we go. Oh, come on, don't fail me. All right, is that see. 1 and 2, 1 and 2. Yeah. Okay, so there's a lot of protect. So we just going with where we see remove and see. That's a big tree. Those are two big trees. Huge trees. So we have to get more details. But remove tree. Big. We'll assume that it's the biggest that the cost book gives us. I think that's 24 inches around. All right. I think those are the only two trees. And what else is remove? Remove is a property line per lot adjustment. Remove property line. I don't know that applies to us. That's property line is just set. Yeah, we'll ignore that one. Let's see. So you give some time for field verify. Reveal an 8-inch sewer main exists. That's your property. Okay. So we give an hour for that. Field verify location. Hour. Field verify. Hour. Abandon it. That's easy. Remain. Quit claim. Given to. Not our problem. Protect. Now the protect part, we can do some protect. We go into the specifications on how they mean protect. And we have those, so we'll bring those up in the afternoon, 2 o'clock Pacific time. Remove sidewalk panels marked. Remove sidewalk panels. Oh, okay, like those metal panels probably. 17 curb and gutter. Okay, because we can measure that. Oh, look, we had more one. All right, let's go back. Let's get this one. All right, so what do we say that was? The panels are 16, 17 is curb and gutter. Okay, there's the panels. 17 curb and gutter. Oh, that looks pretty. Seventeen. Then we'll just 17. All right, and panels, sidewalk panels. And about 3 hours of side. 3 hours of verify. And that was sidewalk panels. That look kind of big. I don't know what kind of panels those are. Those are concrete. And if they are, we'll do them different once we know. And that's all the remove there is. I'm not worried about protect. Let's see, 14. Yeah. Okay, protect utility box in place. Okay. Boulders surrounding the site. There's a separate one. I guess you just got to go out there and see if you find some boulders because they're not marked. So wherever the boulders are, get rid of them. That's extra. So all those are things to note, but nothing to really, be able to determine because they're not shown or anything. So that's like removing a tree. depending on the size. So that's that one. All right, so we go all the way down. The striping plan, really, we just, now they have a stripe. Let's see. We need a concrete plan. That'd be nice. Yeah, there we go. Existing is A, so let's do pavement C, sidewalk D. Okay, let's do D. Now, when we price the sidewalk, you can price the sidewalk by the width of the sidewalk, or we can do it by square feet. So that looks to be about a 3 to 5 foot sidewalk. So let's see, we're going to do it both ways this afternoon when we come back together. So we are finished here at 11:30, which is about 10 minutes, and whenever we don't finish here, we'll finish then. All right, so scale, always scale. And I know my sets of plans are always good, so I don't worry if they're correct. All right, so sidewalk was D. Let's see what the width of the sidewalk approximately, because you can price it by the width of the sidewalk. It's a 6 foot, not even 6 foot. I go by 6 feet because it's closer, but then you got to make sure they're all 6 feet. See, that's 6 feet. D, now that don't look 6 feet. See, that's 5 feet, 6 feet, what's that? That's a special kind. That's a curve right there. So, can we use all 6 feet? Or just measure how many linear feet? You know what? I'm going to use 6 foot wide concrete sidewalk, because that's how we price it. 6 foot sidewalk, instead of doing it by the square foot, because we're going to do everything assembly price. So it goes pretty much from here to here, and then from here to there. We're going to just give it extra. Always give it extra. Here to there, and then there. To the front door. D. Then we got some right here. Might as well finish it up right there. We got some right there. That's the patio area. I'm going to make that different. And do we do all D, though? Yeah. All right. So that's the sidewalk. And then C was parking pavement. We're going to do that by square foot. We'll call that parking. And then we'll go by cost book wise, what it tells us. So we're just going to include all of that, because this gray is different. It looks like we have curve too. We need to determine how many linear feet. Lots of. Oop. Oop. Going to Nilly Willy. Yeah, let's just cut it off halfway right here. Because I like to be as precise as possible. All right, let's cut it off right here. And you know what? Yeah, we got a lot of this and the small little curve. Let's go. We're just going to add that. very like surgery. Forgot I'm recording. Like, hey, it's still quiet. Except for the clicks. All right, there we go. See. Let's see. Yeah, then we gotta come through and do the more annoying curves because we're a little bit. Ooh, look at me. Look at me. All right, see? All right, so striping plan. Why don't you call it the concrete plan? The heck? See, they broke it up in phases, but we don't care. Let's hope we're not asked. All right, we got some arrows, so we do those separately. But in the meantime, what is B? Sidewalk. No. Did I say what? I said B. Drive aisle pavement. 5 inches. Then 9.5. 9.5. Da da da. We'll look at the specification, but I mean, we could go on, right? And what's G? We'll do G. Let's just know what it is. We got 5 minutes for this session. Oh, good. No. Landscape. That's good. That's where the flowers are going. Flowers, flowers. What's M? Bike racks. That's nice. Let's see. It's going to be flowers. Okay. Because that's still in this area and not in this area that we didn't include in the sidewalk. And you see right here, it's a little thicker. Right there. So we're going to say that's probably let's see. We don't have to guess. Well, what's this one? 4 inch. Okay, well that's the smaller one. Let's delete that one because we said they were all inch feet, not inches. So let's do this. This is still our 6-foot concrete up until we get to there. Then it's a 4 foot. 4-foot sidewalk. From here, right there, let's go over a little bit. From there to there. Okay, and then, yeah, we'll fill all that in while you're gone. And then A, we'll fill that in while you're gone. And then G's the landscape is A. Oh, good, existing. We don't need to fill that in. And so that should also mean we're not striping that. Let's see. Yeah, no. We're going to say we're not because it's existing. So we are going to always exclude existing striping. All right. Stop. All right. So that is the Monday live edition of What the Heck is Stacy Doing? All right. So this is our shell. Right. So when we come back, we're going to complete the little pieces of the takeoff we didn't do. And more importantly, the pricing. So if you have any questions between now and 2 p.m. Pacific time, make sure to email me at education@sfjohnsonconsulting.com, and I'll see you this afternoon. And to participate in the OSHA inspection. And you have the right to be free from retaliation. Now, workers also have responsibilities. Okay, and according to Section 5B of the OSH Act, each employee shall comply with the occupational safety and health standards and all applicable rules, regulations, and orders. That's just about the size of it. That's about it right there. You have to comply to all of the standards as you know them to be, and your employer has to make sure you know of all the hazards and provide you with all the personal equipment you need. So now we will, I think this is one of our audio presentations where you'll be asked to answer a couple of questions. But as far as the OSHA standards, what are OSHA standards? The OSHA standards are basically laws that OSHA has created to keep workers safe under certain circumstances. And so for every aspect, we study construction, our standard is the Code of Federal Regulations 29 is the book assigned to the Department of Labor, and there are a set of standards designed as follows. For general industry, which also apply to construction, the book is 1910. For the construction industry, the book is 1926. And for maritime, it is 1915. So when we say the book, all the laws, like every law in our country, has a number associated with it. And so for the laws associated with the construction industry for OSHA, they are 29 CFR, and then there'll be either 1910, those that apply to both general and construction industry, dot something, or 1926 dot something. Okay, so I have some handouts that we will give to our students. Feel free, if you have access, to go ahead and print those yourself. And next, we're going to talk about the inspection process. Only way that OSHA can enforce the standards is through inspection. And there are certain levels of inspection that take place depending on the level of hazard, or in certain years, OSHA chooses certain industries to target, basically. So let's look at the OSHA inspection process real quick.
OSHA's mission is to ensure the health and safety of America's workers. Enforcement plays an important role in the agency's efforts to reduce workplace injuries, illnesses, and fatalities. This video describes the general OSHA inspection process and the reasons for an inspection. OSHA conducts inspections based on imminent danger situations, worker fatalities, hospitalizations, amputations, or losses of an eye, worker complaints, referrals, targeted inspections aimed at specific high-hazard industries or individual workplaces, and follow-up inspections. Compliance Safety and Health Officers, or compliance officers, are experienced, well-trained industrial hygienists and safety professionals. Once the compliance officer arrives on site and enters the facility, the inspection begins with the presentation of credentials. There are three basic parts to any OSHA inspection: the opening conference, the walk-around, and the closing conference. At the opening conference, the compliance officer will explain why OSHA is inspecting the workplace and describe the scope of the inspection, walk-around procedures, worker representation, and the need for worker interviews. The employer is asked to select a representative to accompany the compliance officer throughout the inspection. During the walk-around, the compliance officer will consult privately with individual workers. Common questions may include: how long have you worked for the company? Have you or anyone else been injured or had close calls on the job? Does the employer provide personal protective equipment? How often does the employer provide training, and what is the training composed of? Is there anything you would change to make working conditions safer? After the walk-around, the compliance officer holds a closing conference with the employer and designated representatives to discuss the findings, possible corrective procedures, and reasonable timelines for correction. The compliance officer also discusses potential courses of action an employer may take following an inspection, as well as available consultation services. Following the OSHA inspection, the compliance officer will put together a report based on what was discussed or apparent violations. The information is sent to the area director, who determines whether or not a citation is issued. If a citation is issued, the employer has 15 days to take action, such as requesting an informal conference with the area director to discuss any issues and address the penalties, or contesting the citation. A safe workplace benefits everyone. OSHA uses both enforcement and compliance assistance to achieve this shared goal. Ensuring compliance with OSHA standards is an integral part of the agency's mission to keep workers safe and healthy. That's why OSHA is working to give employers the knowledge and tools they need to comply with their obligations and provide safety information to workers. OSHA's on-site consultation program offers no-cost and confidential assistance to small and medium-sized businesses. The program helps businesses identify workplace hazards, provides advice for compliance with OSHA standards, and assists in establishing and improving safety and health programs. OSHA Training Institute education centers also offer training courses designed for workers, employers, and managers on safety and health hazard recognition and abatement at convenient locations nationwide. For more information about OSHA inspections and compliance assistance resources, please visit osha.gov or call 800-321-OSHA.
All right, so inspections. Okay, so it says that there are about 2,400 inspectors for over 7 million workers. And so they target the most dangerous workplaces first. So definitely if someone calls in, that kind of thing. And you never want to fight an OSHA inspector, guys. Okay? You just don't. Because, if they're there for a reason. Okay? And you need to make sure you keep your workers safe. So why was OSHA created? The intro to OSHA? Well, OSHA was created after 70 years of workers dying, us trying and then not doing it, government officials not caring enough, like most things, right? Which is ridiculous, to keep all Americans healthy and safe when they're at work. So by 1970, they got their act together with President Nixon, and they created the OSHA Act through the Department of Labor. They have things called OSHA standards, which are the laws in which we're going to go through in very good detail. We know that the owner has responsibilities and the workers have rights. Here is a link to OSHA Gov. It is a government agency. So, and as you can see, when OSHA was first created, they made it a law. It was, first only for federal employees, right? Just like everything's good for the feds. And then we get it. And then eventually, yes, we ended up with OSHA for individual employees. So if you're a student, for $5, if you weren't watching this, $5 Starbucks card, take the test, pass it, and I'll email you some Starbucks for your time. And so what will we study after we know why OSHA was created? Well, we're going to go back to, I hope I can. No, I can't. Oh, you know what? Oh, that's right. I'm actually on my work site. So let's go back to this one. So now we will go on to study the next topic, and what we'll cover next week is the Focus 4. right, or fatal for the four most deadly things or reasons employees are injured, dead, killed, injured, whatever. So we'll do the focus 4. That'll be next. But then, yes, we study all of these, and eventually, if you have access to this site, all of these links will be active eventually for you, so you can go through each one and look. But yes, so we'll be covering OSHA 10, of course, covers 10 hours of study. We do have mandatory, which is pretty much these right here are the mandatory ones. Right here, pretty much right here. And then they get to choose from all of the others. So, and I do always recommend a leadership class for one person in the company to be the local trainer for the company. Now, also too, at any time, OSHA could walk in and ask you for any of the following forms. Are you ready? And we will have links to each of these, a little video for each of these that say the reason, how you fill them out, what you need them for. But yeah, you need all your forms. Okay, so that is OSHA Live on Monday. And if you have any questions, please don't hesitate to email me at education@sfjohnsonconsulting.com. Otherwise, I will see you next Monday for free, but look all through the week for our active links. And on the 15th, we will be, for our subscribers, have a drawing for a free certification where you'll join other students and get your certification. Have a good and fantastic rest of the week. See you later. All right, let's try it again. Hey, everybody. Thank you for joining me, or thank you for listening a little later on YouTube or wherever now. We're going to be posting our content on a lot of different platforms here. Thank you for joining us today. And if you did join us this morning at 10, from 10 till about 11:30 with the break in between, we went over the shell. Pretty much all of the aspects as noted. It was an hour and something, so if you do watch it on YouTube, please finish the whole thing. Tell us what you think, like it, don't like it, but please leave comment. I've been in this business for 13 years, and I've never once sent out a survey, because it's like, hey, I know what I'm doing. I don't care. I don't care. Like my grandson say, no one cares, and he's 5. So, and I'm a girl, right? At least hopefully you can tell by now. Queen, I'm a girl. And, most guys are in this profession and they always like to make girls feel bad, especially smart ones. And so, I really didn't care because I knew I was probably smarter than everybody that I was helping, which wasn't always true, right? Because nobody's smarter than everybody. Everybody has something they can learn from everybody. And I've learned so much from all of the contractors that I work with, but yet they have learned so much from Nerdy Me. So today we're not going to go over the pricing and all of that. In this hour, we're going to basically go over something that a couple folks have been asking me, because this is something I mentioned this morning. And it's crazy when you have to do the estimate for the earthwork and blah, blah, blah. And so I thought, well, at least I can give you some tips to think about when you are preparing the estimate. And please note that I am waiting for a text message. And when I get it, I have to tell someone that someone is here. So, all right. So, where was I? So tips for the earthwork, okay? And so let's do that. So again, when you are doing the earthwork, hopefully I can get this. All right, so a couple of things to think about. But first of all, the set of plans is the most important thing, okay? And if you don't have a good set of plans, you have to have a software that's able to look at the elevations on the grading plan. Somehow there's a software somewhere that can do that. look at the contours on the plan. If you have good contours noted in black or whatever and whatever. I don't know how that works. But about 10 years ago, 5 years ago, 6 years ago, I don't know, my memory's fuzzy. A few years back, they started to produce plans that were based on cuts into the earth, right? So now you could have a visual of or section view of the earth where they would give you the existing elevation in a that's also to scale. See, that's to scale. That is, you can do the area, right? So they give you the existing elevation, the proposed elevation. You could actually, because the sheet is to scale, you can actually measure the area, and then if you know the thickness of that area, boom, you have your 3 dimensions. And so you can know how much, and then 3 dimensions, right? 3 square, I always do square cubic feet and divide by 27 to make my cubic yards of dirt, just like dirt, concrete, any of the volumes, right? You have to determine in cubic somethings. But like flooring, somehow, I don't know why, but vinyl flooring is by square yards. Maybe because you use so much, they don't do square feet. I don't know, just to make your life difficult. Square yards, yeah. Just to make your life difficult. Back to this. So, what you want to look for immediately if you have to do an earthwork takeoff is to look and see in your civil set, right, in the C plans, if they have a section view of the earth. And what you'll note on your site plan is that you'll see section view markers that cut all the way through the site. And if you have that, hallelujah, because you can easily determine your cut and fill totals, which is what you need when you're doing earthwork. But in the event you don't, or even if you do, here are some of the things, and this is part 1. I should have put part 1 up here of some things to think about as well, especially if you don't have good plans to do the takeoff. 1, how accessible is the site? Okay, so is it off the Grapevine? You're building a restaurant off the Grapevine? You got to go up the hills and all that stuff to get to, or is it in, a city where the freeway's right off the exit? You can get to it, right? You can get your equipment, machinery there in one day, whatever. How accessible is the site? First question. Because if it's not, then what do? In all of these things, you add more labor, you add more man hours, you add, if it's not accessible easily, you might have to have your crew spend the night, be there the night before to start work, right? So then what do you have to do? You have to pay for room and board for your, how many can fit in a hotel. You got to do that math, okay? So that's very important. How accessible is the site? How far will you need to haul material? So that would be a lot of things, how far you need to go. Same reasons. Do you need to stay overnight? You got to go 15 minutes, an hour in traffic. You need to make sure you work overnight, or do you have to work overnight? You need to make sure, because you have to haul a lot of material. You got to make sure you can get it there and not be I hate traffic. Not be in a lot of traffic. All right. Are utilities, housing, food, and first aid available for your crew? Well, first aid has to be available, right, because of OSHA. So that's a non-starter. That's one of the OSHA standards, especially if you're out there. You have to have a first aid kit. Someone has to know CPR, all of that. Okay. And if you're doing asbestos, you need like a shower on site. I want to go to anybody saying they're doing asbestos, because if you don't have a shower, you're not abiding by OSHA standards. And who has just a shower to put out somewhere? So yeah, you need that. All right. Will compaction material be required? That's very important. So if you cut and you fill, usually, maybe, hopefully, the material you use to cut or dig it out, right? You can say use the same to fill. But what if you don't have enough? Maybe you got to cut a whole lot more, or you have to fill a whole lot more than you cut. right? Which means you don't have a lot of existing compaction material. You have to buy it. So, do you? So, what does that take? That takes making sure your takeoff is right? Because if you can't do a proper takeoff and you're saying, "Oh, I have so much and we can use it. It's been the soil's been tested. Our cut material we can use for fill material." Okay, but what if you can't? What if you don't have enough? And where are you going to get it? And all that good stuff. So, and how much do you need, right? Because how much do you need? You need to make sure you can have an accurate takeoff. And now with GPS, you can do it a lot of other ways. But if all you have is a set of plans, some folks have, drones and they're doing it, which is beautiful. I love that. Okay, but that makes a difference. Yeah, for the question of will compaction material be required? You'll only know that if you do a proper takeoff to see, for one, if the cut material can be used for compaction, and if not, where do you get it? All right, shortage of labor, yes. Okay, with COVID, hasn't there always been? So, I don't know what people are doing with labor. I want to do something different with labor because we can help labor a lot, especially training them, making sure they're OSHA certified, that kind of stuff, because with a shortage of labor, that means they're going to have people out there probably extending themselves beyond what they really know because they need to get jobs done. They were doing that before there was a shortage of labor. Okay, so things to think about. And last but not least, in part one, what kind of earth is being excavated? That makes such a difference, and for a lot of reasons. The type of excavation equipment you need, the method for which you will slope and secure the earth from cave-ins. That is, well, you're just not going to go out there and dig up dirt. And now, if you take our excavation class or available on Mondays when we teach it, you will see the different types of soil, and based on the type of soil, how it has to be sloped and all that stuff to keep it from, causing cave-ins and stuff, and the different methods of retaining the earth in its place while you work, like here, digging out sewage pipes or power, whatever, water pipes or gas pipes or whatever. So, all right, so that's going to be it for our Monday free presentations. Join us. That subscription is not very expensive for the what you get, and also I do have for all my students. You just sign up for office hours throughout the week. If the hour is available, you get it, and we discuss anything you need. So, if any questions regarding anything we went over, there will be a part 2. There are a lot more things to think about in excavation. And if you have any questions, please don't hesitate to email us at education@sfjohnsonconsulting.com. Look for interesting things throughout the week, and thank you so much. And I'll see you next time. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and I just wanted to notify you that we have now uploaded some more information on our free OSHA access for our FADO Focus 4 information on the caught in between and what is a caught in or caught between, the key factors, all the information, same information that you would learn if you were taking our OSHA class. So you would just go on into the Focus 4 link that's there, and then now you can click on the caught between. There's a video from OSHA, nice little video, and then all of the hazards. And at the bottom, there's the prevention training link, and you can click on that and continue forward. So if you have any information that you need specifically, please email us at education@sfjohnsonconsulting.com, or, enjoy the link and tell all your friends. Talk to you soon. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and I would just like to invite you this morning to join our live services. We have greatly reduced the price now through the end of the year because I don't know if you know, I have a nonprofit organization that assists young kids and young adults in a lot of different ways, in terms of education. And our goal really is to help young people get into the area of construction. But also, I do a lot of motivation kind of stuff and to help keep them out of trouble, and a lot of things to think about on a more spiritual level. So, our live presentations now will be, if you'd like to join, and they have stuff like Patreon and all this stuff where people, pay a small amount to join and get exclusive content. And for our reason, and we may keep it this way, 100% of our monthly fee from my for-profit for this service will be going to my nonprofit, which is SF Johnson Family and Community Services. So we will present all of our presentations by audio only on YouTube, but you are more than invited to join our live audio and video presentations by joining on our website, sfjohnsonconsulting.com. You'll get exclusive go-to-meeting log-ons where you'll be there live with us. You can ask questions if you have any. Only respectful content will be invited. Everybody else will be cut off because this is, as you know, we need to try to get together and help each other. And there's nothing more important to me than taking all of the gifts that God has given me through mistakes and just good luck and passing those things on to others. So we hope you will join us. You can sign up again. It's $9.99 a month. There's no obligation month to month. You can sign off with no problem. We'll give you a lot of good extra stuff that we provide for the nonprofit for joining us. And again, 100% of that $10, right, per month goes to us rewarding our volunteers for helping us, and now with the holidays to help get some food out to families in need. So please join, and remember, you can still listen. You'll have our audios here on YouTube, but we hope you will join our family both here and on our nonprofit as we try to make a really good difference in the world. This stuff is given to us for free to do good with. So I hope you understand, and I hope you'll join me. Thanks a lot. And by the way, our first little trial is this electrical project that actually is an emergency and it needs to be completed by tomorrow. So we will have all of our live presentations at 8 a.m. Pacific time on, again, you have to sign up and then you'll get access to all of our GoToMeeting class logins, and you'll be able to ask questions and all that for the full time that we are doing any of the estimating. So, and two, if you would like to see a specific trade, because as you know, we can do everything. Our electrical, we have a ton of electrical clients, so we always focus on a lot of electrical. But if you have something you want to see in general, and I do try to cover the whole specifications book, just let me know, because yes, we will be presenting something, and that will be every day, Monday through Saturday at 8 a.m. Pacific time on that link. And here, again, audio only. So thanks a lot. We hope you'll join us tomorrow at 8 a.m. Pacific time. And so we can get this one done. This is a nice little Camino is the name. It's a restaurant. Restaurants are always fun because you got a whole bunch of extra stuff. It's a 2-story restaurant. So, we got to figure out where our lighting conduit, how we're going to run it, and what everything means. And you watch me enough, you'll be able to do these with no problem. And now you can ask questions once you join. So thanks a lot. Have a wonderful Wednesday. Today is October the 5th on Wednesday, and we hope to see you tomorrow. God bless you. And you, and you, and you, and me, and us. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services. And I just wanted to invite you to visit our website at sfjohnsonconsulting.com, where we have activated a link here for our daily 8 a.m. Classes for Friday, this Friday, the 7th at 8 a.m. We're going to be going over the WBS, the work breakdown schedule, but we will be doing it per trade every Friday at 8 a.m. So I want you to go there, take a look. There's some useful information there. The WBS, what it is part of project scope management, gives you some terminology here, all for free. And the information here, our little spreadsheets. And then in terms of what we did here is all of the portions of our project scope. These are all of the things we need to think about. And number 3 in particular is the work breakdown structure or the schedule. And so what we're going to be doing is we're going to break it down for each of the trades. So for the electrical trade, what comes first, what comes second, because that is all a part of your project schedule. We'll be able to use the Gantt chart once we break it down. And then there's some useful videos here on the Gantt chart, and then some forward and backward pass. And so we hope you will join us every day at 8 a.m. Now that is a subscription service. It's $9.99 a month. You will not be disappointed. You'll be able to ask questions and bring some of your own work, and we'll be able to help you out with it. So any questions at all, but please visit our website at sfjohnsonconsulting.com, and we hope to see you soon. Hey guys, Stacy with SF Johnson Consulting and Construction Services. Again today on the 5th of October, someone told me that I need to have 10 times as many, at least by now, of these videos recorded. And you know what? It takes a while to learn how to do something, right? And then it takes another while to not get burnt out on it. And so, yes, I have a wealth of knowledge by running this business for now 13 years that I should have had on YouTube type platforms, both for this and for my nonprofit. But, you know, is no time like the present. And so what I want to go over today is just to kind of have you in a certain mindset. Every Friday at our daily live classes that you do have to sign up with, and then you'll get a GoToMeeting invite where you can ask questions, join live, all that stuff, have breakout rooms where we discuss all kind of topics depending on what information you want to know. I want you to think about how to think about the WBS, the work breakdown schedules, right? Because if you're going to do a good construction schedule, you have to, every part of, and this is part of our project management series or whatever you want to call it. This fits in a lot of different places. If you're like a sole proprietor contractor, right? Your mom and pop electrician, well, you need this as well, because you need to be able to, when you present estimates to your clients, the homeowners or whatever, you need to be able to have an accurate way to break down the project and show how long it's going to take. And two, when you are dealing with a general contractor, on another hand, and you should be able to do this, each individual trade should be able to do this. And of course, the general contractor should be able to do this. That's the only way that they put together the construction schedule, right? Is to be able to take every scope of work from the site work all the way through the final cleaning, know how long each operation is going to take, and know where critical points are, right? Where these things have to be done, finished, in order for me to continue and not lose money, lose time, whatever. All right. So you have to be able to look at your estimate and determine how long something's going to take. So that's why I always stress it requires that you have a construction based cost book because they give you the cost units like we show here. We always show in our sample estimates. Cost unit is how long something's going to take to do one of whatever it is. So in our case, we have a 3 5/8 inch 18 gauge stud. We're going to be placing at the 16th. Okay, so when we see that, that includes everything it takes to put a stud. So that includes the top plate, bottom plate, nails, da da da, whatever. Okay, just like the gypsum board includes everything it takes to install 1 square foot of gypsum board. Okay, so that's what the cost units are. So if you have a good cost book, you know how long a 1 unit's going to take. And then if you have a good construction software, whatever, estimating software, then you know if you have 3,888 of them, you know it's going to take you 97.20 man hours. Now, what's that mean? Man hours. That's if a man hours, that's hours basically, right? Now, we don't care that you can do it slower or faster. More importantly, you can do it faster. You wouldn't want to say, "Oh, I'm not doing it that fast." Yeah. So we don't care if you can do it faster, right? We just say this is how long the construction industry says it should take you. And so again, we know how long the whole thing takes us. And so where do we get to the work breakdown schedule? Well, now you are going to have to produce a construction schedule for yourself based on your scope of work. And so you have to kind of think, and this is what this video is all about, is the mindset that you take into producing a work breakdown schedule, or being able to look at someone's, or being able to take a whole project and break it down. And Google's there, right? So if you need some help on what comes first, what comes second, if it's not your scope of work, right? Like a general contractor, most of them probably haven't done every scope of work, everything on their estimate in their project. So yeah, they probably have to go to somewhere, some construction site, and see what the logistics are of placing the concrete slab. What comes first, what comes second? That's out there, trust me. Okay, so if you're doing this, for instance, this is the framing and drywall, and everything that's related to installing the framing and the drywall for this takeoff, because we already did the takeoff, right? And it's put on the Excel spreadsheet, and we're producing now our cost estimate. Well, in terms of the breakdown, what comes first when you build a wall? Well, the framing, right? And so you'll break this down even more, right? Because you gotta put the framing up before you put the drywall up, right? And so you can take out all of the framing operations, right? Which basically these two, I'm sorry. The one at the top of every P30, that's just the wall, how many linear feet, right? So you can take those out of this full estimate. And now, for instance, now you have this same thing, but just for the framing. So what is for the framing? What do we do? And we already know how long the framing is going to take because we already have it here, 97.2, and then 58.37, and then 7.17. And then we could break that down even more per type, stud type, whatever. Okay, and then that's the first operation in drywall framing. For me, if this was me, my company, okay, so I took out all the framing because I have to frame before I can put the drywall up. Doesn't this just make sense? And so no matter what you do, that's how you produce your W, work, breakdown, right? Schedule. Just like with concrete, what do I do first? Well, I'll probably have to form it out, and I'm not in charge of excavation and grading, okay? That's believing, right? I'm not in charge of that. I'm just the concrete person. So what do I have to do? It's already been graded. I'm ready to go. Step one, I got to form it out. So I'm going to pull out all my form work numbers. And at some point, everything just kind of what's next. And then, so your construction schedule basically for your particular scope of work would start with, for the framer, start with framing all the different types of whatever. And then you have an idea. And then we can go to the next phase, right? Because before you can do the drywall, you got to finish all the frames. So what your critical point is. Well, I have to have all of this done. Now you go back And because somebody has a bigger scheme of this, okay, your job is however many man hours, but what if they need you to do it in half the time? Your man hours say 45. Well, they need you to do it in half the time. They need you to do it in 30. Well, you just have to have more people because it's per man hour, right? Each man or woman should be working an 8-hour day. So every person that's involved in that is chunking out 8 hours of your full man person schedule. Okay, so when you think about your WBS, your work breakdown schedule, you have to think in terms of, okay, first of all, you have to do a complete estimate to know this is how many man hours for my full job. Okay, now then you go through each of the individual scopes of work and you break down. I'm the framer. Of course, I have to frame if I'm framing drywall and caulking. Well, I have to frame first. And then you could go even more anal and say, okay, when I'm framing, what am I actually doing? Okay, bottom plate. How long is that going to take? Because, again, a good assembly of whatever, assembly hour, man hour should include each individual operation, should be the composite of all the individual operations. Just like I said, the 3 5/8 core stud at the 16. It's like my 6th video today. And not to mention the couple I forgot to press play and record. All right. So remember that no matter what you do, if you're the painter, what's first, second, third, how many man hours, person hours is it? And it makes it very easy. And so if you go to our website, we have the WBS, look on the safety lane on our homepage, sfjohnsonconsulting.com is on the right. You go down a little bit, you'll see WBS. It's a link. Click on it. Gives you all the basics. Gives you a couple videos on a construction schedule, forward pass, backward pass, all that good stuff. And then sign up now that we've reduced our price to $9.99 per month. Join us every day, Monday through Saturday, 7 a.m. on Saturdays, but 8 a.m. all the other days. And did I say Monday? No, Tuesday through Saturday at 8 a.m. But Saturdays are 7 because we want to go home early. All right, so thanks for joining me, and please join me every day. And if you have any questions, please email me at education@sfjohnsonconsulting.com. It is Wednesday. Have a wonderful rest of your week. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services for electricians only, and I just wanted to present a little demonstration here from a plan that we're going to be going over in our live session, which we hope you'll be joining us with this project. I noticed when I do the conduit or the electrical wiring that's not the home runs, it all depends on how your work is presented by, the electrical engineer that produces the set. And so what I want you to notice here, and that you will notice on your own, and really just take a minute to look and see how they show all of the different outlets and which panel in the position and how they represent it. So you'll see some of these, you'll see some of the outlets. You see that there's no home run next to it or connected to it. But then you'll see that some of the outlets have the same position in the panel, right? So that tells me, and for the purpose of my takeoff and what I discussed with my electrician, is that, okay, I'm going to assume that all of these are together with MC cable, all of the ones that are of the same, going to the same position in the same panel, okay? And even though at the end of it, so I'm like, okay, I should have one that has a home run. So I know, okay, that's the end of it, it's going to but we don't have it. There's no additional anything showing me PP1A-27 with a home run. And so what I have to do and what you'll have to do if you get any that are like this, you're going to have to go through and look for ones that are going to the same position on the panel, connect those as best you can, like I did in all of these cases, right? Here, and we got one that's different here that's not connected, but I know it's not. And then this 12, PP, it's been a long day. PP1B/12. I don't see any others PP1B12 outlet anywhere. So I'm assuming, okay, well, that's a home run to position number 12 all by itself, because there's the 13. And this did kind of help me out by putting the 13, 12, 54, 24, 25 next to each other. But there, and then, okay, and then I went, okay, PP1B12, that's a 10, no. And then I saw this one way over here. Wait, where? 12, where did I see that? See, it's not even the same. Well, it was a different 12. It was a A12 or whatever. So I'm like, okay, well, that one must be home run to the position on the panel all by itself. Okay. And then one other thing, you know what you'll have to always do, and I hope you join me every day so you can become an awesome estimator. Okay, so remember you have all the panels, and this is the main distribution panel. Well, some of these panels are on the second floor, some of the panels are on the basement. And so the length of the feeder has to incorporate that. Remember, the single line or one line diagram never shows you the actual, it's not to scale, so it doesn't show you the actual position. So remember, this is a 2-story. Well, PPB is here, main distribution panel is here, so I'm going to have to measure this distance, but then the other panels are on the second floor up here. So I have to visualize in my mind that the main distribution panels were approximately right here, right, on the first floor. So I have to go up 10 feet, I'll give it 15 feet going up the wall, and then over to each of the panels. So that's the tricky part. That's the part that you never want to forget, because that power feeder is very, very, very expensive. So make sure to join me every day, Tuesday through Saturday, Tuesday through Friday at 8 a.m. Pacific time, and on Saturday at 7 a.m. Pacific time for SF Johnson Presents Live, where you'll join me live. You'll be connected to our GoToMeeting page where you will all be there together. You can ask questions, you can bring your own content, and we can have a lot of fun learning together. So electricians, you know, every set of plans is different, but what you want to do is have that same approach no matter what, and you'll never go wrong. All right, see you next time. Hey guys, thanks for joining me. This is Stacy with SF Johnson Consulting and Construction Services, and thank you for joining me on our first episode of What Form Will Get You a Violation? Well, I'm noticing on our sites and who's watching what stuff. And, you know, if you are watching any of the construction videos, you're probably in construction. So the fact that I get a lot of views on the construction stuff and not so much the safety stuff lets me know that, you know, there's not really a safety culture out here, right? And so, you know, that's fine. Until you get hurt, then you understand the importance of a safety culture, or until you get a fine or something like that, you'll understand. But all I can do is make you aware of what you do need. So we have a new series called What Form Will Get You a Fine? So at any time, OSHA could walk in and ask you for any of the following forms. Are you ready? No. So we're going to start with number 1, which is the facility layout. Now, these numbers here are the standards, right? And because OSHA is a part of the Department of Labor, and they make these standards, which basically are laws. And anytime you, as we know, you don't follow a law, or some of us don't follow a law, you have to pay the price. And so OSHA thinks that there are a number of forms and things that you have to have if you're doing your job and keeping your employees safe. And so we just want to give you a little information about the form that will eventually get you a fine if you don't have it and on your at your job. Okay. So first, there are forms related to the facility layout, and we've given you information. And there's also a link there, and you know that you can sign up for OSHA Live at our website for free. There's no charge unless you want to get a certification. Then yes, there's a charge. And all of the red links are active, so you can click on those and look at the information for free. And now you can also, and eventually we'll have all of these filled in with a nice example of what they are. And so for general industry, the standard is 1910.22. For the construction industry, the standard or the law is 1926.752. And so we'll look at each one. So this is the 1910.22, occupational safety and health standards, walking and working surfaces, general requirements. Okay, so this basically says that you have to have a facility layout, and your facility layout should be for general industry. Surface conditions. The employer must ensure all places of employment, passageways, storerooms, service rooms, and walking working spaces are kept clean in a clean, orderly, and sanitary condition. Maintain free of hazards. The floor of each workroom is maintained in a clean and to the extent feasible in a dry condition. Okay, and what's required when there are repairs. And so, how do you get a violation for this? Well, this is telling you about how your facility in general industry, no matter in general industry, is wherever people work. So if they walk in and they see stuff all over the place, and that is not, the working surfaces are not maintained free of hazards, such as sharp protruding objects, loose boards, just like everything you'll find in a warehouse anywhere. Okay? It'll get you a fine if they show up. And so they're telling you have to abide by 1910.22 if it is for the general industry. Now, the next one, 1926.752, safety and health regulations for construction. Site layout, site-specific erection plan, and construction sequence. Okay, so it talks about steel erection. So steel erection, even with, I'd say scaffolds would qualify, right? For that site layout, the controlling contractor. That's where people get sued. Oh, I'm not the controlling. Everybody gets sued. But yeah, the general contractor is always going to get sued. So it's up to them to make sure, that they keep everything well maintained. Adequate access to roads into and through the site for the safe delivery and movement of cranes and trucks, and that's very important. A firm, properly graded, drained area. So all this, you'll find on your site plan. Pre-planning of overhead hoisting operations, site-specific erection plan where employees elect due to conditions specific to the site to develop alternative means. So you can do alternative means, but it has to be approved based on the guidelines. Okay, and so typically, you have to do these things, but you also have to make sure you have something in writing, okay, that shows that you are doing these things. It has to be some kind of form, some certification, okay, that everybody knows that these things, based on your facility, are being adhered to. They understand you're abiding by all of the laws based on OSHA standards. So if you have any questions or concerns at all, would like to take an OSHA class live and online, please contact us at education@sfjohnsonconsulting.com. And we'll see you next time, I like this one. Let's go back to that one. The next one we'll go over are the logs that require, if there's an injury at the job site, there has to be a log for people to see it. First aid kits, always make sure that's there. So again, they walk in the facility and they don't see, or they see any violation in 1910.22 or on the site, any violation of this one, you're getting a violation, you're getting a citation. So, questions, concerns? Email us at sfjohnsonconsulting.com, and that would be education@sfjohnsonconsulting.com. And we will see you next time. Don't get a violation. Hello, and thank you for joining me. This is Stacy with SF Johnson Consulting and Construction Services, and today, right now, we're going to go over some terminology for our project scope management class. And keep in mind, we do teach this class specific to each of the trades. What we're seeing here just happens to be for concrete pros, but all of the concepts in terms of the terminology in this case will be the same. Okay, so again, what do we think about when we think about project scope management? Okay, so for any professional, regardless of concrete or otherwise, project scope management involves three processes, no matter, the trade, and they're as follows. So the planning process. Okay, so in the planning process, again, the project is defined, and all of the processes required to make the project come alive are planned and detailed in that process. Okay, so in the planning process, the controlling process, this involves the tracking, managing, and monitoring of the activities, and then the closing process. This is the last part of the project process where we include the audit of the deliverables and looking to see if our result came out as we initially planned. And so, again, we're going to break this class up into about 6 or so, or maybe more depending, individual videos where you can review each one individually or go back and review them as we take the class. But here we just want to talk about some important terminology that we want you to certainly remember and make sure, you keep in mind when we're talking about talking about some of the subjects related to any of the project management courses, whether it is schedule management or integration management. A lot of all of the terms apply. So in this case, because this is project scope management, specific to this topic, the project scope. Okay, so by definition, it's the work that will be involved in order to deliver the project. The project scope is defined by the following. Okay, so these are the things when we set out to create our project scope, we want to talk about first, what are the project objectives? What are we doing? Are we building a home? Is it a commercial building? Is it, whatever time of, it could be a number of things. Okay, so, but we do have a sample scope and a sample charter that we'll look at that'll give us good details on how to follow that, and then be able to create our own. So, 2, second portion are the goals. What are the goals specific to the project? And then 3, what are our sub-phases? So in terms of a commercial construction, we could be talking about the, site work phase, and then, the actual building the building, and then finishing it off, and then prepping it, or, the punch list. So what are the phases that we're going to break the project into? And then the task, number 4. And then 5, what resources? What are the contractors that are needed? What are the trades that are needed? What is the equipment that's needed? what money is needed. What do we need? Loans, that kind of thing, in order to make it happen. And then the budget, of course, how much is the full project going to cost? And then the hardest thing, I think, for most contractors, where we'll try to make it a little easier piece by piece, is to create a schedule, or the schedule from not only for the project itself, but for the planning stage all the way through our 3 processes, right? All the way through. Our schedule related to planning, controlling, and closing. Okay, stakeholders. Who are the stakeholders? Anyone involved in winning or losing, basically, in this project. So a stakeholder can be the owner, right? Or the insurance company, or an investor. All right? Anyone who has an interest in the process or the outcome of the project. So pretty much everyone involved in this project, in one way or another, you can think of them as a stakeholder. Even the contractors that are performing each of the scopes of work, they're a stakeholder, because why? They want to get paid at the end of it, right? So WBS, we have a separate video for this, but this is our work breakdown structure. Breaking the project into phases, and then from those phases, we're going to break it into subphases and into scopes of work by the end of all of that. So all of the individual scopes of work create the work breakdown structure. Okay, and so it's important in order, trade by trade, in order to understand how to break down your trade, right? So that's why we do it for the contractor, for the framer, because depending on your scope of work now, your breakdown is going to be a little different. All right, construction milestones, we all know what that is, but those are dates that absolutely something has to be completed, right? So then we use our Gantt charts in order to see our schedule and forward pass, backward pass, all that stuff, to see what dates, what times, when do we absolutely have to have something done, because if the foundation isn't prepped, we can't drop the new walls or something. You know what I mean. I only do it from a desk, okay? So, deliverables. Those are tangible objects. So the foundation, the full house, the driveway, the whatever you're building is a deliverable. Okay. So I have examples. Include a report, the permit, or a new home. Okay. Statement of work. Should include a list of everything needed to create the framework of the project. Okay. Everything needed in order to create the framework of the project. Okay, so framework is different than the details. Okay, framework of the project including project goals, deliverables, features, functions, tasks, deadlines, and costs. Okay, scope of work. Now we know what that is. That's what we're familiar as contractors that do the work. It outlines the work to be done. Okay, details the deliverables, timeline, milestones, and reports. And here's scope creep. Okay, so basically, your scope moves along, because if you have your project schedule, right, you want everything to go TYP, right, typical. You don't want any drawbacks, setbacks. So, scope creep is what happens when you have setbacks and your scope just keeps moving on. We got an extra week, we got to move it up, or got to move it back. Okay, so we want to prevent that. The process of getting off schedule at some point in the project. Okay, this is what happens when the project's not being managed, basically. Okay, so there are ways. You have to be pretty much a construction Karen to keep your project. But again, somebody's paying you to keep it on task, to keep it on budget. And so you want to avoid scope creep at every possibility. Construction risks any threat to the process of completion of the project. Right? So we always want to do a risk assessment when we know what we're going to do. All right? You do that in life, okay? You do that going to Walmart. Let me do a risk assessment. Where's the exits? Okay. Look way in front of you. So what could I be talking about? Know what your possible risks are when you are doing anything in life, let alone the project. So any threat to the process of completion is a risk. And then a mitigation strategy. Like I said, going to Walmart, you want to know where the exit is, okay? So mitigation strategy is reducing the probability of consequence of an adverse risk to a satisfactory threshold. Okay, that's a lot of lingo. But basically, you want to mitigate in real terms. Say, for instance, your roof blew off and blew a hole, or a tornado, right? And your roof came off. Well, you're going to mitigate the damage by going out and putting a tarp on the roof, right? Because if you don't, additional water is going to come in. You're going to cause more damage to the interior of the home, blah, blah, blah. That's mitigation. And so you want to know in every step, if this happens, what do we do? You want to always have a strategy. You know, I'm sure there are GCs that don't do it this detailed, but, you know, if you want to make big money and control substantial amounts of money in terms of construction, you got to have these things in order, and you have to know, at least, you know, have a plan. And then the scope management plan itself, the processes that are in place to make sure the project includes all the necessary tasks. So this plan is concerned with dealing with how the scope is explained, developed, structured, and verified. Okay, so those are the important parts of that. Is the plan helps us to do those things in the end. How are we going to explain it? We're going to develop it. How we're going to structure it, and then how we're going to verify that the things that we have planned are actually done. So, project scope management involves all of these things, okay? And so, plan, scope management, the process of creating a scope management plan that documents how the project and project scope will be defined, validated, and controlled. Okay, so collecting requirements. These are all part of what is necessary in order to build your full scope. Okay, and again, most contractors they're narrow in when I say scope, they only think scope of work. Okay, but no, this is the process, okay, that documents how the project and the project scope will be defined, validated, and controlled. Okay, so collect requirements. These are the things you have to do. The process of determining, documenting, and managing stakeholder needs and requirements to meet project objectives. Okay, so this is typically just supposed to be terminology, not the full class, but this is part of what we do in the full class, is go over each of these and how do we go about determining, documenting, and managing stakeholder needs. There are specific tasks in each one of those processes that we can break down even further. Okay, but in general, collecting the requirements is the process of that. Okay, defining the scope. The process of developing a detailed description of the project and product. Okay, create the WBS. Okay, that's the biggest, most challenging part, because we know we have to build the wall. We can even determine by the cost estimate how many days it's going to take. But then when we have to integrate the rebar with the masonry with the concrete truck, and you know, how do we break all of that down in a way that we can translate that paperwork into actual people coming and going and things being done in an efficient manner. Okay, so the first part of that is to create the WBS, which is the process of subdividing project deliverables and project work into smaller, more manageable components. So, right, if we're going to basically your scopes of work create your WBS. Okay, and we create our scopes of work by breaking down our construction documents, right? Doing the takeoffs, the cost estimates, because once we do the cost estimates and we do all that, we know how long each individual process in our project. And now I'm specifically talking about building the building, but there's an amount of time it is going to take also to write up the contracts for all of the contractors. So that is part of this. There's the amount of time it takes to order all of the material if you have a national supplier. That's part of this. Okay, so define scope. WBS validate scope. What's the process? These are all like, okay, these are things we have to do. So what's the process that we're going to use in order to do it? And again, to control the scope. What's the process that we're going to do? The process of monitoring, how we're going to go about doing it. Okay, so these are all larger items, right, that we are creating a process for. Okay, and in our class, we will have a sample scope management plan and a sample of everything to go over that. So, 7 steps, okay? And these are the 7 steps that we're going to be going over in the next video. But again, this is our project scope management plan, part of our project management series. I am Stacy Johnson, the owner and operator of SF Johnson Consulting and Construction Services. Owner and operated since 2010 for your approval. And most likely disapproval sometimes because I'm smart. So, join us next time. I probably could have left that part out, but I really do enjoy teaching people from everywhere. And as a matter of fact, people listen to these videos from about 8 different countries. So I'm very pleased that I am helping people all over. So let's join together for the next class where we're going to discuss the project charter and the 7 steps to making a scope management plan. Thank you very much, and visit us at www.S as in Sam, F as in Frank, JohnsonConsulting.com. See you next time. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services here for HVAC only, where we're going to just discuss a small HVAC job for our coffee house and how we would go about doing the takeoff, because we are going to complete the estimate. And so first step is always reviewing what you're going to be doing the takeoff for and beginning it. This is small. We have 1 air handling unit, 1 condensing unit, 1 exhaust fan, and all of the pretty much the grills that go with it. Supply grill 1, supply grill 2, and return grill 1. And so it's pretty simple. What do we need to do? We need to be able to determine the type of ductwork and all of the straight runs, if they are dampers, and knowing what type of damper. Is it mechanical damper that has an electrical component, or is it just a manual damper? You're going to look in the specifications, and that would tell you. Looks like these are manual dampers that are intrinsic to the grill, so you don't really have to worry about it. So when you look at your cost book, which we'll go to really quickly, because we always have our handy cost book to know how we are going to price something or how the cost book represents it, so we'll know what the labor is. So let's go to grills. I like to call them diffusers, because then you know you're going to get the right thing. You know what? You're not, because I need to go to my plumbing cost book. So I'm going to open cost book, and I'm going to go to this year for plumbing, because that's where the HVAC is for some reason. And now I'm going to go to diffusers, air balancing. All right, so CFM, cubic feet per minute of air, and so gives us the price. And grills, return air grills, and this is just the labor. Actually, the labor to put in one. It's not the material cost at all. So if they're being provided, that's what you'll use. And let's get some pricing for them. There we go. Yeah. So four-way adjustable pattern ceiling diffuser, 24 by 24 with collar and volume damper, steel construction. If it has an 8-inch neck, this is the price all the way down, but more importantly, because we always win. Why do we always win? Why do my clients always win? Because, first of all, we're winners. Second of all, we know how much the construction industry, how much time it says to do something. And so our estimates are always very tight and very competitive. And that's what you need. That's what you need. You need a very good takeoff software, right? That we also use, that we do our demonstrations on. Digitized software, so you'll know exactly how many linear feet of something that you're doing that you have now. How this configuration right here usually means the spiral ductwork, this broken line where this is just I'm sorry, flexible ductwork, not spiral. This is spiral ductwork because it is not giving us a dimension, unlike that's spiral ductwork. It's not giving us a 12 by something, 10 by 12. That's a rectangular ductwork. So I know that all of this is spiral or round ductwork. Oh, here we go. Like I said, I always review it when I review it with you, so I'll be surprised, just like you. And I don't want to be too familiar with the sets of plans before I review them for you. So these are rectangular ductwork. This little piece of it, it's a 20 by 12, and it's always inches, right? 24 by 14. And those are return grills as well. Yeah, R1. And this is the CFM number. They always, or at the grill, they usually give you the CFM, meaning how much air do they want coming out of the supply grill. But it doesn't. And it must somewhere. Okay, it has to somewhere. So we would know how to balance the system. Okay, so first things first, always going to scale it. Yes. And so we have a bunch of different sizes. And so for this, I'm just going to go through this 18-inch. And then what we don't see here are, wait, let's see if they show us. Yeah, that's all they give us for, they don't give us a, like, that's plumbing. That's all they give us for mechanical, huh? No, oh, there we go. There we go. Okay, so what we see on the plan is the horizontal measure. Okay, and this represents spiral ductwork because you're allowed to use a certain length, 3 feet, 5 feet, to connect the metal ductwork to the supplier return grill. Okay, and so it's the flexible elbow, flexible duct. And then all the clamps, right? And then the clamps. So these are things that have to be noted in the takeoff that you don't see on the plan. So, every time you see that we have a grill, a diffuser, air supply grill, whatever you want to call it. And we have to always make sure we include the flexible ductwork, the 90 degrees flex, all the flexible ductwork up to 5 feet. Might as well just do it that way. And the connectors, and the grill. And then sometimes it may have a reducer. So you may have to go from 18-inch to 16-inch to 12-inch. It's always some case somewhere. So you always have to be aware of the pieces of your takeoff that you don't see on the plan. Let's go back to the plan. What you don't see on the plan. Right? You don't see it on the plan, but you know it's going, X means going down for HVAC. Okay. And so, yeah, you got to account for all of that. Now, let's go back to cost book. So you have to know the neck size, right? The neck size is the size of the spiral ductwork that's leading into the grill. So it may be 8-inch, 6-inch, 12-inch. It all depends on the plan. All right, so this next size would be what? 12-inch. I believe they're all 12-inch. See, the next size doesn't apply to this because there's no grill going to it. Yeah, I think all of these are. See, it's making you guess. See, now you have to have good eyesight because, yeah, this 14 looks wider than this 12. So, but does this look like a 14 or a 12? That looks like a 14. That looks like that goes with that. So that next size most probably is a 14. Bad sets of plans when it doesn't tell you everything. Or it may in the notes. You know, I got to look in the notes. It may tell you. Let's see. Thermostat programmable. Provides 6-inch exhaust duct through roof and terminate with roof. Okay, that's note number 3. See, well, yeah, that's this one. 6-inch. So it does tell you, and it's going up. It's telling you for the exhaust fan. Actually, it's going down from the exhaust fan to the outside. So it's going up. That's bad too. Just out of nowhere. See, so you got to have a lot of experience on where's that going? Where's that coming from? Okay, but the notes are supposed to help you. Provide through roof. Okay, so roof cap, I'm just going to give the 90-degree angle, so it'll turn and go up, right? And then 10 feet of that, just for that. And then the cap. All right, so there's a lot of hidden stuff you don't see, but you have to account for. Sorry, with all the going back and forth. All of that. 5, 6 is probably the condensing pipe. 6, but that's the plumbing scope of work. So the plumber, that would be something that the plumber would be. It would be on the plumber's estimate. I mean, it could be on the HVAC estimate, but not. It should be a separate portion of the HVAC because the pipes that run the condensing pipe, it is a plumbing scope of work, even though it's used for the mechanical equipment, just like the electrical to power it is an electrical scope of work, and they don't show the power to the rooftop unit or the air handler, but we know it needs power. So that would be on a separate set of plans, a separate estimate. So everything is broken down separately based on scope of work. Okay, so that's pretty simple. That's all we have for the HVAC. So we're going to do all the measurements. So in this case, this looks like maybe this is a 6-inch. It's not really noticed very bad, right? You can tell that's 14, but is that also a 6-inch? It looks like it is. So what I would do, just show you a little takeoff. Did I already do the scale? Yeah. And so this is bad. Okay, so this comes with a couple components. So I have the 6-inch, which is the straight portion, which everywhere I have a straight portion of 6-inch. And then I'm going to say that, I'm going to say maybe this is a straight portion. You see how anal it gets? But if you're good, and this is 6-inch. We just put it all the way through. And these are all those connectors I'm telling you about. And this is some kind of adapter that goes from a 6-inch round to whatever the exhaust fan has as the connector. Okay, so, and then now, because we have a couple of things, and this is just what you normally have to do. 6-inch, 90. Because, yeah, in the cost book we have 90s, 45s. So that's the 6-inch 90. And let me add another one because remember, oh no, that's flex. Going 90 degrees down to, because basically the supply grill's in the ceiling, right? And then the ductwork comes up in 90 degrees up and then into this system. Okay, and so what we also need is a 6-inch 45. That's that one. And then what we're going to do is just say 6-inch flex, and we already know we're going to use the 5. Let me just measure this just to make sure. I'm not going to call it anything. I just want to measure it. Yeah, so that's 2.5, 2 feet, 2 inches. So what I'm going to also say for every supply grill, I'm going to say, oh no, because this supply grill is going to be different because the flex size is different too. So 6-inch flex. And I already know it's going to be 5 feet, but I'm going to put on here. Oop, go back. I'm using one eye in my glasses and the other one out. 5 linear feet. That won't work this morning. All right. So that's for that's for this one because I know that's 6-inch. And that's a 6-inch. I need a 6-inch grill too, right? Because 6-inch 2 by 2, just like in my cost book, but this next size is going to be 6-inch. So let's go back to the cost book and see how much that is. Where'd it go? Here we go. All right, so we want that one, this one. 24 by 24 with collar and 6-inch. So that's going to be $90 for that one. We just that one we're dealing with. And how do they figure out the labor? This is the man-hour rate, so 0.35 of a man-hour it's going to take, right? Just over 15 minutes to put that in there. It's $90 each. So if you have, and we had to go to the other ones because I think we had up to a 14-inch neck, so that one's going to be $127. And this is based on 5% based on, well, now, with this cost book, any cost book, really, if it's good, you got to put in the zip code of where the project is. And chances are this is based on the zip code of where our home office is, Sacramento. So no matter where in the country it is, I put in that zip code and it'll give me the local price for the grills up to 5, and the labor's not going to change, right? It won't take you longer to do it in California, at least it shouldn't, than in Mississippi, right? So the time it takes isn't going to change. The only thing that's going to change is the cost of the material. So that makes that easy. All right, so let's go back. So that's what we have to do for the whole thing. Or we got to do, this is such a crazy set. We'll just assume that this is a 14-inch. So we need the 14-inch here. So this is a 12. We'll assume this is a 12-inch. We'll do the same things here, but for a 12-inch as we did here for the 6-inch. The 45s, the 90s, 45s, the flex, the grill, because of the neck size. All right, so any questions at all, please email me at education@sfjohnsonconsulting.com. Please give me your comments on this. Please remember to subscribe to all of our giveaways, and we would love to have you as a student and as an intern and a continuing listener. Thank you very much, guys and ladies, and have a wonderful day. Hello, everyone, and thank you for joining me whenever that is. This is Monday, the 10th of October, and this is our next edition of What Form Will Cause You to Get a Violation, and we want to avoid that at all costs. So I hope your weekend went well. We have a whole new exciting week here at SF Johnson Consulting and Construction Services, where now our clients are receiving, we're going to watch NBA League Pass with us, our valued customers and clients and friends. So we hope you can also find a service that we provide that you can use. But right now we're going to talk about the logs that OSHA requires you have. First one we went over was the facility layout, the form, and what's required and what your facility should look like. That's what these all talk about. And then the next one is the OSHA Log 300. Okay, and there's a OSHA Log 300, 301, and 300A. And what those are required to do, and we'll go to the next page. those are our record keeping and reporting requirements. So if you go in this, we'll make sure we have the live links after.